Morning, Manas. Hi, Raman.
Hi, namaste, namaste.
Namaste, namaste.
Welcome.
Namaste, good morning.
Namaste, sir. Namaste.
Namaste, Dr. Jain.
Namaskar ji.
Morning to all.
Hi, Arnalok.
Nice to see you, Ravi.
Yeah, nice to see you too.
Namaste, sir. Oh, good. Where is that? Namaste, sir. Namaste, namaste. Dr. Aruna Loke Chakrabarti, Dr. Ravi, sir.
Namaste, Sare.
Namaste. Namaste.
Ravi, are you at home or?
Yes. At home.
Badama.
यार ने लोग
हाँ
ये हिसिकॉन लोगो लेंस के अंदर वायरस आ गए.
अच्छा
Normally it used to be bacteria or fungi. इस बार तो वायरस आ गए.
नहीं आजकल वायरस ही वायरस है. बीच में फंगस थोड़ा सा उत्पात किया फिर दोबारा वायरस कर रहा है.
Dr. Arun, good morning, sir. Sir, are you wondering how to share the slide?
I can share my slide if you allow me. I'll do the sharing of my slide.
Yes, sir. Sir, on your turn, it will be
Yeah.
automatically activated.
Okay.
No problem.
नमस्ते जी.
रमन तुम्हारा कैमरा को थोड़ा नीचे कर दो. तुम्हारा खाली आपको ही दिखाई दे रहा है.
अभी ठीक है सर.
It's now better. We can see your face.
Good morning, Dr. Sadhana. Good morning, Dr. Jain.
Hi,
Good morning, everybody.
नमस्ते.
Good morning, everybody.
Ravi is preparing the slides. I know. Oh, he has raised his hand. He is not preparing slides.
So good morning, all of you.
Good
Hi,
morning.
नमस्ते. Good morning. नमस्ते.
I am Dr. Hiba Sami, Assistant Professor in the Department of Microbiology, Jawaharlal Medical College, Aligarh. I bid a very warm welcome to all the esteemed faculty and delegates to the 17th Annual Conference of Hospital Infection Society of India. So beginning with the first part of the conference on antimicrobial resistance. Effective antibiotics have been one of the pillars for us to live long, live healthier, and benefit from the modern medicine. But as predicted by Alexander Fleming 70 years ago, drug resistance is upon us. So to discuss the same, I want to invite our first speaker, Dr. Balaji V. Raghavan, to talk on multi-drug resistant gram-negative bacteria, tackling the menace. So introducing Dr. Balaji Veeraraghavan. He's a professor in the Department of Clinical Microbiology, CMC Vellore. So he's a Global Infectious Disease Research Fellow in NIH USA and also an Indo-US Science and Technology Fellow at the Tufts Medical Center, Boston, USA. He has 369 published manuscripts in peer-reviewed journal. That is really a wow. So I invite sir to please take the talk.
Good morning, everyone. For the next 10 minutes, I'm going to talk about the multi-drug resistant gram-negative bacteria, tackling the menace. So underneath this topic, I'll be talking about MDR and XDR scenario in India and why we need to avoid polymyxin. And I'll be elaborating a little more on the giant killers, especially on Klebsiella pneumoniae, Acinetobacter baumannii, and Pseudomonas Acinetobacter baumannii and Pseudomonas aeruginosa, and then I will sum up. Current AMR scenario in India. So this is the unique profile, AMR profile observed over years in India. E. coli has got 70% ESBLs, and it's mainly due to 10 OXA1 and CTXM15, and 10% carbapenemase resistant is seen among the E. coli. The common resistant mechanism is NDM, which is almost 90 to 95%. It's New Delhi metallo-beta-lactamase, followed by 10% is OXA48 like, and then 2-3% NDM and OXA48 like together is there. And the colistin resistant among E. coli is only 8%. Moving on to Klebsiella pneumoniae, 60% are ESBLs. The enzymes responsible are SHIV10, CTXM15, and 40% carbapenemase resistant to Klebsiella pneumoniae. The most common is OXA48 like, alone 30%, and 60% is OXA48 like plus NDM. And these carbapenem resistant Klebsiella pneumoniae, among this 40%, 37% are resistant to colistin also. Moving on to the Pseudomonas aeruginosa, 25% of them produces ESBL, mainly web. And nowadays we are seeing, earlier it was not up to this percentage, now it's almost 25%. They produce metallo-beta-lactamase. This includes Vim, NDM, and imipenemase. Majority of them are NDM. Earlier we used to have a non-metallo-beta-lactamase carbapenem resistant, but nowadays we are seeing more of a carbapenemase producing carbapenemase resistance, and it's almost 5% resistant to colistin. When moving on to Acinetobacter baumannii, 80% produces ESBL, mainly TEM and PER, and 80% are carbapenemase producers, and majority, almost 100%, is due to OXA23/24 like. Among this 100% OXA23, 30% dual carbapenemase, where OXA23 plus NDM is seen. Colistin resistant is around 5%. So now it's time to move away from polymyxin. The evidence and alternatives are there. For many reasons, colistin needs to be avoided because of different units and for different dosages. And every time batch to batch variation will be there. That's why we call it a heterogeneous product with variability in strength and purity. And the old drug has got limited PKPD parameters have been done and reported. And of late, definitely this has been not recommended for lower respiratory tract infection. And it has got a higher nephrotoxicity and higher mortality. And it's challenging is the susceptibility testing. And you know the new CLSI guideline where it doesn't give the susceptible criteria. And during the therapy, resistance mutant selection happens, and it fails the therapy. Now I move on to the giant killers. What is the problem? What is the solution? Klebsiella pneumoniae, Acinetobacter baumannii, and as well I will cover the Pseudomonas aeruginosa. Klebsiella pneumoniae causes high mortality. The high mortality is mainly due to two factors. One is AMR and another one is the virulence. Now I will talk only about the AMR. The trend of carbapenem resistant in Klebsiella pneumoniae is predominantly OXA48, almost 100% or 90% OXA48. That in that 90%, 30 to 40%, along with OXA48, NDM is also there. So this is 100%, and here along with the NDM, another 40. Among this 100, 40% are NDM is there. And it's not the OXA48 parent enzyme which we see. We see one of the variant, that is OXA232 or OXA181, which has got a higher MIC than the parent OXA48 like. And whenever there is an NDM is not there, the porin loss is not much seen. Sorry, wherever OXA48 alone is there, porin is not seen. Wherever NDM is there, porin loss is also seen up to 50%. The good news is there is no OXA1 PP3 insert or KPC in E. coli. Hence, E. coli resistant is less than 10%, whereas Klebsiella pneumonia is more than 40% for following problem. And the Indian lineage is sequence type 231. High rate of AMR and virulence convergence is there, and mainly due to OXA232 and OXA181. Among the virulence factor, aerobactin and acinetobactin. So now I'll talk about the virulence. There are two types of pathotypes are there. Classical Klebsiella pneumonia, hypervirulent Klebsiella pneumonia. In the hypervirulent Klebsiella pneumonia, this is the virulence factor. And K1, K2, K5 are the types. Other than these three types, other 40 K types are there. The remaining are all multi-drug resistant, carbapenem resistant Klebsiella pneumoniae. So what happens is when this highly virulent Klebsiella pneumoniae fuses with the multi-drug resistant KPC, you can see this virulent plasmid gets fused along with the multi-drug resistant plasmid. That's this, a red ring gets joined with the green and the blue. So this fusion makes it a mosaic plasmid. So where there is a convergence of AMR and virulence. So this is a double whammy which causes severe infection and not responding to the treatment. And this is a global collection study where more than 13,200 Klebsiella pneumonia genomes across 99 countries were collected, and they have analyzed for the looking for the AMR virulent convergence. And very interestingly, what it shows is, you can see here, majority, all the red are resistant. When the resistance is there, virulence is missing, that blue color is missing. So in very few sequence type where the virulence and resistance are seen. Maximum virulence and maximum resistance are seen in India with sequence type 231, which is predominant in India. In no other country, sequence type 231 is seen to the extent seen in India. That's why I've written as India on top with the ST231. So this is the short story. So definitely this is the major reason why the high mortality of Klebsiella pneumonia in India is due to hypervirulence and multi-drug resistant convergence. How do you manage this? If it is only OXA48 like, you can manage easily with the ceftazidime avibactam. If the OXA48 plus NDM is there, always NDM is accompanied by default outer membrane protein K35 and 36. So this combination constitutes about 60%. When these three combinations are there, then meropenem bobarbactam, imipenem relibactam, ceftolozane tazobactam, cefepime tazobactam, none of these four will work. However, aztreonam avibactam, cefiderocol, cefepime ziribactam, tigecycline/colistin will work. These are all the choices. Unfortunately, except tigecycline and colistin, other three drugs are currently not available in the market. And tigecycline colistin doesn't give consistent result. So really, we are in an unfortunate situation. This is a rare situation where without OXA48, like only NDM and outer membrane protein K35 and 36 is there. This constitutes 10% of the isolates from the patient. Here, definitely ceftazidime avibactam and cefepime tazobactam may not work. What will work is cefepime taniborbactam. That too, it will take care of only 70%, but still it's in the phase 3 trial. Moving to the next, I'll just skip off because KPC is not available in India. I'll skip this slide. Now I'll move on to the Pseudomonas aeruginosa. You need to understand there are two important types out there. That is metallobeta-lactamase producers, and another one is non-metallo-beta-lactamase producers. Unique to India is the metallo-beta-lactamase producers. This is always accompanied by efflux, porin, and the inducible AMPC. So this is 70% in India, whereas in Western countries, they don't see the metallo-beta-lactamase variant. They usually see efflux, porin loss, and the inducible AMPC, which is only 30%. In India, it's only 30%. The remaining are 70%. In Western, it's almost 100%. They don't see this variant in the Western countries. This is much easier to treat rather than this metallo-beta-lactamase. So non-metallo-beta-lactamase, how to treat? Definitely meropenem is not of use. Cefepime-tazobactam is also not of use. Whereas ceftazidime avibactam, ceftolozane tazobactam, imipenem relibactam are the three best choices to treat because it overcomes efflux, porin deficient, and AMPC. So these three drugs are the better ones. Imipenem relibactam seems to be much better than the other two. So this is better, and slightly lesser than this is the ceftolozane tazobactam, and even lesser is the ceftazidime avibactam. When it comes to metallo-beta-lactamase, we have only one choice, that is cefiderocol. It has been FDA approved but not available in India. Already 2 years before it has been approved in US and European countries. We don't know when it will come to India. Usually it takes 5 years for the new drug to come to India. It's almost 2 years now. Cefepime-zidibactam is one of the good drug, more promising, but it may take another 3-4 years to get FDA approval. We have nothing as of now, just to depend on colistin, knowing that colistin is not that great drug. And how about the Astrionam avibactam and Cefepime-taniborbactam? This is, though theoretically it must sound good, but high efflux throws these two drugs out. So this is also not a great drug. Now I move on to the last part, Acinetobacter baumannii. Mostly are XDR for the simple reason almost 100% of all the XDR Acinetobacter baumannii are due to OXA23/24. And the overexpression of OXA23 is brought about by the upstream insertion of the ISA BLA1. And in 30% of this OXA23, dual carbapenemase, along with the OXA23, NDM is also there. It becomes even more challenging to treat. Unfortunately, we don't have any beta-lactamase inhibitor for OXA23 as well as for NDM1, FDA approved. So as of now, for both these enzymes, there is no inhibitory drug. Hence, we are using the old and the new combination, mostly the old. We use colistin tigecycline combination, or colistin meropenem, colistin minocycline, or sulbactam minocycline, sulbactam meropenem. So all as an equal chances. As of now, minocycline and sulbactam seems to be the better partner for other drugs, with other drugs. As I mentioned to you earlier, we don't have any beta-lactamase inhibitor inhibiting the OXA23 as of now. And where do we see more of an Acinetobacter baumannii infection is in the AP and VAP, where colistin is abundantly used, knowing that colistin reach to the epithelial lining fluid is very less, that is only 9%. Though it has been categorically recommended not to use, we have no other choice. People continue to use colistin. And that could be the one reason why we are having high mortality here. And coming to the epidemiological picture, it's a universal donor and receptor for plasmids. So abundant number of AMR coding plasmids are there in Acinetobacter baumannii, and there are growing complexity of islands also present. So 60 to 70% carbapenem resistance. Dual carbapenem means even higher it goes, and 10% of colistin resistant among the carbapenem resistance are seen. And we are now interested in looking at the AMR virulence convergence, something similar to Klebsiella pneumoniae. So how do you treat this one? For OXA23 alone, as of now, the sulbactam birulobactam combination, which is in the phase 3, is more promising. And for OXA23 and NDM, cefiderocol is the choice, but it may take 2-3 years to come to India. Cefepime-zidibactam may take 5 years to come to India. So eravacycline, still it is not available in India, but it has been FDA approved and it's available elsewhere. This is being used off-label for salvage therapy. Cefepime-zidibactam seems to be more promising, but it may take 5 years to come. So eravacycline and sulbactam, sulbactam has got an intrinsic activity and eravacycline has got a carbapenemase inhibitory activity. So at present, till the new drug arrives, we can try with the eravacycline and sulbactam. The studies are focusing now on this combination. Next is the summary. You can see, to sum up, Klebsiella pneumonia recent study reveals India is epicenter for AMR virulent convergence with the sequence type 231. Ceftazidime avibactam plus aztreonam is the off-label option as of now. And though cefiderocol is the ideal choice, but it's not available in India. It has been FDA approved a couple of years back. It may take 3 more or some time to come to India. Until cefiderocol comes, we don't have a good choice for Klebsiella pneumoniae. Then for Pseudomonas aeruginosa, what we are observing in the surveillance network is more metallobeta-lactamase producing multi-drug resistant Pseudomonas aeruginosa seen, unlike Western countries, and the specific lineage is sequence type 357 is predominantly seen in Indian subcontinent. And regarding the Acinetobacter baumannii, 70% are due to insertional sequence with the BLOT23. Cefiderocol is the ideal choice. There is no beta-lactamase inhibitor for OXR23, promising drug going to be sulbactam, darolobactam. Otherwise, until then, we need to put up with though we know that colistin is not a great drug, as a salvage drug, colistin with minocycline or colistin with sulbactam seems to be a better option. So, how this is the last slide where I show that KPC we don't see in India, but more choices are there. OXA48, only 3 choices are there. One is partial, 2 are good. But in India, only one is there, ceftazidime avibactam. Metallobeta-lactamase, cefiderocol is the only choice, but we don't have in India. Carbapenem-resistant Pseudomonas, non-MBL, many choices are there. But this is least seen in India. Metallobeta-lactamase is more seen. Again, cefiderocol is the only choice. Then carbapenem-resistant Acinetobacter baumannii, the only choice is cefiderocol. So clearly, you can see from this slide that until cefiderocol comes to India, we are tend to lose more number of lives.
Thank you so much, sir, for that informative session. I humbly invite our next speaker, Dr. Pratima Gupta. Ma'am is a professor and head in the Department of Microbiology, All India Institute of Medical Sciences, Rishikesh. She has served as an expert in various renowned examination and also served as an inspector in various universities. She has got Best Paper Award in the Microcon 2017 held in RIMS, Ranchi from 22nd to 26th of November on the topic baseline assessment of head hygiene, knowledge, perception and compliance among various healthcare workers of AIMS Rishikesh. Ma'am was nominated to attend Pari and DOTS training, and she conducted key performance indicators of BD Pandya Hospital Nainital 2020 under NABH. I request ma'am to please come and talk on clinical management of resistance gram-positive cocci infections. Please, ma'am.
Thank you. Uh, is my screen visible?
Yes, ma'am, it's visible.
I would like to thank the organizers for inviting me to on this discussion on clinical management of resistant gram-positive cocci infections in Hisicon 2021. So just a very brief overview within 10 minutes. I'll be talking about the past and present of drug resistance, especially involving the gram-positive cocci, Staph aureus, enterococci, others. What are the options currently available, and what is the immediate future, and what we should do? Now, the discovery made by Alexander Fleming way back was a great promise, and it was most effectively used during the World War. which saved a lot of soldiers from death, and it was held in high esteem. So this was the magic bullet at that time. However, Fleming in his 1945 Nobel Prize lecture very well highlighted the fact that it is not difficult to make microbes resistant to penicillin in the lab by exposing them to concentrations not sufficient to kill them. And then same thing has occasionally happened in the body, and by exposing his microbes to non-lethal quantities of the drug, make them resistant. So this was one of the red flags shown by the man, great man himself way back. Currently realizing that drug resistance has become very important globally. Every country has been affected by these multi-drug resistant drugs called as the escape organisms, the superbug. Several names have been denoted to these group of organisms. So the WHO published a list of bacteria for which new antibiotics were urgently needed. This was published in 27th February 2017. And they published the list of antibiotic resistant priority pathogens. Now, if we look at this list of priority pathogens, which require research and development for the purpose of developing new antibiotics, they were divided into priority 1, 2, and 3. The priority 1 or critical pathogens did not include, as we see, any gram-positive organism. However, in the priority 2, that is the high priority area, the organisms like Enterococcus specium vancomycin resistant, Staphylococcus aureus methicillin resistant, and vancomycin intermediate and vancomycin resistant were included. And in the priority 3 area, Streptococcus pneumoniae, penicillin non-susceptible were included. So these were the areas or the thirst areas which required research and development. Now, if we realize the mechanism of antibiotic resistance, as I said, some microorganisms may be born resistant, some achieve resistance by mutation, or some have resistance thrust upon them by plasmids. So we can also understand them like this, that mechanism of antibiotic resistance include, and we should understand that some are intrinsically resistant to the antibiotics, a group of antibiotics, or they can be acquired by these organisms by genetic methods like chromosomes, that is by mutation, or extra chromosomal agents like plasmids. Now, if we see in this list, it highlights which drugs are, the gram-positive pathogens are intrinsically resistant. Gram-positive pathogens are intrinsically resistant to aztreonam and colistin. The purpose of showing this list is very often the clinicians ask us in the lab, like, आपने ये वाली antibiotic नहीं लगाई, हम ये दे दें या नहीं दे दें. So we should be able to, promptly tell the clinicians, guide them to make them understand that certain organisms are intrinsically resistant. Gram-positive is resistant to aztreonam and colistin. Enterococci are intrinsically resistant to cephalosporins, fluoroquinones, macrolides, trimethoprim, sulfamethoxazole, clindapycin, and ertapenem. Staphylococci are intrinsically resistant to fluoroquinolones and macrolides. Besides this intrinsic resistance, gram-positive bacteria can also acquire resistance by other mechanisms like overexpression of efflux pump, by reduced permeability of drugs. One prevents the entry of the antibiotic into the cell. The other mechanism actually throws out the drug from the cell. And it also, through these extra chromosomal agents, that is the plasmid, it can produce antibiotic degrading enzymes which destroy the antibiotic, or it alters the antibiotic in such a way that it becomes ineffective. Furthermore, mutational changes also reduces or finishes the activity of an antibiotic. So normally an antibiotic, when given, would cause death of the organisms. However, if there is a mutant or altered mechanism for drug resistance, this organism not only survives but multiplies, therefore creating a pool which can spread to other susceptible individuals and allow the emergence of multi-drug resistant organisms. Now, if we talk about Staphylococcus, which is a major human pathogen causing minor and life-threatening diseases of respiratory tract, the skin, soft tissue, lungs, other areas, we have to understand how the drug resistance actually emerged in Staphylococcus aureus. If we see, once the magic drug penicillin was discovered, it was found to be very clinically effective against this Staph aureus. However, slowly this organism developed resistance to penicillin. To fight with this and deal with it, penicillinase resistant antibiotic like methicillin were then developed in 1962. However, this too very quickly developed resistance, and it was called as the methicillin resistant staphylococcus. Due to the emergence of this type of strains, vancomycin was used more frequently, and this frequent use of vancomycin also led to resistance development in Staphylococcus aureus, and also there was an emergence of vancomycin resistant enterococci. There are two things which are mentioned about the resistance in Staphylococcus aureus. One term which is used is the vancomycin intermediate Staph aureus or VISA, and the other is the more dreaded vancomycin resistant Staph aureus, which can arise, which is said to have arisen from this vancomycin resistant enterococci. The other methods for developing drug resistance in Staphylococcus aureus, besides these enzymes, was alteration in the outer membrane permeability, inactivating enzymes, and efflux systems. All these have contributed to development of drug resistance in Staph aureus, making it one of the major dreaded multi-resistant superbug. Now, methicillin-resistant Staphylococcus aureus has been classified for various purposes into an healthcare-associated MRSA known as the HAMRSA, and the other is the community-associated MRSA. Though the difference between these two has become quite blurred, these terms are frequently used. What are the major differences between the community-acquired and the hospital-acquired? The hospital-acquired, as the name suggests, is in long-term care facility residents and diabetics. There are predisposing conditions like diabetes, dialysis, prolonged hospitalization, patients admitted in the ICU, and those with on IV fluids and lines. Whereas the community-acquired is seen in a younger age group, children, athletes, prisoners, and certain other risk factors. The gene coding for this is different for both. And the most important thing to remember is that the antimicrobial resistance for MRSA in case of community acquired is to beta-lactam alone usually. But they are usually susceptible to trimethoprim sulfamethoxazole and clindamycin, usually. Whereas in the hospital acquired, this is resistant not only to beta-lactams, but to other drugs also. That is what is the disadvantage or the major problem with HAMRSA. But they may be susceptible to the combination drug. MRSA infections, if we talk about the epidemiology of MRSA, Indian studies through the major, Indian network for surveillance of antimicrobial resistance, which was carried out, has stated that 42% of clinical isolates of Staphylococcus aureus were methicillin resistant. European studies have also shown that 40 to 50% of the isolates have methicillin resistance. And in surgical site infections, 71% were found to be the Staph aureus isolates. That is quite high, out of which around 22.5% were methicillin resistance. If we see a global picture, Sweden reported the lowest prevalence in of around 0.4%, with a very high prevalence in Belgium of 48.4%. Again, coming back to India, in the Indian region, it was seen that the prevalence of methicillin resistance was around 25% in the western part of the country, with a higher prevalence in the South Indian studies of around 50%. Now, what are the drugs which are available against this methicillin-resistant Staphylococcus aureus? Methicillin resistance basically denotes, or the other term which is used is the oxacillin resistance, and it is intrinsically then found to be resistant to all the beta-lactam drugs. Now, which are the drugs which can be used and are actually used by clinicians? Sometimes for empirical therapy, once they find out that the isolate of Staphylococcus aureus is sensitive, they step down to a lower, first generation cephalosporins are effective. No need to use vancomycin in that case. The other drugs which are available are vancomycin, teicoplanin, linezolid, quinpristin, dalfopristin combination, daptomycin, tigecycline, and this latest generation of cephalosporins, that is ceftobiprole. Newer glycopeptides, which have a similar activity to vancomycin, are also available, like dalbavancin. Now, these cephalosporins, I would just like to repeat again that these cephalosporins are found to be effective against the MRSA, and they're referred to as anti-MRSA antibiotics, ceftaroline and ceftobiprole. These are the drugs which can be used. And in the quinolones, becifloxacin, delfafloxacin, these are the other drugs which are effective against the MRSA isolates. Now, among the other gram-positive organisms like Streptococcus pneumoniae, resistance has been reported quite frequently, and that's why they've been included by WHO. In our hospital at AIIMS Rishikesh, it was started from 2014. We started our reporting in the bacteriology lab, and this is a sample of the report which we release for methicillin-resistant Staph aureus. We give the list of the antibiotics as per the CLSI guidelines and report them as either susceptible, dose dependent, intermediate resistant, and we also mention what oxacillin susceptible staphylococci means. It means that it is considered susceptible to this group of drugs. And oxacillin results can be applied to other penicillinase stable penicillins. So these information is included in the antibiotic sensitivity report, which we release from the lab. The primary reason being, this is a guide to the clinician, a repeated reminder about the profile of these group of organisms. When we talk about Enterococcus, you have to remember that Fecalis and Faecium are the common isolates of this. Fecalis is usually responsible for 80 to 90% of all clinical isolates. Enterococcus faecium is resistant to group of antibiotics, which should be kept in mind. And Enterococci was found to have developed intrinsic resistance to third generation cephalosporins and later to ampicillin also, which led to the introduction of vancomycin as a treatment option. However, as is common with other antibiotics and organisms, resistance to vancomycin also emerged. And it emerged in 1990s as the second most nosocomial pathogen due to the increased use of vancomycin. Now, besides talking about clinical applications and clinically used antibiotics, this is a review paper in Nature Reviews Microbiology, which mentioned about the preclinical antibacterials which are available in the pipeline. And different institutes are carrying out studies to study the efficacy of these directly acting small molecules, potentiators, repurposed drugs, antibodies and vaccines, immunomodulators, antivirulence approaches, even phages, and there is important role of altering the microbiota to fight against these multi-drug resistance. So these are all in the pipeline. Results are still awaited to see how good they are. And a large number of other drugs are being developed to overcome gram-positive resistance. Now, what are the strategies which should be adopted to overcome drug resistance? This till now we were just talking about the different gram-positive cocci which have shown drug resistance. Now, what are the strategies which can be adopted? Surveillance of antibiotics should be carried out to detect resistance in humans as well as animals. Because of the close interaction between humans and animals, we do forget to understand the importance of how antibiotic misuse in the livestock actually affects us in retribution. So cautious use of antibiotics should be done in humans and animals. Decontamination or isolation of patients with identified resident pathogens is a very important part. There should be emphasis on improved antimicrobial stewardship in the healthcare facilities with restricted antibiotic advertising so as to inhibit their misuse, with a good health infrastructure, development of proper policies, development of good rapid diagnostic tools for prudent antibiotic prescription, consistent disease control strategies, and one very important aspect which cannot be undermined and is actually very important, which this conference is also addressing, that is the education of the prudent antibiotic use. And another most important thing, which should not be forgotten, especially in the scenario of drug resistance, is the practice of proper, as indicated, hand hygiene using appropriate tools and in the correct manner. For this, one should carry out audits, carry out on-site training, not only for the healthcare workers, but also for the patient attendants. They have to understand that it is not just to be followed in the hospital, but also where they live, in the community. So I would again repeat, hand hygiene is one of the most important methods to overcome or control the spread of drug-resistant organisms. Several global initiatives have also been taken, realizing the impact this drug resistance would have on human health, because as we all are seeing that infectious diseases is gaining a foothold. It is becoming the most important part which is troubling the entire human race, and drug resistance remains the foremost. So the take-home message would be target definitive therapy to a known pathogen should be done. One should treat infection, not contamination. We need to differentiate that. When to say no to vancomycin and higher generation antibiotics. The role of microbiologists is so important, not only to isolate, as is being told by all the senior microbiologists, the microbiologist has to come out from the lab, from the bench to the bedside of a patient. The say of the microbiologist would actually help a lot in helping a clinician in managing these patients who are infected with multi-drug resistant. So again, repeating that we should keep our hands clean, and simple bedside tests may actually help the clinician in initiating appropriate initial therapy, antibiotic therapy. Thank you.
Thank you so much, ma'am, for that informative session. Without wasting any time, I would like to invite our next speaker, Professor Anuraloke Chakrabarti. Sir is a professor and head in the Department of Medical Microbiology, PGIMER, Chandigarh, working in the field of fungal infections for the last 36 years. So, sir, consider that he is still a student in the field as new things come up, and he is always keen to learn. Sir, we are all in the learning phase and need to learn a lot from you. His field of interest is epidemiology, research in nosocomial fungal infections, molecular epidemiology in opportunistic fungal infections, non-culture based diagnostics of systemic fungal infections, and many more. Sir has received various prestigious awards, and he has a fungal species named after him, named as Malassezia annuloke species. So I humbly request sir to please come and deliver the talk on resistance to antifungals, how to cope. Please, sir.
Thank you, Dr. Sami. And good morning, ladies and gentlemen. At the outset, I'd like to thank the organizer to consider this importance of fungal infection. And the topic is antifungal resistance, how to cope it. So I'm not going to discuss much of the molecular mechanism of resistance, rather how to cope in this aspect. First, I would like to say that considering to the bacteriologist, we are not so much lucky because we are eukaryotic, fungi are eukaryotic. So there is limited scope to exploit for development of antifungal. We have only 4 classes of antifungal which are there. And if you see the spectrum of activity of this antifungal, of which usually we used to consider amphotericin B is the gold standard of antifungal therapy. But if you see, there are so many gaps now. So it remains a myth, no more true in that sense. So no antifungal is ideal as limited spectrum, toxicity, drug interaction issue, PKPD issues, which are also very important. Also, there is a treatment failure issue in managing fungal infection. And I would rather say antifungal resistance and treatment failures are not synonyms. What are the reasons? If you see, because these antifungals are mainly fungistatic, we need to improve the immune status, otherwise there is a problem. In case of fungi, there are several other factors, and in case of antifungal drugs, as I have said, the PKPD issue is a very important. But as we are going to discuss the drug resistance issue, I would say there are 3 types of resistance. One is the intrinsic, acquired resistance, and the clinical resistance. But we are lucky, not like bacteria. We are not like bacteria or virus, no beta-lactamase, no horizontal transfer, no plasmid, transposon, or ELBS is there. So if you see in case of resistance development, over the years, you can see it's a slow development which is there. What is driving for this resistance? Main thing is that long-term use of antifungals, so mutations coming into this picture, and this pathogen mutation rate is very important. But along with that, what added to the list is now global dispersal, movement of the people, immunocompromised patient, population growth, all these factors. But friends, 3 facts change this whole paradigm. What we are seeing is that multi-drug resistance Candida auris globally, azole resistance Aspergillus fumigatus in Europe, and terbinafine resistance dermatophyte in Asian countries. Other issues is that emergence of intrinsic drug resistance Candida aspergillus, emergence of the echinocandin resistance or the azole resistance to the common Candida species. The Candida auris is a very peculiar organism. Suddenly a bacterium like come in the fungal field because it is developing resistance very fast, easily transmitted, cause severe infection, high mortality, and not easily identified. And this is the first time one of the fungus had been qualified as the urgent category. And if you look into these Candida auris, there are 4 clades, and amongst these clades, there is variation in resistance. In India, we generally have the clade 1, and clade 1 has the highest resistance. Not only fluconazole, even on voriconazole, and amphotericin B, around 1/3 is resistance. Even echinocandin resistance is emerging. This is the Indian scenario. Multi-center data which you could accumulate, you can see nearly all strains are resistant to fluconazole, very few susceptible to voriconazole. Even in case of these 3 echinocandins, the resistance is emerging. Look at this Candida tropicalis. It was said in IDSA guideline once that if you have Candida tropicalis, do not worry, do not need the susceptibility, you could go straight to fluconazole. But if you look into this China data, 9 years data, which showed that in all fluconazole, voriconazole, itraconazole, posaconazole, the resistance is emerging. Even when we conducted the 27 ICU study of 1400 Candida species, where we have shown amongst Candida tropicalis nearly 12% resistant. In case of fumigators, this is another interesting aspect. Because of the fungicide use, there is a very high resistance as we've seen in North Europe. Luckily, it's still minimum in case of Asia, Australia, and USA. In case of this North Europe, especially in Manchester, it had come because of long-term therapy in chronic disease, whereas in Nijmegen, it is acquisition from the fungicide. That's why the tulip which had gone from Netherlands to Ireland, it contains azole resistance as per just fumigators. You see, this is a very important editorial, Great Indian Epidemic of Superficial Dermatophytosis. We never used to think dermatophyte can cause the problem, but now there is around 30% of the dermatophytes are not responding even to the base drug terbinafine. And what we are seeing is that a very extensive lesion. And you can see, generally we teach the student there is a one ring, but we have multiple rings are being seen. Why it is happening? This is happening because of this type of treatment where you are giving anti-inflammatory, antibacterial, antifungal along with steroid. And what we have seen, this is the paper which we have published last year, which showed that number of strains which are shown to be very high MIC with terbinafine, and this is because of this mutation. So what are the reasons? One aspect is the improper use of antifungal. Where we need to use, we are not very sure. Choice, dose of antifungal, drug interaction, PKPD issue, antibiotic use also factors, especially in case of Candida, where there is change in case of microbial diversity, leading to the tolerance in less susceptible fungi, fungicide use, natural resistance, intrinsic resistance coming out. Even then, there are certain strains we don't know why it is developing resistance. Acquired resistance is important factor, but unknown factor, why Candida auris develop resistance so fast, it is there. So you see that improper use of antifungal, global data shows very high, more than 50%. Guidelines are there, very few follow guidelines. We don't know exactly what should be the dose. The problem comes of the PK non-linear in majority of antifungal. Duration is also not clearly defined. We don't know when to de-escalate. Clinical outcome depends not only on drug, but also on host and rulers of fungi. And high cost of antifungal is another issue. A lot of people cannot afford this antifungal. That's why you have seen that clinicians tend to choose less expensive drug, which may be appropriate. This is the study which we have not yet published, and this is under review. It showed that at least we have a better situation in our hospital where 1/4 is inappropriate drugs. What we have seen, mainly it has been used in adult, and amphotericin B has been misused quite long. So if we have to do antifungal stewardship, what do we say? We say right antifungal, right patient, right time, right dose, right route, and causing less harm to the patient. But all this depends on diagnosis. And in case of fungal diagnosis, nearly 50% of the cases, it is very difficult to diagnose. So what we said a very provocative statement, and we mentioned that delivering even antimicrobial resistance agenda will not be possible without improving fungal diagnostic capability. Because in sepsis, whether it is Candida sepsis or bacterial sepsis, if you don't know, you will go on giving antifungal or antibacterial, which may be inappropriate and causing emergence of resistance. So how to cope at it? We need early accurate diagnosis. We need to have a novel antifungal which should be proper, predicting development of antifungal resistance. We need for antifungal stewardship, but I would say, especially during my mucormycosis, when this outbreak came, we found that training so important, not only in microbiologists, but also in clinical, and we need research. What is the present diagnostic scenario is that when there is clinical infection developed, we diagnose, but it may be too late. That's why we need, when fungus enter, to diagnose. That's why these biomarkers, which are possibly going to help in case of fungal diagnosis. At the same time, we need a real-time antifungal susceptibility testing. Only good aspect is that, look at this. In 2020, since 2020, we have got so many cases of new drugs which are emerging. This is very important, though they are in the phase 3 or phase 2 phase. But I would say that there is a golden period, possibly, if we have a good antifungal drug very soon. Even in this year, in June 27, FDA approved one of the drug as an orphan drug status, which possibly, this is BSG 005, which can possibly substitute amphotericin B, the polyene. This is just a nystatin which have been modified. Lastly, I would like to say, possibly we need to predict antifungal resistance like antibacterial by like Barlow's-Hall's method, where you go on going subculturing and try to find out which is the real gene which is having more resistance to the antifungal. If we can determine, and if we can detect that part, that would be best. So if we have to do the antifungal resistance to cope with, I would say that emergence of multi-drug resistance Candida auris is a challenge. We know that Candida tropicalis and glabrata, which are common species, even there is resistance development. We have to look into fumigators where the triazole resistance is emerging in Europe. It should not come in India. Intrinsic resistance is emerging, that we have seen. And we have also seen that there is a dermatophyte resistance, which is a major concern. We need to have appropriate antifungal therapy in majority center, no scope of complacency. The amount of resistance has complicated antifungal management. Need to improve the antifungal diagnosis, the fungal diagnosis, and need to develop antifungal drug, predicting resistance and antifungal stewardship. But we also need to have routine antifungal susceptibility testing. Friends, bacteriologists are already drowning in the water. We are small creature. We are going in this direction. Please save it. Try to save these antifungals properly. Thank you for your kind attention.
Thank you so much, sir, for that informative session. Moving on to our next speaker, Dr. Ravi Vasantapuram, famously known as Dr. V. Ravi. Sir is a nodal officer for genome sequencing of SARS-CoV-2, the government of Karnataka. So, sir has done MD microbiology from JIPMER and was formerly senior professor and head of neurovirology in NIMHANS, Bangalore. Sir is a WHO consultant for Japanese encephalitis, HIV, and influenza, as in the scientific advisory committee member in various national committees like NACO, ICMR, DBT, NIV, NIN. He is an NABL assessor since 2012. The external examiner for MD virology at Sri Lanka since 2009 and PhD examiner for several universities in India. He has mentored more than 425 PhD students and has been a PI for several funded research projects from national and international agencies. He has published over 160 papers in peer-reviewed journals and contributed 20 chapters to book and 4 WHO monographs. He has been elected Fellow of National Academy of Sciences, Indian Academy of Sciences, and American Society of Tropical Medicine and Hygiene. He is a visiting professor of microbiology and immunology in the University of Liverpool, UK, and has been conferred with Sir C.V. Raman Young Scientist Award, ICMR J.B. Srivastava Oration Award, Dr. S.C. Agarwal Award, Dr. Hai Jhala Award of IAMM, and Eminence in Virology Award of Indian Virology Society. So he is a member of Karnataka COVID-19 Task Force and Technical Advisory Committee. He is a member of DBT COVID-19 Vaccine Committee. After that exhaustive CV, I humbly request Sir to please take a talk on antiviral resistance, strategies to prevent and treat. Please, sir.
Good morning, and thank the organizers for asking me to speak on antiviral resistance, the ways to prevent and treat such especially Dr. Raman Saldana for, is my screen visible?
Yes, sir, it's visible.
Okay. What I will do in the next 7-8 minutes, I'll try to cut down as much as possible. Tell you on, because unlike fungal and bacterial resistance, viral resistance is emerging because antiviral therapy itself is not available extensively for all viral infections. Definition of antiviral drug resistance: what are the indications of emergence of drug resistance and what are the strategies? Um, we must thank HIV in many ways, because with the advent of HIV, antiviral research really took off. Prior to that, only herpes virus we had drugs. Since then, we now have for hepatitis B, hepatitis C, papillomaviruses, influenza, and other respiratory viruses. Although this is all very exciting, the bad news is there is emergence of resistance. And so that brings us to the question, what is antiviral drug resistance? It's defined as a reduction in the susceptibility of viruses uh, in culture to the drug. The inhibition concentration, IC50 or IC90, there are two measures in which you can measure resistance to viruses. So if there is a reduction in IC50 or IC90, then it is termed as drug resistance. And the absolute method of doing it is by doing it in culture, and this is called phenotypic resistance. But because growing viruses and doing antiviral resistance typing is not as easy as bacterial or fungal, we need live systems and a whole lot of other infrastructure. So people have relied more on looking at the mutations and associating them with drug resistance. And so you can also define drug resistance by looking at the genotype and showing characteristic mutations that are associated with resistance. Why do viruses develop resistance? It's a simple Darwinian principle. As you know, they have the highest rate of multiplication compared to even probably bacteria and fungi. Their doubling time is very, very less, and in a day, billions of particles are produced. And since therapy is available mostly to RNA viruses, and we all know that RNA viruses have uh, an advantage, they're endowed with a lousy enzyme known as RNA dependent RNA polymerase, which makes mistakes while the virus copies itself because it lacks proofreading ability. So mutations occur at a very high rate in RNA viruses. Hence, this is an advantage. And if they occur in the areas where the antiviral drug is acting, so naturally they develop resistance, and that population is selected out based on the Darwinian principle. So the various factors associated with development of antiviral resistance, I'll just summarize in this slide, are viral, drug related, and patient related. The high rate of application, the error proneness of the viral replicative enzymes are the viral factors. The potency of the combinations. For most chronic viral infections like hepatitis B, hepatitis C, and HIV, single drugs don't work. So we use them in combinations. And the combinations have to be complementary to each other. They cannot be antagonistic. So the potency of the combinations, how they help each other in reducing virus replication, the pharmacokinetic properties, especially the antiviral drugs that are used for chronic infection, should penetrate all barriers like the blood-brain barrier. Otherwise, the virus hides in the CNS, mutates, and then from there it repopulates the entire body. So pharmacokinetics of the drug, its penetration characteristics are very important. And also pharmacodynamic PK and PD, as Dr. Aranalok very rightly said, for antifungals. PD is, for example, chronic hepatitis is a condition where cirrhosis can happen. There is fibrosis and drug metabolization is an issue. And mutations selected by specific uh, target sites, target specific drugs is important. But Uh, Above all, the most important reason for emergence of drug resistance in the viral infections is two things. One is prior drug experience, and the most important issue is compliance, because these are lifelong therapies, at least for HIV, and for hepatitis B and HCV, it's prolonged therapies. And if there is no compliance and the right amount of drug at the right time is not taken, it can induce resistance. So the indications of emergence of drug resistance will depend largely on clinical deterioration. Viral load has become a big advantage in the last 2 decades. From the turn of the century, we can measure viral loads in all these major infections like hepatitis B, HCV, HIV, and that's a clear indication of emergence of resistance. Decreasing CD4 counts, increasing enzyme levels are surrogate markers for emergence of drug resistance, and identification of specific genotype markers of drug resistance. But this is not routinely done, I must say. This is something that we are lacking as a national program. There are many types, methods that are used: genotypic methods, phenotypic methods, and hybrid methods. I won't go into details, and they have their own advantages and disadvantages. Phenotypic resistance is very difficult. You need an experienced lab and good infrastructure. A classical example of lack of adherence to therapy. Here is a very important slide that shows you in HIV, if there is 95% greater than 95% compliance for taking antiretroviral therapy regularly, then the emergence of drug resistance is very low, especially after a long period. But if the compliance decreases, you will see that virological failure occurs and viral loads go up. So consequently, it's important to have something like a pill box, which is there in the bottom, which puts the names of the days: Sunday, Monday, Tuesday, Wednesday, and so on, and educate patients on taking it properly. What are the ways to prevent antiviral drug resistance? First is to try and increase the maximum tolerated dose. That's one of the methods. Most importantly, for chronic infections, no monotherapy. Right from the beginning, combination therapy, attacking viral replication at various stages, and select the most effective regimen. Not only that, also select the right combination. Do not use antagonistic combinations, especially when it comes to nucleoside analogs. Um, the other way is to maximize genetic barriers to resistance, avoid sequential therapy, choose drugs requiring multiple resistance mutations, because we know now that for most of these chronic viral infections, we know where the mutations are occurring. Now choose a drug that will require multiple mutations before it becomes ineffective. And always try and choose drugs when the patient is drug naive, so that your chances of drug resistance emergence is much less. But most importantly, as I said and showed you some data, patient compliance and monitoring tissue distribution are very important. So, in summary, I would like to take this. I'll request you to take home the following points. Emergence of antiviral resistance is a reality. Set up a robust surveillance mechanism for detection of antiviral resistance, especially for the chronic infections, HIV, HBV, HCV. Right now in this country, we rely predominantly on viral load monitoring. We do not have a formal drug resistance testing program. Avoid monotherapy in chronic infections. Have clear-cut national policies, indications, and as Arunalok said, the biggest challenge is adherence to guidelines. I think that's the major guideline. Although we have guidelines, we popularize, especially in the private sector, people tend to use their own combinations, and that is something that contributes to emergence. And above all, patient counseling and support services to enhance adherence to therapy. Thank you.
Thank you, sir, for that informative session. Moving on to our next speaker, Professor Asadullah Khan. Sir is a professor in the Department of Biotechnology Unit, Aligarh Muslim University, Aligarh. He is recognized as eminent researcher in the field of antimicrobial resistance by Government of India and Research Council UK as per the prepared scoping report on antimicrobial resistance in India, which was released in November 2017 during Newton's award function in New Delhi. Sir is appointed as a reviewer in Swiss National Science Foundation Funding Agency in Switzerland for the scientific evaluation of proposals. He is appointed as adjunct professor in University of Católica, Spain, and appointed as a visiting professor in the University of Malaysia for a period of 2 years. His thrust areas drug resistance, mechanism, drug designing, biofilm, photodynamic therapy, infection control, and nanomedicine. Sir has 237 published manuscripts in peer-reviewed journals. So I request sir to please come and discuss the doubt and controversies about antimicrobial resistance. Please, sir.
Unmute sir, please.
Okay, good morning, everybody, and thanks inviting me at this forum to learn more about the antimicrobial resistance. I know a couple of the speakers here by interacting in several meetings. I know Dr. Bala Ji, I've been met him in several places. It was a wonderful talk. I think all speakers, they have explored a lot on the area of right from bacteria, virology, and infection control and fungal infection. I think nothing is left to talk by me, but I think yes, it's most welcome that if you have any queries and questions that to discuss on this forum. I don't know, I'm not aware about whether I need to present something or I have to just to talk in general way. Yes, can I ask Dr. Hiba?
Yes, sir. So you can discuss the questions that various participants had put in the chat box.
Okay. Okay. So I think if you can help me out to. I think one of the questions somebody asked regarding the phase typing of MRSA, if I'm recalling, because there's a couple of questions on the chat box. I'm not able to recollect all, but I think, yes, there's a paper in, I suppose I've come across in quite old paper, decades old paper, from one of the study on the phage typing on methicillin resistant Staphylococcus aureus. Yes, they have done. So they have screened out the MRSA phage to screen the methicillin resistance Staphylococcus aureus in I think Malaysia, and they've done almost more than 400 and different isolates of methicillin resistant Staphylococcus aureus from clinical specimen of patients in Kuala Lumpur. So yes, the answer is yes, it has been done in earlier cases. I don't know what exactly the question you want to ask, but what I understood, so I can answer it. Phage screening has been done on MRSA.
Any more questions for the experts, please? This is a time when we can take advantage of their presence.
I think it will be better if a moderator can ask questions through the.
So there was, yeah. So what about the faculty who was in charge of clearing doubts and resolving controversies?
Sir, Dr. Asad is here to clear doubts and resolve controversies.
Dr. Asad, please. Audience, let the audience also ask. Let you also take on with the thing. If we can.
The moderator should take care of this session. I mean, to ask the questions so that I can answer if I can do. Otherwise, I can talk something based on the all 4 talks. I can discuss something.
Please do engage the faculty here. I mean, it's very rare to get the combination on.
Okay, well, so in view of the all 4 wonderful talks on bacteriology, bacterial resistance by biology, and virology by Dr. V. Ravi, and fungal infection, and Pritima by Pritima on infection control. What I learned is that the current scenario and what are the take-home messages, I'll just discuss. So in the light of the global emergence of antibiotic resistance and fungal resistance or even viral resistance, what is the baseline point is that how to cope up the situation? Because there's the 2 parts. One is to understand the mechanism. Second is because understanding the mechanism may not quickly help the patient, may not quickly help the society. But what is important after understanding the mechanism is to think of the therapeutic approaches. And what is the best quick therapeutic approaches is we have to look into. And what I am doing in my own lab and for last couple of years and trying to translate now certain molecules to the level, and they are in the process of like animal testing, is FDA approved molecules. And we are trying to, especially I'm talking about the bacterial drug resistance, to design the broad spectrum multi-drug resistance. As Dr. Balaji discussed various markers like from NDM, and now, from 2009 onward, we have got at least 31 NDM variants. And these 31 NDM variants, they are quite different in their mode of action in terms of like they are having different mutations, single mutations, double mutations. So based on the mutation, the severity of the enzymes is increased or decreased. And whether it is MBL or beta-lactamases or methyl-beta-lactamases, the mechanism is entirely different, because in methyl-beta-lactamases, it is a zinc metal ion that hydrolyzes water molecules and to degrade the beta-lactam ring and to make the antibiotic ineffective. Whereas in the case of serine enzymes like beta-lactamases, SHV, TEMs, and there are many more, A, B, C, D, all these 4 classes, they have serine mediated interaction with these beta-lactam ring, and they hydrolyze the beta-lactam ring. So, but they're the transition state. And the transition state is, which is common from both methyl-beta-lactamases and beta-lactamases. Now, what we are planning is to design inhibitor, we call SBL inhibitors and MBL inhibitors, to this transition state so that we can thought of broad spectrum inhibitors. And these broad spectrum inhibitors is basically not, as Dr. Bala discussed, that NDM, OXA, certain inhibitor, and for SHV, TEM, and certain other beta-lactamases and methyl-beta-lactamases, we have a different inhibitors. So what is important is to check in a patient what kind of inhibitors, what kind of markers is being expressed is time taking. And by that time, the patients might reach to the critical state. So what we are planning is to design a transition state mechanistic based inhibitors that can have a broad spectrum inhibitors of all class of beta-lactamases and methyl-beta-lactamases, and that too are from FDA approved molecule. Because the advantage of FDA approved molecule is because these are already trial molecules, so you need not to go for further trial for the testing of toxicity and some other animal trials. You can pick up these molecules and you can just, having a single trial, you can move for translating these molecules into the proper in the market. And so we have reached to certain FDA approved molecules so far, which are best fit for all beta-lactamases and methyl-beta-lactamases. But this is a tough task because mechanism-based screening of beta-lactamase and methyl-beta-lactamase broad spectrum molecules are very, very limited molecules, but we have to. Second point is that we have been working on combination therapy for last couple of years. And I think combination therapy is one of the best way to look into. So we have proposed, because my background is molecular biology, so I work more on molecular aspect of this drug resistance. So what we discovered that two different class of drug, like for example, if you talk about aminoglycosides and beta-lactam, and both the drugs are, showing the resistance in bacteria separately. So when you give the look the MIC with the aminoglycoside, it's very high, and if you look the MIC with the beta-lactam drug, it's very high. Now what we did, we combined these two drugs randomly and just with the minimum quantity below the MIC level, standard MIC level, and then we tested against the highly drug-resistant strain. And what we found that the MIC goes down tremendously to the sensitivity level. And then we try to prove the mechanism of these two combination of these two class of drugs against drug-resistant bacteria, where the single drug will not work. And we reached to the conclusion through several biochemical assays and several molecular biology techniques that one of the drug like aminoglycosides, when it give, it can have to trap the drugs, and the drug will not to the enzyme like NDM, SHV, and TEM. So we clone and express these enzymes and do a lot of binding studies with these molecules and prove that with the ITC, with the high techniques, that yes, the drug is going to bind. Now, when the drug is going to bind, then the available drug, which is there as a cefoxitin, ceftazidime, or any beta-lactam drug, third generation or fourth generation drug, will available to hit the target on the bacteria, and so the bacteria is killed. So this mechanism we have proved, and we published a couple of papers on that. So this is another aspect, but this is of course at the laboratory level. So we have not yet reached to the level of translating this molecule. Of course, it needs a lot of work on pharmacokinetics and dynamics, and of course animal studies as well to finally decide the dose for the human system. So this is another aspect what I'm planning to, my lab is working on, and we think it will help a lot for the physicians and clinicians to plan the empirical therapeutic approach.
Rani?
If you have any question, otherwise I can discuss.
Dr. Khan, can I ask few questions? Two
yeah,
questions?
Sure.
Yeah, thank you, Dr. Khan. My first question is for Dr. Arun Aloke, sir.
Anti-fungal resistance.
Yeah. The question is, after the outbreak of mucormycosis, we could not treat most of the mucormycosis the right way because of lack of liposomal preparations. Other preparations were used. Some patients were treated with half doses or lesser doses. So could you see any impact of all this wrong doses and wrong drugs being used for mucormycosis on the sensitivity pattern as of now? And what are your expectations out of all these wrong doses and drugs?
I think obviously I'm not working in this area, but as a just for a knowledge point of view.
He asked this question, Dr. Khan. He asked this question to me. Let me answer. Dr. Josh, this is a very important question you have asked.
Sir.
The problem here is that because of variation and because of the lack of knowledge in case of antifungal, there was a lot of variation in case of outcome.
Yes,
in case of this treatment, what happened is that some of the patients have got where maxilla is involved and there is loosening of the teeth. Because of that, people have reached to the dentist, and dentists, they don't know about the antifungal drug. They have just removed the teeth, and that way they stop there.
Yes,
and
sir.
Similarly, problem happened in case of the so-called maxillofacial surgeons. They have given 2 weeks of amputation, be stopped. Then there has happened some of the ENT specialists. So it was a really tremendous challenge for all of us who are expert in the field of fungal disease to make a training in case of antifungal management of mucormycosis. You know, in case of mucormycosis, the most important thing is that after 3 to 4 weeks amputation B therapy, you have to go to the either posaconazole or isavuconazole. If the patient is stable and responding. If it is not, then you have to change the therapy. You may possibly have toxicity issue where you have to change the therapy. And if it is a CNS infection, possibly you have to raise the amputation B doses. Nearly what we found is that, I will not give you exact data, but around 15 to 20% recurrence which we are seeing. At present, the challenge New cases are coming down, but at present we are facing the major challenge of recurrence because people have stopped the therapy, either could not afford, or there is not availability of the drug, or clinicians suddenly stop the therapy. So these are the major picture which are there. Now, regarding the strain susceptibility, we have done over 300 species strains resistance. Possibly now another 100 or 200 have added. I'm just giving you the data which is around 15 days back, which showed that there is a susceptibility variation in amphotericin B. At least 10% of the strains had shown amphotericin B susceptibility more than 2 microgram, which is not good, which is really difficult. Regarding posaconazole, somehow our susceptibility in vitro data is good. But challenge in case of posaconazole is that they have not done the therapeutic drug monitoring. That was a big problem. And because of not having the therapeutic drug monitoring, this is very difficult to say how it would respond. Isavuconazole is very good in Rhizopus aereus, but in other species, because this time we have seen many other new species also, like Rhizopus homothalicus, considerable number of centers have reported, Cunninghamella have reported, and these are the strains where, or these are the species where isavuconazole didn't found to be very good. So I'm saying you this is a mixed result in case of in vitro, and possibly there is also some difficulty in correlation between the in vitro and in vivo data in case of mucormycosis. So we had a challenge in every field while managing this particular group of patients. Sorry if I could not answer your all the details because I don't have data so much, exact data, but whatever the data and whatever the situation available, I have tried to answer your question.
Thank you, sir. Thank you, sir. Another question in the same continuity, sir. We have to use other lipid preparations like lipid complex or colloid dispersion at times because of non-availability of liposomal preparations during the pandemic. So what is the sensitivity pattern to mucor in general for non-liposomal preparations of amphotericin?
See, the thing is that in lipid preparation, susceptibility is good because, but the lipid preparation is usually, there are two compounds. One is called amphotericin B colloid dispersion, that is called ABCD. Another is the amphotericin B lipid complex. But in case of India, there are certain antifungals with lipid had been prepared, which is really a problem because these are the just they have put the lipid and try to shake with amphotericin B, which is not developing the micelle formation where the amphotericin B can enter in it. So there was the problem which remained with this type of compound. What we have suggested in that, those who have asked me about this particular compound, because we have looked into the toxicity and those are the patients, how they are responding. We said just give as per amphotericin B deoxycholate, don't exceed 1 milligram per kg, otherwise there is toxicity in those group of drugs. ABLC and ABCD hardly was available. We were dealing with those type of compounds. But there are certain liposomal compounds as generics were there, which were found to be almost similar in case of in vitro susceptibility with the liposomal amphotericin B, the research compound, which is called ambisome. So those are okay, but I had the problem, so-called lipid complex in case of amphotericin B, which is not ABLC, which is not ABCD.
Thank you, sir.
Thank you, the audience and wonderful faculty, sir. We are really grateful to. We wish we had a lot of time with you. I mean, and we'll definitely take that advantage in our webinar series. So once again, thanks a lot, sir. We are going to have another session, which is very important, the first keynote session with Dr. Vinod Paul joining us and Dr. Ganga Khedkar. And DG would be joining soon. So request all of you to please get be tuned to the session. Thanks a lot for everything, sir, and thanks a lot, audience. Wonderful audience.
Thank you all. I move forward to the next session, the keynote session. So hand over to Dr. Afri now. Thank you.
Can't hear anything.
Abu Matthew ஏதாவது வந்ததாமா? சீக்கிரம் சொல்லிருக்கோம்.
Waiting. So let us start with the answer.
Good morning. This is Dr. Safia here. It's time to begin our keynote session. We have an array of informative talks lined up today. Am I audible?
Yes.
Okay. So this is chaired by 4 eminent personalities. We are honored to have with us Dr. T.S. Jain, sir, Senior Consultant at Max and the National President of the Hospital Infection Society. He is well known for organizing numerous national and international level programs, as well as delivering the Dr. MKC Nari Awards 2014. We are also delighted to have with us Dr. Aarti Kapil, ma'am, Ambassador for Health Epidemiology in America. She's also the co-chair for the Hospital Infection Control Committee at AIIMS. She is a recipient of the Dr. Ajita Mehta and the Dr. S.C. Agarwal Awards and many more. Moving on, we are also delighted to have with us Professor Geeta Mehra. Professor Geeta Mehra, ma'am, she is the editor-in-chief of the Journal of Safety and Infection Control. She is a respectable member of the CARE Advisory Group on Hand Hygiene. And of course, we are delighted to welcome Dr. Raman Sardana, sir, Honorary Secretary of the HISI India. He has multiple affiliations and has co-authored the National Guidelines on Infection Prevention and Control 2020 and much more. So without further ado, I'd like to hand over the session to our esteemed chairpersons.
Thank you. Can we start?
Yes, sir, please.
The introductory slide. Thank you, everybody. It's my honor to introduce Professor Vinod K. Paul. I mean, Dr. Vinod Paul does not need any introduction. He is known all over the country, and not only all over the country, but all over the world by now. He is a member of the Niti Aayog and Government of India. Professor V.K. Paul, a pediatrician and a neonatologist by training, was on the faculty of the Department of Pediatrics, All India Institute of Medical Sciences, New Delhi since 1985, and served as the head of the department for nearly a decade. Government of India appointed Dr. Paul as a member of the National Institution for Transforming India, the Niti Aayog, in August 2017, where he leads the health, nutrition, HRD verticals, and he has played a pivotal role in formulating the Ayushman Bharat PMJAY, the Ayushman Bharat Health and Wellness Center scheme, and the Poshan Abhiyan. Dr. Pal is a part of the core team of the Union Government for the COVID-19 pandemic response. He chairs the Empowered Group on the Medical Infrastructure and the COVID Management Plan, as well as the National Expert Group on the Vaccine Administration for COVID-19. Professor Paul is a fellow of the 3 science academies of the country and is recipient of Dr. B.R. Ambedkar Centenary Award for Excellence in Biomedical Research. He was conferred with the prestigious the Programmatic Family Health Foundation Prize by WHO at the 2018 World Health Assembly. But besides that, I also admire him for being an excellent doctor, a very passionate doctor, and an excellent teacher. Over to Professor V.K. Paul.
Good morning. Thank you very much, Dr. Jain. You've been my teacher. Thank you so much for the kind invitation. Dr. Jain and distinguished leadership of the Hospital Infection Society of India, distinguished co-speakers of this particular session, very esteemed speakers who will follow me, and the entire fraternity of hospital infection academics and action gathered around this video conference driven conference seminar. It is a pleasure to be amongst you. I have been interested in the area of infections for a very long time. As a practicing pediatrician academic, this has been my one focus of my work, both from the point of view of research, but also action. And believed in restricting use of antibiotics, believed in protocolized management of infectious diseases, and then believed in preventing infection through rigorous adherence to the best practices. Those who are young students in the audience today, for just to say how step by step we uncover new areas of work and solve problems to an extent, just want to relate to the fact that when it was 80s, the infection profile of our nation was seen to be an oddity in neonatal infections compared to the world. The Western world had different organisms causing newborn sepsis, typically group B streptococcus, and we would have Klebsiella and E. coli. And this would not find much space even in the textbooks at that time, because we never documented it very well. But we were grappling with gram-negative infections, and then later on, of course, all kinds of infections, including catheter-related infections and so on, which are totally different spectrum of infections. But by creating what we at that time called neonatal perinatal database, working together with 15 leading institutions, we systematically documented. In addition to, of course, individual studies that came up from very eminent groups and colleagues, that our infection profile is different, our organisms are different. For us, Klebsiella was the king at that time. Klebsiella pneumoniae was the king. And we were dealing, even at that time, in late 80s, mid 90s, with the problem of huge antimicrobial resistance, which we flagged collectively as a neonatology academic unitology fraternity of our nation. And later on, of course, so much more work followed and so much more uncovering of the dynamics of infectious disease was uncovered. In later part of my academic phase, I worked on antimicrobial resistance with passion because it was very devastating to see that we would lose antibiotic after antibiotic. Things would not work, and very sick babies would move from one infection to the other. Newborn is a very vulnerable host, and the situation through which preterm newborn babies, small newborn babies, compromised newborn babies go through, they pick up infection from the environment, and you feel very guilty. So that's, and then later part, Acinetobacter focus came up. We elucidated the mechanisms of antimicrobial resistance along with very distinguished colleagues from around other institutions, multiple institutions from Delhi and LPGI Chandigarh, worked as a collective. The moot point that I wish to make here is that if you want to make a progress in any sphere, in particular in the area of infections, in the area of hospital-borne infections, in the area of antimicrobial resistance, these are epidemics, by the way. These are ongoing silent and at times not so silent epidemics. When we get into the newspapers for messing up babies in a cohort with one infection and the other, we do come into newspapers in a very sad manner. So in order to find solutions to such problems, it is the collective effort that makes a difference. So I first message to you this morning is work together. And your organization, Hospital Infection Society, is a great forum, and it should increase in its size and its intensity of work. But within this, there must be people who are interested in one set of infectious disease, let's say pediatric infectious disease, newborn infectious disease, or around organisms, for example. Therefore, my first message and request is advance the science and practice, evidence-driven practice in infectious disease. And that you can only do. Science you can surely only do when you work together. And even action you can only do when we work in even larger numbers. So that's my first message. Come together to fight the menace of hospital infections, the menace of antimicrobial resistance. And here I will make a few suggestions as to how you should move forward, and we should set some goals about it. We should be moving toward change and not discussing, not only discussing the clinical and pathophysiological and microbiological aspect, which is essentially understanding the knowledge, but knowledge should also translate into action, because this spectrum of diseases is avoidable to a very large extent. This spectrum of diseases is sad because a hospital is not the place where any of us should pick up a new infection. Having said that, let me now dwell on three themes, essentially. First theme is in regard to the theme of the session, namely prevention. Indeed, prevention is the best policy. It's not just a cliche, but it is also a very potent dictum in the field of infection. A lot of infections are preventable. Hospital infections are preventable. But there is a method to make that happen. And again, that method is about teamwork. The method is about an organizational response to how we practice medicine in our respective specialties and settings. My first learning in this area has been from my teacher, Dr. Mehban Singh, who emphasized the need for protocols for any hospital setting. Protocols of antibiotic therapy, protocols of asepsis, protocols. Be very clear how we will prevent infection and treat. So right now I'm talking about prevention. So what is the protocol for inserting an intravenous line? What are the 3 steps you take, 4 steps that you take, and you take them repeatedly, and you train your residents and nurses to do exactly the same thing. We do not take shortcuts. When if the gloves have to be worn in inserting an IV line in a sick patient in an ICU and a newborn baby always, and a cancer patient always, so be it. It has to be done. It cannot be compromised. So protocol is not only a writing on a piece of paper, but also something that you practice every day. Aristotle said, excellence is a habit. Excellence is a habit. It's something that you and I do on a daily basis, not you and I do occasionally, because we can do much better than what we may practice on a daily basis. So excellence has to be made into a habit. Protocols have to be adhered on a daily basis, as simple as inserting an IV line. If the betadine has to be used in a certain way, it has to be used. If you have to wait after betadine for 4 minutes, you wait. And you make this a habit of your own self as well as habit of your system and colleagues that you work with. Protocols in relation to sterilization, disinfection, very important. Periodic disinfection of the intensive care unit or a hospital, a general ward. How often do you do it? Is it weekly? Is it daily? Is it every night? Is it once a month? One has to adhere. These are all written up. I'm sure you have documents that highlight these aspects, but are they being done? We have to have champions who relentlessly follow and steer implementation of those protocols. Protocols of environmental hygiene and waste disposal. Protocols for ensuring that there is water supply and hand washing. Protocols on hand washing on a daily basis. Ultimately, these 4 or 5 items are the mainstay of practice for every organism, practically for every organism that we normally deal with in a hospital setting. So protocols on aseptic procedures, protocols on sterilization and disinfection, decontamination, and environmental hygiene. These have to be based on evidence, but they have to be adhered by the step. We must get used to follow all the steps. Doctors are not good at adhering to the nitty-gritty of a certain procedure. Engage with nurses to make this happen. They are a very, very important part of your team and also part of the solution, just as, and like us, also part of the problem. So protocols, and protocols. My second learning is that every clinical setting, department, unit, and of course hospital must have a hospital infection control setup. It's not only to be confined to medical colleges or centers of excellence, but in every sub-district hospital, district hospital. What is the infection control protocol? Again, a protocol. What is it that we mean by hospital infection control system? I urge your society to take a goal, make a goal. Can we, in the next, let's say 2 years, introduce hospital infection control practices in 2,500 hospitals of our country? 1,000 district hospitals, 750 to 1,000, then 1,000 private sector hospitals, and 500 other hospitals. Can we do it? That's how we could make a change. Hospital infection control doesn't mean rocket science, doesn't mean big resources. It's something that we do in a patchwork way anyway, but we must do it well. I'm sure your association must have protocols, how this is to be done in a very simple way, in a structured way. The hospital infection control mechanism of a sub-district hospital will surely look different from that of a medical college and a center of excellence with multi-speciality. Can we promote that? So that's my second learning. The third learning is antibiotic policy in the unit. Again, it is a protocol, but I would like this to be highlighted. Every unit, every group should have an antibiotic policy in an organized hospital. It can be, and it has to be unit, well, department and unit adapted as well. Because infection, the same Klebsiella infection is treated differently in a cardiac surgery unit perhaps, and detected differently than in a pediatric setting. So certainly a antibiotic policy for the unit, for the condition, for the specialty, for the subspecialty. Antibiotic policy, for example, for nephrology could be very different from an antibiotic policy in a neurosurgery unit. It is the third most important thing to be done and implemented and enforced. And my last advice and learning on prevention is to have antibiotic stewardship policy, and I'll come back to that as a separate theme in a minute. So 3 areas: protocols on asepsis, sterilization, asepsis procedures, sterilization, environmental hygiene, hospital infection control program, hospital, unit and department and specialty, and patient cluster driven antibiotic policy, which we are clear, this is what we will do. We will not jump. We should not have the fear of the unknown. Once we have decided in a certain way to go, we should not be tempted to change. Have confidence and have a peer confidence. Let your peers say, take it easy. We are with you. Let the consultant tell the resident, you don't have to jump. In one point in my, just a an anecdote, one particular very eminent resident joined in the DM program. And he started prescribing, writing antibiotic whenever he would start an IV line. So his criteria, and innocently so, because that's what he learned, that every time you start IV line in a newborn baby, start antibiotic. So this is the extent to which we could be off track and wrong. So kindly enforcing the policy is very important. And I'll come back to antimicrobial stewardship program in a minute. On the use of antibiotics, I have 5 messages. My first message is avoid the urge to start an antibiotic. I gave you an example of my very dear resident. There is an urge to start it, fear of the unknown. I think we should instill confidence in people. We should help people take decisions. We should help junior residents, junior doctors, junior people have confidence on this. This urge to start antibiotic has to be curbed. And you as a group of leadership in the area of infection should think how to create an environment and a buzz that we give confidence to people to avoid this urge. Now that's for us to do. Because you, in this fraternity, have to find a solution. If there is a wrong urge amongst us, wrong tendency amongst us, there must be a way to address. There must be a way of persuasion. There must be a way of other means for teaching residents and students and colleagues and consultants to avoid the urge to start antibiotics. We must teach, my second point, infection and not a situation. Do we suspect infection? We often end up treating situations in hospitals, particularly busy hospitals. We think we want to be safe. So we treat a situation, but we should be treating infection. We should look for some evidence of infection out being there, and not a situation which just is used to start an antibiotic. The third learning is undertake microbiology. We must invest in better laboratories in our systems. Often we don't. Can your organization advise, first and foremost, do a landscaping exercise as to see, do we do enough microbiology across the country in government hospitals, private hospitals, district hospitals? Do we? And what are the areas for improvement? Can you suggest what should be an optimum microbiology setup in a district hospital? When you do the landscaping exercise, you may find that it is actually perfect. There's no need to improve it. But perhaps there may be. So could you please create a template for this? Because this should be a national movement. Only then the treating physician would depend on microbiology, would wait and of course, institute rational therapy. So we need to be liberal with our laboratory. We need to set up laboratories. We need to teach our colleagues how to interpret laboratory findings. And therefore, promoting creation of microbiology laboratories should be one of your missions. And measure it. Today, if there is X presence of microbiology laboratory, can be moved to 2x in 10 years, 5 years, 3 years, as you may deem fit. But if you don't promote laboratories, investment in laboratories, if you don't talk about it, then it could be missed by other planners and other people. The fourth learning is target the pathogen. Be as specific to the pathogen as possible. That, of course, is dependent on microbiology. But even when we get a microbiology report, we continue to be shooting everywhere rather than shooting at that bullseye. So we need to train ourselves to target the pathogen and have confidence to target the pathogen and not target an army, which is not there in any case. And the fifth point is to teach our residents and colleagues that we should stop antibiotics if the parameters are negative. Once we start antibiotic, then it rolls on for a certain period of time, typically 7 days, 14 days, 21 days. But we must learn to follow the practices, evidence-driven practices, which allow us to stop an antibiotic sooner than later. And there are at least some settings that I am familiar with. Yes, we need not go all the way necessarily. And of course, we must go all the way in another setting. But there are settings where once you rule out infection, or once you attempt to rule out infection and the data comes negative, stop the damn antibiotic. Why should it continue? And by the way, apart from antimicrobial resistance, it also knocks out the kidney or knocks out something else and brings in another infection in the form of fungus, for example. So we should promote this, and this is what I learned painstakingly. And my next theme, and the second last theme that is to promote the idea of antimicrobial stewardship programs. If you have to promote one area of work, one theme, one mission, I urge your society to create a national movement on antimicrobial stewardship programs in the country. Again, to kindly undertake a landscaping exercise. How many departments, institutions, hospitals have an antimicrobial stewardship program? If 70% of them have, perhaps we can do something else. But if only 1% have, then there's a challenge out there. Because antimicrobial stewardship program is a way of life. It is a super protocol for all of us to follow. It is a norm. It is for me, when we treat diarrheal disease, starting zinc on day 1 in a child with diarrhea is a norm. Giving ORS is a norm. Similar, I think in today's time, for your mission, this should be your mission, to promote antimicrobial stewardship programs in a systematic way and demonstrate places where it is being done. Train people to do so. Give confidence to do so. Create resources to undertake optimum ASP. This would need some resources, but not huge resources. Create champions. It is set down. It should be a norm in every hospital. How can antibiotics be used and misused? One major part of prevention and preventive effort is truly the antimicrobial stewardship program. The two principles that embrace antimicrobial stewardship program is formulation restriction and pre-authorization. Antibiotics are not available to be prescribed unless a positive decision is taken and pre-authorization is given. We introduced this in our department, and in any case, even informally, it was there for a long time. But it does mean the following: that carbapenems will not be prescribed by a resident at all. And the highest end antibiotic, even in the entire department, I made sure, can only be done by me. They have to present a case to me. I'm not specialist of every specialty, but this is just to make it difficult for people to jump to the so-called high antibiotics. They take liberty with higher antibiotics. So we created allowance for this MSSA group, which can be given by a resident at the start of treatment of pneumonia infection. But then when you move
Unmute sensor, please.
then this is to be done by the unit head. And then a certain antibiotic can only be prescribed or at a certain level through a committee to preserve antibiotics for future. The second principle is the prospective audit and then responding to it. It has two facets. One is to audit the use of antibiotics. Because then you should see how it is changing with time. And you demonstrate that change is possible. Show that the change is possible. And you can preserve it. We have seen this happening myself in our own program, and it's well documented. It's an evidence-based practice. ASP is an evidence-based practice. You can demonstrate that the antibiotic choose and you are able to save those antibiotics for and the other order, which means tracking the antimicrobial profile of infection changing or not changing. So both facets, one tracking, antibiotic dosage tracking, as well as microbial tracking. Actually, the latter part in any case should be a part of the additional part is only to affect how we are using health conditions, and that will be prescribed. And then the next one, and then the next one. It's difficult, but take liberties with everybody. And likewise, of course, I think we should add to this continuous surveillance of the protocols of infections, etc. And that is working hand in hand with the part of hospital.
Unmute sensor, please.
It relates to you are making it between. And my last point is in relation to research and innovation. We need information to track where we are. We need to understand the dynamics of infection and especially heard with regard to mucormycosis, etc. is so relevant and contextual. So we need data, we need information, we need research infrastructure. Surely this should be a part of the endeavor. But as bedside diagnostic, rapid diagnostic, which can tell you whether this patient has infection at a certain time. We have been hearing about that area, that rapid diagnostics in hospital infections are possible, but progress has been missing and can we move in that direction? And I assure you that in the ICU, there are enough resources we'll be happy to connect you to resources, happy to connect you with industry. And I want to emphasize here when the time came for COVID-19, almost 95 diagnostic tests were established in India. Antibody tests, RT-PCR tests, and she should be the same emergency and clear pathways to rapid diagnostics, and India can do it. And last, vaccines that protect patients against hospital. There's truly a scope in several settings, but vaccines which can protect individuals. These are frontline solutions. Hospital of infections is sad against our dictum of doing no harm. And antimicrobial resistance is going to cost 10% of India's GDP by the year 2050. Nation has a very important role in this very critical area. Life and death. Wish you the very best in your endeavor. Thank you once again, Dr. Jain and your team, for giving me this opportunity to converse with you about the conversation. I hope you pick up on some of these ideas if you please.
Thank you, sir. I mean, it's amazing. It's just you're just like a magician, sir. You kept all of us. You know, both the years. If I wish I had 20 years to listen to you what you said today. Keynote. Not only you know, each and every sentence that you spoke was a keynote in itself. So. I mean, the way you are passionate about infections, especially in the specialty, and also in AMR that we are seeing more with gram-negative throughout. And you said that from 80s and 90s. Very well brought out, sir. You know, the advices that you gave for HISI, we assure you, sir, many of those we have started working on it. We have a platform on HISI, which is called as Hisicon, and this is an educational activity on AMS. So that is already in that. It's been programmed by various experts across the country. And you know, only thing is we have not mapped. You have given us a wonderful idea, sir, of mapping it, and we will definitely come across with a you know. Something like a project and submit it to you for your kind guidance. So that would be wonderful, sir. What a wonderful idea, sir. So we'll map through, and then definitely you told us to work together. Yes, sir. We always have been, because in our individual institutions we may be as good, but combined for the nation, definitely the work has to come together, sir. And you also emphasized on need for protocols, processes, and training. So all the three, and orientation of the people who are doing those processes. So very well said, sir. And also the engagement and empowerment of the junior doctors and nurses. So that is something which, again, sir, gives your vision very clearly. The nurses definitely have a big role to play, and you would be happy, sir, that this organization has a good number of nurse members who do a wonderful job as ICNs and otherwise are interested in them. So, in fact, in our own board also, we have two great nurses working for the cause. You talked about HICC, sir. That was wonderful, in fact, because that has been a vision for HISI also. And we'll definitely again map the hospital, sir. Again, you advised that you know, to map it with our own goals, and then spread and promote PCI through HICCs in different hospitals, different level of hospitals, catering to their needs. So that's something, sir. We'll definitely, we assure you that we'll be working together on that issue also, sir, with the government. Sir, on antimicrobial policies, very well said. This is the time, sir, then, you know, because India has definitely exhausted with the resistance that we are seeing across, but hope is there. Hope is there with this government coming up in a major way with interministerial, you know, deliberations, and realizing that it is not only human health, but there is a lot of other ministries which are involved, and you are rightly under your leadership and guidance, we can visualize that very well, sir. Sir, another aspect that you brought out, I mean, I can spend hours and hours talking about the keynote, sir, but we will just mention out that investment in better microbiology labs, I think that's a very good, you know, impetus for all of us. In all our institutions, whether we are administrators or we are, you know, working in different specialities or super specialities, to take up that onus with our own managements. And obviously, we will again require, once we map as on HISI basis, we'll definitely submit it to you for your own guidance. So the whole project would be actually submitted I assure you that on behalf of HISI, and Dr. Jain is here, so and many other esteemed members from HISI executive. So we assure you that we will definitely take up that cause, sir. You talked about AMSP in a big way, sir. So it's a global phenomena, but at the same time, India requires it much more, and especially when we talk about again landscaping by HISI. So I have already said, sir, and assured you that we will carry out the Hisicon activity, the program that we have developed. It has got various modules, including a nurse module. So what nurses can help out in AMS. So we have got 6 modules with some modules in it, and definitely we'll share that with you, sir. Sir, I mean, we can go on and on. But at the same time, it is an honor and a pleasure to listen to you, sir, and also listen to your views, your vision about India. And I think once because in one of our commitment, we have said the 6th strategy was that India should assume leadership. So, and that is under your kind guidance, sir. I think that is becoming very, very clear, sir. Very clear. So that is what was we wanted to hear from you, that how we are progressing. What is your vision, sir, for India? And I think we will all come together, sir. We all come together and lead your force from the front. So that is something which is. Thank you, sir. Thank you so much, sir. Thank you.
Dr. Paul, I'll again take this opportunity of thanking you on behalf of the HISI. And as Dr. Sardana has already said, we have noted down all the suggestions made by you. And again, we will assure you that we will work on all the suggestions that you have given. And Dr. Sardana has already taken note of everything also. Thank you very much, Dr. Paul.
Thank you. And I think now we move forward with our session after this beautiful talk. It's my pleasure to introduce Dr. Ganga Khetkar, who is presently Dr. C.G. Pandit, National Chair at the Indian Council of Medical Research, and he's a Padma Shri awardee in 2020. He's the former head division of epidemiology and communicable diseases at ICMR. And as a head, he managed research and contributed to public health response in recent outbreaks of COVID-19. He's a member of the National Task Force on COVID-19 and also a member of Clinical Research Epidemiology and Operational Research Group on COVID-19. So from that end, he has been leading various policies and processes and the programs on the epidemiology of communicable diseases. And even in it has been great. So I think we move ahead, and without coming between the next talk, which is a very important on everybody's mind, is how do we prepare for our healthcare for the third wave or a possible pandemic in our country. So Dr. Ganga Khetkar, please. Thank you.
Thank you, madam. Let me at the outset thank Dr. Sardana and the entire team behind this particular prestigious conference. I was asked to deliver a talk on preparing for third wave or future pandemics. All the views that I'm going to express are my own personal views. We know the virus is extremely smart. things can suddenly change. But it's not my fault. No, we are adjusting to a dynamic situation. And what is also important for us to understand is first question that we need to handle is the third wave over as of now? Now, all of us must remember, January 2020, the new year started with a asymmetric warfare. No, there was a virus which was spreading through respiratory route. It was infecting people largely. Majority of them used to come out as asymptomatic infected individuals. So you didn't know the source from where the transmission could occur. And it was killing those who were weak and older, weaker with the chronic morbidity that they had. We know the drivers of vulnerability: population density, mobility and migration, inter-country travels, and difficult to sustain non-pharmacological interventions, whether at individual level or at the population level. And these become crucial if we were to understand how we would respond in the long run as such. We took this virus very seriously. Within 2 weeks of the report from China, the first meetings that started at the highest policymaking level were initiated at that juncture, which was hitherto unknown. No, I had never seen any such kind of a coordinated response. The result we all know: we went in for lockdown. Subsequently, there were successes of lockdown that we delayed the onset of this outbreak in our country. It also helped us to enhance the capacity to produce different supplies, also ensure that the diagnostic tests would be available in every nook and corner of this country, and also importantly, try and ramp up the healthcare infrastructure, not only in terms of beds, but the trained manpower that was required through telemedicine. Today, if you reflect yourself on what has happened, we had a large second wave that followed after a delayed onset of the first wave that was witnessed earlier. And why did this occur? Most of us tend to believe that this is because majority of the infections that tended to occur in the second wave were from Delta variant, and this was slightly different kind of a variant because it not only had higher transmission efficiency, it had lesser incubation period. So you saw clusters of infections that were occurring even within a family. And then there were very high viral loads that were noted at that point in time. Now, if you actually look at these variants, the way they are developing, one of the best countries which has been doing genomic surveillance far better and regularly across in the world was United Kingdom. If you try and look at what kind of variants were seen in UK, you realize that there was always a replacement of a predominant strain which was related to the attribute of high transmission efficiency, and one, the introduction of this particular variant within that country per se. If you look at where we are, you find Delta has a better transmission efficiency over Alpha, and Alpha over Beta, and Beta over Gamma, but we don't know what would be the next one. If you look at Delta variant today, you find most of these countries, especially UK, even India for that matter, the proportion of people who are getting infected by Delta variants, wherever genomic sequencing have been done, you realize that the frequency is reaching close to about 100%. In India, it is currently around 92%, which means the strain is completely replaced as of now. Now, what is the impact that we had to expect then? In a vulnerable population, which is unexposed or largely unprotected since they have not taken vaccine, there would be dramatic rates of new infections and hospitalizations that would follow. But then when you look at the current situation and try to think about the third wave, one of the thoughts that comes to one's own mind, that the recent Zero survey that was done, it tended to show you close to about 2/3 people were actually having antibodies against COVID. But you need to think about it little differently, that we need to read it from a vulnerability point of view. You still find that close to about a third of people continue to remain vulnerable. And when we say third, we have to remember that this proportion of vulnerability can essentially lead to a very high number that could be generated if they are exposed to this particular virus subsequently. Now, one of the things which I feel is important for us to understand, and that is the optical illusion that tends to lead to different inferences that we can draw. Now, currently, most often people tend to discuss about third wave, and that has been happening from perhaps last 1.5 months or 2 months time. One thing which we have to realize, this particular illusion is only occurring because the peak in the first wave was at around 4 lakh, whereas if you look at 43,000 as a number that you see today, which is consistently around 40,000 as of now, it tends to tell you that we are nowhere nearer. The decline has definitely occurred, but we have not reached baseline. If you look at the peak that we had in the first wave, it was close to about 98,000, and the low that we reached was around 9,000 at this juncture, but we are nowhere closer at this juncture. So there is still a likelihood that the second wave is not over. We need to recollect that the this particular second wave has been severe in rural areas where access to testing and hospitalization is low, and that is at a backdrop of vulnerability. That is, the prior exposure in first wave was comparatively lesser in the rural areas, and all of us know, whether it is rural or urban areas, the COVID appropriate behaviors are not being followed up. There is lifting of lockdowns that is occurring across, and then there is lower vaccine coverage, which brings in lot of vulnerability in the population. So what are the possible scenarios? You could actually see an extended second wave, and that would have perhaps localized outbreaks as one of the scenes. The second thing that you might see is there would be a longer interval between second and third wave, about 4 to 6 months time, and a shorter third wave that you might eventually see. There could be highly localized outbreaks that may lead to development of what we call as endemic infection per se. But if a new variant comes that can defy the infection or vaccine induced immunity, then perhaps a dangerous third wave that could come, which could affect the older and those who had chronic morbidity. Now, all of us recollect the horror stories that we heard about the second wave. There was an unprecedented challenge that we saw across, whether it is in supplies related to oxygen, whether it was medicines, whether it was, the agonies that people had to face in different spheres per se, including hospitalization. But all of them could not have been so easily anticipated, given the fact that we could not understand the high level of transmission efficiency or predict the high level of transmission efficiency that Delta showed, and therefore we remember those scenes more often. But if you try to look at what is essential for all of us to think about, the rate of occurrence of daily new cases is unlikely now in near future, is unlikely to be high in urban or population dense areas that experience severe second wave so far. However, it will continue to put a stress on hospitals in rural and peri-urban towns. The linkages for teleconsultation and oxygen plants and supplies need to be ramped up in that particular area. We need to predict places where this outbreak can be severe. And what do I mean by that? We will need to develop a vulnerability map. So far, the vulnerability maps have been based on drivers of infections, which we looked at earlier. But then now you have access to district-wise seroprevalence data through surveys that each of the state have undertaken. You need to look at vaccine coverage of 45 years plus population, because this is most important from risk mitigation point of view. Availability of ICU beds and also trained manpower and oxygen plants in areas where vulnerability is high, and at least 2 weeks of supplies for providing services should be made available, because the focus in this particular phase that we are witnessing has to be more towards decentralized approaches rather than centralized approaches. When mutants develop, what is the impact of these mutants? They can impact many things. One is transmission efficiency. It can also impact disease severity. the diagnostic test. It can also impact the protection from natural infection or vaccines and can reduce the utility of monoclonal antibodies. Now let's look at what might happen in near future. Is it likely to impact the diagnosis? Definitely not. At least so far we have been lucky. Delta variant continues to light up the S gene, because the more this spike gene is going to mutate, the fear will be there could be a variant which will not be detected by conventional tests as easily. Now, in any suspicious or abnormal cluster that we see, unusual presentation that we may observe in the clinical setting, one may resort to genomic sequencing either through the INSACOG network that is already established, and of recent, they are actually trying to approve the private labs even for genomic sequencing. This could help us in undertaking efficient genomic surveillance. When it comes to therapeutic drugs, all that we know, it was a saga of dropping ineffective drugs. We took one or the other molecule, most of them were repurposed, and kept on dropping them. But what is the near-term impact that we are likely to look at? The binding of the monoclonal antibodies to Delta variant is known to be reduced, and therefore there would be a worry. The current one that is available, which is casirivimab and imdevimab, may still remain optimally functional because casirivimab still retains the ability to neutralize this particular virus. But the Eli Lilly monoclonal antibodies are definitely going to be challenged by this particular virus. And one thing which we have to remember, that this is going to be an evolving situation. So we will have to keep a watch, do lab studies, and then take decisions how to treat these people appropriately. What is most important is practice what you know the best. Now, these are very simple things. All of us have seen that it was high flow nasal oxygen, prophylactic anticoagulants, and prone positioning. They helped us most, in addition to quality management of chronic morbidity and steroids, which actually helped us to tide over the crisis as of now. But does this mean there is nothing in the newer drugs that might be coming up? You must realize that there are huge number of trials that are currently ongoing. Perhaps one of the molecules that may come to India, which is molnupiravir, is also likely to be very promising. This is also undergoing studies across, though these phase 3 trials have not yet been even completed in US. But we look forward to some drug molecule which will help us control this infection really well. In absence of any curative intervention, can we control this virus? We need to remember that adherence to COVID appropriate behavior has a protective effect of close to about 85%. And this protection, additionally, we need to look at protection that comes from natural infection and also vaccines. We know vaccines protect against severe disease or death per se. So the best way to prepare for third wave is through rollout of rapid rollout of vaccination, whereby we could prevent the emergence of the third wave. When we think about it, at the backdrop of newly developing variants, we realize that the vaccines are losing efficacy if you try to estimate their efficacy per se. But even if that is occurring, we were still feeling that we may still move forwards with the vaccines. But a shock did come through a Merck developed vaccine, which is called as CureVac, which had only 47% of efficacy, and they had to drop this vaccine altogether from this phase 3 trial results per se. When they look back, they realized that majority of the people who were acquiring infection were acquiring it from variants of concern or variants of interest. So therefore, it becomes extremely important for us to understand that we need to vaccinate people very quickly, even if it means that there could be one dose that could be given, you could provide 2 dosages, still, no, you would still be successful for one simple reason. One dose, even if it is less effective, if it is given after natural infection, because your 2/3 population is already exposed to this particular infection, you might find that we will be able to stop this infection a little better, and the third wave may be curtailed to a larger extent. Do people need to worry about the vaccines, whether they would be working against the newer variants that are coming. If you look at the antigenic space plot, you realize all the vaccines that are currently available, you find that they work against any variant that has come out so far in the world. If you look at what is the impact, you find that there are places, there are countries where you find that there is a new wave that is surging at this point in time, even in the Western world. But when these new waves are coming in better immunized countries, you realize that the hospital admissions continue to remain very, very low. And the same is the story of patients in ICU. And why am I showing these slides? One reason is, if you are to prepare for the third wave, assuming that before the third wave, we will be able to vaccinate people, perhaps the hospital needs might be minimal than what we are worried about this particular issue as of now, unless a variant tends to come of a different kind. If you look at the current vaccine coverage, we know that as of now, we perhaps have immunized close to about 25% of our population with at least one dose, and 60% of these dosages have been given to 45 years plus population. What is critical for us is to mitigate the response, mitigate the impact that might occur on health infrastructure, and that can be done by ensuring that there is 100% coverage of 45 years plus population, which would perhaps make a huge difference in terms of the third wave per se. Is rapid rollout possible? When you look at the circumstances where we are with respect to supplies, and then our target to reach to December, where all 18 plus population would be immunized, people tend to worry whether it would be possible to reach there. If the supplies are right, you just look at China. No, if China could provide dosages close to about 125 crore dosages between April 15th to July 15th, I don't see any reason why we can't reach that, because our healthcare infrastructure is as strong as one could imagine. Today, China has given only single dose of 158 crore vaccine dosages across in the country. And this becomes critical because unless we go for a rapid rollout, you might find that we would be handling a mirage of herd immunity. If a new variant comes, and perhaps it has the ability to challenge these vaccines, you will find that the goalpost will keep on changing over a period of time. And that would become extremely important for us to understand, because if you actually look at vaccine hesitancy that is seen elsewhere also, you realize that there is a hardcore group of anti-vaccines, and this particular group may actually be around 20 to 25% of the people. And if the Western world is facing this, we should start our own efforts to ensure that this situation doesn't arise in our population. But if that has to happen, what is it that we will have to do? Engage the community using peer-led or community opinion leader model, or use BCCs to try and ensure that people tend to not only adopt but sustain these changes in behaviors that are actually required to control this infection. Healthcare systems will have to gear up to meet the challenge of rapid scale up that happens. Now, rapid scale up in terms of vaccines would essentially mean private sector could also participate, but at the same time, if they are not participating, at least they could promote use of vaccines in the people or the patients who approach them for consultations per se. If a third wave will come, one of the issues is, will children be affected most? It is unlikely. With the variants, the adults and children appear to have got infected equally as of now. There is a high level of innate immunity, which we tend to gradually lose as we get older. And generally, in children, this is likely to be a milder illness. But does this mean we should not prepare for the third wave to affect the children? Perhaps not. You need to prepare that. And one needs to also think that investments in increasing the pediatric intensive care unit beds and the training that could be imparted to make them functional can help in the long run in terms of health investments that might occur. Now, why are we worried more about it? One must remember that one of the studies clearly tended to point out that in low incidence setting, travel may introduce newer variants. As of now, we know there is a definite declining trend that we are seeing in India. But now our worry would be whether a variant tends to come from any other country where it has developed. In high incidence setting, perhaps you cannot think in terms of travel alone as one of the reasons why variants have been introduced or developed per se. But we need to be careful. We need to develop a stronger regulatory approach for travel in terms of handling those travelers. One of the issues is inequity in vaccine rollout. If you look at the global situation, 397 crore vaccine dosages have been administered. Daily, about 3.5 crore people are receiving vaccines. Only about a quarter of the population so far has received one dose. And among them, there is a disparity. Those which are wealthier 27 countries, they have received large proportion of these vaccines. Even if you reflect within the country, there are differences between urban and rural, men over women. Now we need to be mindful of certain facts, that if there is a world that is partially immunized, we need to worry whether the mutant that is likely to develop, would it be a stronger escape mutant. If you ask me, one of the things we have to keep at the back of mind is a stronger escape mutant. If we were to look at those countries where it can happen, could be UK, USA, Brazil, and UAE. And when it comes to transmission efficient mutants, you still have a scope that in India, Russia, and Indonesia, another transmission efficient mutant would perhaps develop. Newer vaccines will continue to chase these escape mutants. These are first generation vaccines which do not have sterilizing immunity. But you might find that if the vaccine manufacturer has to switch off, they switch on and develop a newer vaccine, they are likely to require 2 to 4 months of time in order to develop that. And each vaccine manufacturer is trying to reduce the duration that it requires to develop a new vaccine. Now we come to the last part. How do we prepare ourselves against future pandemics per se? Now, few questions that we need to understand is which organism should be the one that we should be worried about in India. If you look at emerging infections, we are already handling one, the disease X, the COVID-19. Ebola, Zika, SARS, and Lassa fever continue to fall in that particular group. If you look at re-emerging infections, our worry should be around anthrax, which continues to vex certain parts of the country, especially in Orissa. You have Nipah, dengue, CCHF, and KFD, which actually still need lot of thinking in terms of how to control these infections and ensure that they are eliminated to a larger extent. Then there are priority organisms causing antimicrobial resistance, which I will not dwell upon because they have been dwelt very well by Dr. Vinod Paul. What should we be doing on research front in order to understand the future impact and how to develop those policies? We need to carry out Delphi regularly to try and shortlist the priority organisms against which we will have to develop a response. Prepare a blueprint of diagnosis, management, prevention, and early detection of any of those organisms that we shortlist. Establish quality clinical trial networks so that you can discover a new drug very quickly. Keep platforms for rapid drug development ready. We need to develop good drug libraries which are currently lacking in our country, for the repurposed molecules. The bio and gene banks for known organisms that have been reported elsewhere, in addition to what we have, should also be very well maintained. You need to develop cell lines which are required to grow them and ensure that they are alive to use in those circumstances. Keep various platforms for rapid vaccine development ready. Invest in mRNA technology. Genova is working on a different kind of model where it's a replicating mRNA model that they are trying. We still need to have more players into the field so that this technology, which is for future, in ensuring that newer vaccine responses can come, and especially so against treatment of malignancies, perhaps this would be a useful technology to develop in India. We need to create awareness and linkages for clinico-epidemiologic surveillance. We need to understand that we have a huge infrastructure of integrated disease surveillance program, that is IDSP, which is a huge network. Now we need to ensure that the linkages between VRDL labs and AMR labs and mycology labs, which have been established by ICMR, they become stronger with IDSP. Every practitioner, healthcare practitioner, should be trained to report any suspicious death, which tend to occur generally in clusters, to IDSP for further investigations. We need to give a boost to genomic surveillance, especially on borders between human, animal, agricultural, and environmental interface, which we call as One Health surveillance. And this has to be nested within a integrated vector surveillance and human and veterinary surveillance, which we were trying to embark on when it came to Nipah, when we stopped Nipah in 2019. Unfortunately, COVID and Zika disturbed that entire strategy. We could not work more on that. Healthcare services, infections, we need to recognize infections don't respect geographic boundaries, and therefore we need to establish ID clinics near porous borders and airports in order to handle such infections really quickly and very well. Develop checklists and protocols for management of such conditions centrally and involve the hospitals accordingly. Raise the standards of hospital infection control program in each hospital and train the healthcare workers, especially in private sector or even for that matter in public sector, where the turnover rates of manpower continue to be higher. Encourage virtual telemedicine networks and involve private sector is also a key to success for future. In today's world, one cannot relax by maintaining stockpiles of weapons, foreign exchange, and oil alone. COVID has also taught us one lesson. You need to develop a stockpile of essential supplies for healthcare services. We need to boost efforts to develop, through a stronger industry academia interaction, newer diagnostic tests or point of care tests, antibiotics or antivirals, AI-based tools to assist clinicians when in quandary, and develop appropriate regulatory guidelines for emergency circumstances for their approval, and disseminate ethical guidelines with members of ethics committees across in the country. In conclusion, COVID has brought health to the center stage. Though third wave is largely preventable, a powerful escape mutant can challenge healthcare infrastructure again. Close vigilance is vital. We need to enhance investment in health and health systems. Though KFD actually revealed our inability to sustain the interventions that were actually productive, CCHF, which is also one thing which tells that we could not undertake community involvement, and therefore we tend to see repeated episodes of CCHF outbreaks that tend to occur in Gujarat and Rajasthan more commonly. But we need to also look at our success. We could avert spillage of Nipah from Kerala to other places at a time when perhaps things could have had been really bad. We can do it if the public and private sector works together as we did in COVID, and I'm sure we would be able to avert the newer pandemics if they were ever to come. Thank you.
Thank you, Dr. Ganga Ketkar, for an excellent and illuminating talk. And you saw us through the entire history of COVID, how this COVID affected us in India and how we tackled it, and so many issues you have touched upon, and how we could, face the third wave, which may be imminent, and what we could expect, and how we can, gear up our systems and how we can gear ourselves up, and also the very, very important issue of sticking to the non-pharmacological interventions and the rapid rollout of vaccination, which is still actually the succor for us today. And you also showed us that this is just not COVID. We could be facing other emerging infections in the future, and we have to be prepared, and how and our various systems and even our research should cope up with it, and we should be well prepared. So thank you so much, Dr. Ganga Ketkar, for this extremely excellent talk. And I'm sure we are all very well informed now about the situation we are in and what we can do in the future. Thank you so much.
Thank you. Thank you.
I think we can go to our next speaker. Dr. Adarsh Chaudhary. Dr. Raman Sirdana, could you introduce our next speaker?
So, namaste, sir, and welcome to the keynote session. So, Dr. Adarsh Chaudhary, whosoever has worked in the clinicals in India, they would not have missed the name Dr. Adarsh Chaudhary, such as his charisma and his overall personality, and also not to belittle his surgical skills, which are extreme. I mean, I am a recipient of his surgical skills. That is what I can say. A long time back, more than about 30 years back, in fact. So when he operated upon, and what a marvelous person. What a marvelous person. Knows his job, so humble, and very difficult to come across. So that was way back in GB Pant Hospital, and now he is working in Medanta, the Medicity at Gurgaon, as chairman of Department of GI Surgery. And I can assure you that the finest surgeons that I have ever come across in general surgery and in GI surgery. So, sir, over to you for your esteemed. We are looking.
Can you share the screen with me, please? Thank you. Can you see my slide?
No, not yet.
No, sir.
Okay.
Not yet.
Dr. Geeta Mehta, ma'am, you would remember him,
Yes,
obviously. So
absolutely. I was just waiting to say my little bit. Dr. Adarsh Chaudhary, I was very fortunate to be, to have you as a colleague when I was working in the GB Pant Hospital. And I just know how dynamic you are and what an excellent clinician surgeon you are, and also a colleague and a friend. So it gives me great pleasure to be here chairing the session. Thank you.
Can you see my slides now?
Yes, sir.
Can you see it?
Yes. Yes, sir.
Okay. Thank you very much for inviting me here, and thank you very much for this introduction. So I don't have a long talk. We as surgeons can't talk much. We do more than we talk. So I've been asked to talk on what happened to surgery during the COVID pandemic, and I'm aware that you all are not you won't be interested in the surgical details, but I must tell you that for surgeons, at least, it was an unprecedented global crisis. We are not used to thinking much. And this is the first time that we had to reconsider almost every facet of our surgical practice. During this pandemic, we as surgeons had 4 challenges. How to select patients for surgery? Did any of our existing protocols needed to be changed? And then we had to consider the safety of the healthcare workers, the surgeons, the anesthetists, our technicians. And a very important facet which has been ignored is the implication of training for the students, because surgeons need to learn hands-on, because there was no much surgery being done. So there were big questions. How will we train our residents in this period for being able surgeons in the coming times? Interestingly, though most hospitals in the National Capital Territory of Delhi had closed and had become complete COVID hospitals, we at Medanta continued to work. We continued doing carefully selected patients, and we published this paper this year where we talked about elective gastrointestinal surgery in COVID times. And that's a testimony to the policy of our hospital, which fortunately had two separate wings so we could segregate the COVID and the non-COVID patients. So whatever little experience I have had in these times, I'm going to share with you. This graph tells you the number of operative procedures we did in the months before COVID and during the COVID months, like in March 2019 and in March 2020. The blue ones signify the non-cancer surgery, the green ones signify the cancer surgery. You can see in April it fell down, and it went to June and July. The numbers came back. Numbers were rising. I must confess that when the lockdown just started in April, there were so many ambiguities, so many confusions. We could not lay down policies immediately. We really did not know how to go about it. But as time went on, we formulated policies, and then we could establish the continuum of surgical care to our patients. There are a couple of interesting observations we made during this period. We realized that some of the diseases which earlier we used to do often in the emergency, they significantly decreased in COVID times. Like less hernias got obstructed. I cannot give you a scientific reason for it. Appendicitis, we operated less because we treated more of these patients with antibiotics, and that made us realize that possibly our threshold for surgery for appendicitis and cholecystitis was low. We used to operate them much earlier, but in COVID times, majority of the patients who could be managed with antibiotics, they did well. It's very interesting that during COVID times, since there were lockdowns, there was less traffic, there was much less surgery for trauma. So we did hardly any surgeries for trauma. Vedanta lies on the near the national, the big roads. So every week we do a major trauma. So fortunately, there was very little trauma in these times, and people were, I think their tempers were controlled. We had hardly any surgeries in the last 9 months for any gunshot or stab injuries, which in this part of the country is reasonably formative. I think people realize the value of life rather than fighting over small issues. So interestingly, such surgeries were done lesser in the emergency. But as expected, there was no decrease in the emergency surgery which was needed for patients who had bowel gangrene, or patients who bled, or patients who had perforation of their duodenum or small bowel. It was not expected to go down. That number nearly remained the same. The biggest challenge for us was to continue the care of cancer patients during this time. So we really did not know how to formulate policies, but the hospital had made a clear policy that patients who need elective surgery like gallstone surgery, hernia surgery, etc., will be cancelled because we had to conserve the hospital resources, manpower. So we all had to limit that. We formulated in Medanta a policy that we will operate a selected group of patients who had cancer. These patients were ones who had either received preoperative chemotherapy or radiotherapy. You must realize that one patients who have advanced cancer, when they receive chemotherapy and radiotherapy, there's a window of opportunity in which we have to operate these patients. If we lose those 4 to 6 weeks, then the entire effort has gone waste. So patients who had received chemotherapy or radiotherapy in the preceding weeks, we had to operate them. And I think it's ethical in these times to offer surgery to them. Also, aggressive cancers like pancreatic cancers or colonic cancers and esophageal cancers, these patients cannot wait for long. So we also operated these patients. Then there's a subgroup of patients in whom we had operated once, and they were awaiting a second stage procedure like a reconstruction of a wound or a construction of a flap. So half of the procedure had been done. To continue the second procedure, we had to do these procedures. Also, patients who had diagnosed to have metastasis or had diseases like lymphomas, we had to do a biopsy, the small procedure, we continue to do surgery in them. And also, as expected, patients with acute symptoms like bleeding and obstruction, they also underwent surgery in the times of the COVID pandemic. This is a table of the operative procedures we performed. During this time, as you can see, we performed all major procedures like pancreatic duodenectomy, esophagectomies, hepatic resections. So we continue to do surgery for these diseases in this time. It's a very interesting story how patients reached us. And it was a great testimony to how human courage is an example of how people drove in their cars all the way from Bihar, far off places, driving 24 hours in a day continuously. And they used to come to us because there were no trains, there were no flights, and people were driving. And then many of them told us that they never knew earlier that the Indian roads were so beautiful they could drive, because when we drive these days, there's so much of traffic, there's so many shops, there's so many people. Our main aim is to weave our way through the traffic rather than admiring the surroundings. So we really admired those people who had the patient in the back seat. They didn't have big cars. Many of them came in small cars, and all the restaurants, dhabas on the roadside were closed. So many of these people, there were stories of courage that they carried their mother or children driving for 24 hours and reaching the hospital. So we offered surgery to these patients. So it was an interesting experience interacting with them, how they carried their food and water. And they said in the entire journey when they drove, they could not meet anybody, nor were there any facilities available on the way. Some gas stations are open, but it was a risk that if the car broke down, there'll be nobody to repair. But such is human mind. I think if you have courage, you go ahead and do these things. And we also, once the first wave settled and patients came, we realized that some of our patients did suffer during this COVID pandemic. There were multiple reasons for this. There were hospital policies. Many hospitals had no policies, that they did not know. They admitted patients. They kept getting admitted, but they were not operated. So they were not referred. So some patients suffered because of hospital policies. Definitely, there was a problem of manpower because the anesthetists, the resident staff in most hospitals were shifted for COVID care. The lockdown caused all the avenues of transport were closed. Patients could not travel. And also an interesting concept, many people thought that the fear of contracting COVID was much more than their basic disease. So there were various assumptions that people had, and they lived in those assumptions and that suffered. And also there was a crisis of the disruption of the supply chain, that our staplers and sutures, some of them could not be available because there was a lockdown and the companies could not manage to get it across to the hospitals. So this was not a very major problem. The major problem was inability of patients to come and reach the hospital. Did we modify any of our policies to operate these patients? We had a routine policy of doing testing before surgery. We will not operate a patient who did not have a COVID test. You might debate it, but that's the hospital policy. I think personally that it is good to do it because it saves the patient also and saves the entire healthcare personnel also who are involved in managing these patients. The associations, some associations did a knee-jerk reaction to COVID and they banned laparoscopic surgery, saying with the belief that the smoke which we have in laparoscopic surgery can cause dissemination of the COVID disease. We did not stop, and subsequently there was also evidence that these fears were actually unfounded. We did not stop doing laparoscopic surgery. We believed that patients should not get inferior treatment just because of an assumption. So patients who had to be hospitalized for COVID, and if they ever needed surgery, we will postpone their surgery unless it is emergency, because there is evidence today that if you operate on a patient who's got COVID, the mortality in these patients is very high. But we only selectively use a CT scan of the chest only for patients who've been very sick or who've been in the ICU. We believe that a routine CT scan for chest for a patient who are uncomplicated COVID infection is possibly an overkill. What were results of surgery? Were they affected by in any way during the COVID pandemic? There was no increase in mortality. The mortality remained the same. You know, whenever you search for a thing, another thing comes out. We observed, it's very interesting, that the surgical site infection rate during COVID times was much lesser than normal times. That just goes to prove that if you have proper discipline in the operation theater, because we had a separation, we are more stringent during those times. There was less traffic. We were using more asepsis. So we had a significantly low rate of surgical site infections than we normally have. It's been a lesson to us. And that teaches us that if we have more discipline, even in normal times, we can decrease our rate of surgical site infections. So what are the collateral effects of learning in this COVID epidemic? One is we are using more and more of online consultations. It is so paradoxical that 2 years back, writing a prescription on the telephone on WhatsApp was considered illegal. And today, it's one of the most commonly prescribed ways of managing patients. There has been increased awareness of microbiology, at least among surgeons. I'm sure if I can lay a bet, before COVID epidemic, if you ask 100 surgeons the difference between a bacteria and virus, 90% of us could not have answered. But now a lot of us have read about it. We've understood what PCR is. We understand small nuances. We become more sensitized to the effects of microbiology, and we have learned more, which is a sad thing that we had to have such a major pandemic and an event to give us learning, but all of us have learned about it. And we also learned about the ambiguities of science, how assumptions drive sometimes treatment plans, which may be overall harmful to our patients. What was the Medanta Medicity policy during the COVID pandemic? And I'm very proud to say that our hospital had some definite policies which kind of streamlined our management. It prevented people from going haywire. There was no ambiguity. We knew what we were supposed to do. We postponed all elective procedures. Like I said, we had a clear plan for surgery, for cancer surgery. Our healthcare professionals were educated for the need of adequate professions. We had a policy of a rotating staff. We never had the same staff during this time. We had rotated the staff. So I'm very proud to say that during the entire, both times during the COVID pandemic, none of our doctors except me, I'm the only one who got COVID. No other junior doctor or any other person got COVID. So since we managed our staff well, none of, except me, nobody got COVID. And also, since our hospital had a dedicated operation theater and ICU for COVID patients, the quality of care, either for non-COVID patients or the COVID patients, did not suffer. So if you have definite guidelines, policies, I think it makes management very easy. Thank you so much for inviting me here. And it's indeed a pleasure interacting with you all. Thank you so much.
Thank you so much, Dr. Adarsh, for this extremely, illuminating talk and from the heart, and telling us how you coped with the surgical interventions during this very, very challenging time. And, I think what you did for the cancer patients and carried on, made a plan for them, and just went on fighting ahead like the COVID warriors you are. And what I like to hear was, and it was so heartening for all of us IPC people, that your surgical site infection rate went down. And that is so good to hear. And it just shows, like you said, it's the infection control, concentration, and probably because you appreciated microbiologists more too, I think, at this time.
You've been teaching us since GB Pump days to get better. I have still understand how you used to be so strict. And this time it proved to us for sure that we should have listened to you more often to do that.
No, but Dr. Chaudhary, you were one of the people who did actually. You were always on our side.
But it was so interesting that even in bad times we realized we can do these things. So now we are doing that. So our surgical site infection rates really decreased.
Absolutely. And that's so wonderful to hear from you. And thank you so much for being with us. Surgeons have already always been a very big part of our endeavors, for infection control, and we have tried to do our best, to keep your surgery safe and your patients safe. So thank you so much
Thank you
for
so much for
being
inviting
with
me.
us
Pleasure.
and for teaching us so much
Thank you.
about this
Thank
area
you.
of work.
Thank you so much. Thank you.
Naman, sir, Naman, every time.
Thank you. Absolutely.
So for the audience, see, there are no questions to on a keynote address. I mean, that would be something, not good, because they are an institution in themselves. So when they deliver a keynote address, they are an institution. So we don't allow questions. So we just listen to them properly. That is all. Thank you.
The presentation.
We have our next speaker, and I am so happy to introduce my my colleague. When I was working in CERO, Dr. Rodrigo Ofrin was very, very respected and so passionate about the work that he did that we used to just listen in the meetings and, be very impressed with how he was tackling, the emergencies in the different countries of the region. So he's the WHO representative to India. And Dr. Rodrigo Ofrin has extensive experience, like I said, and the expertise covers critical issues impacting health of the 11 member countries, including India. Now, he has served in multiple roles, starting as a public health officer in the war-torn nation of Timor-Leste and assisting in setting up its health systems. And leading non-communicable diseases and environmental health department during his stint in 2015, he worked with several teams across the region on climate change, food safety, health promotion, nutrition, and injury prevention. So he was conferred the Director General's Reward for leading Nepal earthquake, response and recovery. And to his credit are numerous publications that he has authored and co-authored in preparedness, in emergency preparedness and risk management. So Dr. Ofrin, we are really happy to have you, and thank you so much for coming here with us and giving your views. Thank you.
Thank you, Dr. Gita. So nice to see you again after all these years. Who knew COVID would bring us together?
Yes.
Together. Thank you for the introduction. I will start with my presentation, and I think it's a great segue to our previous speakers' presentation on the hospital and the need for policies, and I will be going through that. Thank you very much. Next slide. I'll give you an outline. It's a brief introduction on the why, what, wherefore of IPC. It's just one slide. The burden of hospital-acquired infections, etc. IPC in COVID-19, core components of IPC in India, and some lessons from recent past, especially COVID, the two waves of COVID that has hit India, and what are key priorities? Just some suggestions. Are they priorities? So IPC, it needs to be.
So I was a little bit busy yesterday. So I will give me time. I will.
Hello. Oh, okay. Can I continue?
Yeah. Yes, sir. Please.
Thank you. So practical evidence-based actions to prevent infections in patients and healthcare workers. We heard our previous speaker talking about this, the decrease in post-surgical infections, and of course, the decrease in infections with healthcare workers. Needs and action at all levels. This is not just for a surgeon, an internist, Nurses, it's for everyone. Policymakers, managers of healthcare facilities, whether they're tertiary, secondary, or primary. Patients themselves, people themselves, universally relevant to protect every healthcare worker and patient. So sometimes IPC is under the framework of patient safety as well, or occupational health and safety, because it's really cuts across other initiatives. It's impossible to achieve quality healthcare without effective IPC. I think that we can all agree, and this COVID has brought a spotlight to all of this. Affects all aspects of healthcare, including hand hygiene, surgical site infections, injection safety, AMR, hospital operations, everything. The need for IPC programs, I guess, to the previous point, also epidemic control. Need for IPC programs, particularly important in low and medium in the developing countries, where healthcare delivery and medical hygiene standards may be not as far as that of well-developed countries. Okay, the burden. 1 in 10 patients get an infection while receiving care. These are global estimates. Up to 32% of surgical patients get a post-operative infection. 50 to 70% of injection sites are infected, are unsafe. So something happened with the fonts of my presentation once it's shared, but I will relay it to you that and 35% of health facilities in Southeast Asia region lack functional hand hygiene facilities at points of care and toilets. So this is where the world is as of now. It's very difficult if we can extrapolate that to India's situation. The numbers will also be huge. I guess it will be high in some of these categories of data points, but maybe low in others. But just the same, it's a huge issue. Preventing infections begins prior to care also. It's part of the whole care continuum. Healthcare-associated infections, we've heard a few. Central line-associated bloodstream infections or CLABC, surgical site infections, catheter-associated urinary tract infections or CAUTI, ventilator-associated pneumonia. This is the most common in the past 2 years in the treatment for COVID. And of course, epidemic-prone infections, outbreaks. The one thing you don't want is for an epidemic to spread within the healthcare facility, whether it's COVID or otherwise. That's the one thing to prevent. Of course, as an organization of member states, the World Health Assembly has passed these several resolutions. Quality of care, patient safety in 2002, and most recently in 2019, quite a number of resolutions were passed on AMR, global action on patient safety, and water and sanitation and hygiene in healthcare facilities. So you can see that the recent pass is a huge, was giving huge importance to this pre-pandemic. Now, IPC and COVID, I think this is what will bring us to be relevant. And to summarize, IPC is also an individual behavior. For us to get to public health measures, it begins with an individual. So it's about 3 Ws, which I called, it's a summary for washing your hands, wearing a mask, and watching your distance. And now we add 2 Vs, ventilation and vaccination. So 3 Ws and 2 Vs. It's our most effective, even at the outset, the 3 Ws were most effective in curbing transmission. Now we have the tools of a vaccination available to us. And of course, the recent findings, because this was evolving, that actually better ventilation prevents transmission of the droplet nuclei. Okay, this just summarizes to you the point that there were so many guidelines that had to come up and developed and revised. As of now, 14 technical guidelines, all related to IPC. At the same time, revisions for as many as 5 times was done for a few of these guidelines. The one that kept revising was the masks, rational use of protective equipment, home care of patients. They kept revising, upgrading IPC guidelines, etc. The reason probably is also because of this global survey early in the pandemic of capacities in countries. So countries that don't have a IPC control program or for long-term care in facilities, a national policy or guideline is about half. Countries with a national program for IPC and WASH standards in all healthcare facilities, it's down to 39% possibly. Countries that have an occupational safety plan for healthcare workers, very few, 28%. So this is our baseline value. The others have no information. Half don't have information. This was a survey done for member states right at the outset for the pandemic to be able to address certain capacities in terms of the pillars of action. So, but there were collateral benefits. We also heard our previous speaker talk about that. Everyone was very concerned about masking, hand hygiene, physical distancing, DOGA, skiduri. We have heard those sayings. So probably as was mentioned in an operating room theater, people were more disciplined, but that spilled out outside the whole the theater. That went to the public places. People were concerned about washing their hands. So the ban on spitting in public places became part of the Disaster Management Act. There was a focus on use of personal protective equipment, masks, gowns, gloves. It was not only in the ICU, the NICU, or your obstetric wards and then theaters and operating theaters. It was important to wear this even at OPD settings. Then telemedicine came. So that we also heard that it had prevented infections because you didn't really have to get into a crowd of patients. It protected both patients and the healthcare workers. The focus on infection prevention and control for safety of patients, healthcare workers, and the community was the core to stopping the transmission of COVID. And I think it has brought a spotlight to all of us of how conscious we are right now, even on our daily work, not just in healthcare facilities, in terms of all of this. It may be not masking, your cough etiquette, how you wash your hands. Maybe you used to wash your hands very regularly, but you're now more concerned about how better you are washing your hands. And of course, distancing. There are core components to IPC programs. I go down through the 8. There has to be first a program, 2 IPC guidelines, IPC education and training, surveillance, multimodal strategies, which would mean that if you're doing, let's say, awareness, it has to be in different media. It has to be in different settings. It's attacking it in all areas. It's not just in the purview of one part of the hospital or in a healthcare facility, but in educational facilities, and bringing the public with it. Monitoring, audit, and feedback, workload, staffing, and bed occupancy, and of course, the built environment. The physical environment itself, the infrastructure itself should lend to very good IPC practices. So that was the guideline that was provided, but it seemed that that was so ideal. So WHO also came up with the minimum requirements, and I highlight the two that are most important: IPC programs at national level, especially, and a national IPC focal point, which is not a person, but possibly an institute that would do this. And again, in this guideline, there's separate key priorities for each of these areas. What are key investments? Because I think one is public awareness. Let us use the opportunity that COVID has given us of this awareness and take it further. I think it's getting the awareness to wash hands, wear a mask into the public consciousness. Hand hygiene, standard precautions, protocols, and care bundles to be strictly followed. So that you have less of the post-operative infections. IPC compliant infrastructure, I was just saying that the physical environment alone should be able to support IPC behavior. If there is no sink or a tapless, a sensor tap, it's in operating theaters, then it's really important that these simple technologies be there. Some don't need that to be a sensor. It's a foot control tap. So it's as simple as that sometimes. And that technology is available and also affordable, because this has to be seen in the range of all types of health facilities at all levels. Surveillance, of course, how does that integrate? How do you use IT data so that it's IT in your collection of data and analysis so that you're able to do corrective action? Injection safety, no reuse of needles and syringes. Human resource development, the training begins pre-service, for example, so to speak, and continuation of training. So you just saw that for one new epidemic, we have so many guidelines and so many trainings. I'll show you that. Private sector engagement, private sector, the need to regulate private sector and get compliance with certain national policies is so important as well. Example of getting the public join us into IPC behavior. It's COVID compliant, COVID appropriate behaviors, but maybe it's IPC appropriate behaviors that we can say a World Hand Hygiene Day on 5th of May. Should it just be one day? But let's keep it every day. I mean, this will now be how we should be actually all contributing as individuals for a healthy world, healthy population. Training, I was talking about training, the use of virtual platforms. This is the Open WHO platform. This is just for IPC, all the different small courses, standard precautions for rapid response teams, a quick learning, prevention, identification, management of infections in health workers. It's, as of now, 5 million course enrollments just on the IPC modules alone. Now, a quick snapshot of the landscape of IPC in India. Where is IPC prioritized? In AMR, there is National Action Plan for Antimicrobial Resistance. We had this in 2017. It's up for review. And one pillar of this, one strategic area really is infection prevention control at the healthcare facility level, at animal health and community and environment. It is not confined within the human health sector alone. So requires the development for a national plan for IPC and the implementation of IPC policies. Another input is the National Patient Safety Implementation Framework. And A strategic priority area of that is prevention and control of healthcare-associated infections. The healthcare facility should be a safe place both for its healthcare workers and its patients. So strengthening the IPC structure and programs across healthcare services. There might be departments that are more careful about IPC versus others. I think that should not be the case. There are certain practices that need to be really in place. Providing appropriately clean, disinfected, or sterilized equipment. Providing a safe and clean environment by improving general hygiene, sanitation in all healthcare facilities. The National IPC Guidelines, this was launched in April 2020, developed jointly by NCDC and WHO. It is based on WHO components of IPCs, which I mentioned to you, and disseminated now recently, shortly thereafter into tertiary care facilities across India. Training resources have also been developed for this, and I'll talk to you about how we are able to do that even in this second wave. Larger landscape of prioritizing IPC, the Swachh Bharat mission, sanitation and hygiene. This is a huge initiative, globally known in terms of its scale for the country. Ayushman Bharat, PMJ, investments in healthcare facilities, especially IPC, Kayakal program for quality of care also includes prioritizing IPC. There are 804 accredited hospitals, and all these accredited hospitals by the NABH have IPC programs. Maybe there can be more accredited hospitals for the scale of India. ICMR, AIMS, and Healthcare Associated Infection Surveillance Network. There are 40 hospitals enrolled in this. Maybe there should be more. The reuse prevention of syringes project in Punjab and Andhra Pradesh is something we're supporting against scaling up for more states to be part of that or have programs around this. Recently, the letter of the Health Secretary to Chief Secretaries and administrators of all states and union territories to really prioritize IPC and use these the national IPC guidelines developed, especially during this second wave, and to continue doing that. That was a big directive for this second wave of COVID. Now, from our end is through the Samiksha that we produced. Dr. Anuj Sharma, our lead in IPC, has been diligently sending this to you. As some of you, I'm sure, will have received this so promptly, so regularly, wave or no wave, rise or no rise of cases. It includes scientific journals, WHO guidelines, Ministry of Health and Family Welfare, Government of India guidelines, all related to IPC, including the interactions of IPC with COVID and AMR, plus the training resources that I told you about. So it's a good way for us to be able to share all that information, what's available. IPC trainings that we were able to facilitate, especially during this time of COVID. The first one was where it was first one using virtual platforms as well, 280 government officials, 180 field officers, and that cascaded a national webinar on IPC in healthcare facilities in May, and IPC monitoring tools were developed. So in assessments of hospitals that our field staff were doing, this was included. From the first wave and this wave, around 72,242 healthcare workers trained across India, because this was one of the things I was telling the team. Training is also a response. We have to update quick training on the new guidelines for the second wave. We don't know who was trained before. Maybe there's a need for a refresher, etc. And North, East, West, South, UP Bihar are our offices, WHO offices, which we use as a nodal point to cascade the training. There could have been more people trained. Possibly it's just that these are the direct trainees that we are sure that were able to participate in all these sessions that we were doing. IEC, as I said, it's so important. because we need to engage the public. There should be a public demand for health, for infection prevention control practices. And we've done so many. There's that bubble you see, there is a video, is super bubble. So this is to explain how to wash your hands very well. Keep your hands clean. There's that English guideline. There is the Hindi guideline, and I'll demonstrate a little bit for you. It's Sida, Ulta, Muti, Anguta, Nangkun, and Kalayurist. So that's Suman K. You can think of that name every time you wash your hands so you don't miss out a part, and be really a good contributor to infection prevention control. Now, the last part, so that we can have some time for interaction as well, some lessons from the pandemic response. What needs further attention is designate probably an IPC national focal point, not a person, but an institution, as per the minimum WHO guidance on minimum requirement for an IPC for country. Establish a national program with dedicated human resources, because this will be an issue that's ongoing with healthcare. It is about it is not about a subject matter. It is a standard to maintain and see and monitor and keep maintaining standards and reaching higher standards, because it saves lives. I think that's the point. Some will say saves money as well. Yes, saves lives, improves lives, and saves so much money. It's an economic issue as well. Development of evidence-based COVID-19 treatment guidelines to prevent misuse of antimicrobials. So this was also about addressing adherence to protocols, because as you know, especially with the second wave, we saw that everyone had a different way of treating a mild, moderate, severe COVID. Research in all its aspects on IPC interventions. Some of operational research, maybe look into new other technologies for IPC. And the last bit is a few questions. What then would be our priorities? What are our policy options? Of course, training, it's something you can do very fast, develop skills and capacities for IPC at national, state, district, and community facility level. So it's a huge thinking for how do you retool, re-support, retrain a workforce. Surveillance of healthcare associated infections at national, state level and hospitals. Right now, I mentioned to you the network of 40 hospitals and hospital IPC programs, including private sector. So you do have inclusive. It's not a government program for government hospitals, but all healthcare facilities. Strengthen infrastructure to prevent infections. So we may be able to train people, but if the infrastructure does not allow us to have good supply of water, have sanitation facilities, it will still remain a problem. Integrate IPC in health system strengthening. So whenever we think of building new health facilities or even primary healthcare facilities, this should be a part of setting up that standard for facilities when we're training people. So it's really developing policies. It's integrating IPC as an investment in health system strengthening. And should we look at mandatory accreditation of healthcare facilities? As of now, with NABH, we have 804 hospitals accredited. Maybe it should be mandatory. So all of the accredited hospitals have IPC programs. So maybe this should be mandatory to really have accreditation with set policies, and not just for IPC, probably for epidemic pandemic preparedness, so that we will never have issues next time around beds, oxygen supply, etc. So looking at accreditation as a way to keep the standards and to keep it across all healthcare facilities, all sectors, all levels, I would say, in India. I think I will end there. Thank you very much.
Unmute, ma'am, please.
Dr. Aarti, would you like to wind up?
All right, thank you. Thank you, Dr. Afreen. I think it's a very interesting talk of a subject which we have been otherwise always been talking about. And we think we are familiar with this, but I think one very important point. Can you hear me? Huh? Can you hear me?
Yes, ma'am. Yes, ma'am.
Okay, so one very interesting point was that how infection prevention now has reached the communities also. In a way, the two important contact precautions and respiratory precautions now from the hospitals moved on to the community at the public health care level. And something which we have been always striving, I know Dr. Geeta Mehta, to begin with your hand hygiene has now become a part of a practice by and large across hospitals as well as communities. So in that manner, I think what you beautifully brought out was how COVID-19 really helped strengthen or understand the infection prevention. And now we need to continue to training. Again, a very important aspect, train almost 100% of our healthcare staff at all levels. We have we have some very basic level healthcare workers who are not even familiar with English language, so to train in their own language, to focus how that will be useful to them. For example, a lot of our security guards, these are another class of workers which are like community but working in the healthcare structure. So I think that was a very important point. And then what should be our national priorities, what India is already doing. And I think, of course, a lot of work has been done in this pandemic, and I'm sure we'll continue to strengthen our infection prevention practices, programs, as has been already told by all the eminent speakers, Ganga Khetkar. So they have all stressed this need. And as you have also very nicely showed a pathway how we should go about what should be the priorities in infection prevention and control. So thank you so much, Dr. Orphan. So it's very nice listening to you.
Thank you. My pleasure. Just last is to remember the 3 W's. Wash your hands, wear a mask, watch your distance, and the 2 V's. Just vaccination and ventilation. Thanks very much for the opportunity.
Thank you. So I think we move on to the next speaker, Dr. Pallav. Yes. So Doctor, it's my pleasure to introduce Dr. Pallav Ray, who is a colleague, who is a friend, and who is also a teacher. So we learned a lot from him when we were residents. And so he's presently professor in charge of bacteriology section at the Department of Medical Microbiology, PGIMER, Chandigarh. He's been a great teacher, guided more than 150 thesis dissertations, has published extensively in the national and international journals. His special interest is antimicrobial chemotherapy, staphylococcal infections, healthcare associated infections, education, and various teaching technology, which is so relevant in the present COVID times also. He was awarded Dr. S.C. Agarwal Memorial Oration, which is one of the most prestigious awards of the IAMM, and he is the president of Indian Association of Medical Microbiology. So Dr. Pallav, he'll be talking about the resistance, which has been a great challenge with or without COVID. And so, Dr. Pallav, please, my pleasure to invite you.
Thank you.
Thank you.
Good afternoon, colleagues and friends. I thank the organizers of Hisicon 2021 for inviting me to join this August endeavor. I particularly thank Dr. Raman Sardana, for inviting me to be a part of this particular exercise. Resistance in emerging microbes is a topic which is very, very relevant for this conference, particularly because antimicrobial resistance and infection prevention and control are considered to be the two sides of the same coin. And therefore, this topic is very, very important. But at the same time, in about 25 to 30 minutes, it's not possible to go into all the details about resistance in organisms, the mechanisms of resistance and other things. I will rather set the ball rolling by taking you through the journey of Earth, microbes, man, drug resistance, where we stand now, what are the options available to us. Let us start with the journey 4.6 billion years back when the Earth originated. The Earth was a bit too hot. It was being bombarded with meteorites, and there was no oxygen. It took about 1.5 billion years for the Earth to cool down sufficiently so that it can become conducive to life. And the first life forms probably arose 3.5 billion years ago, prokaryotic organisms, anaerobic prokaryotes, because there was no oxygen in the first half of the history of Earth. At the same time, we should also realize that the first 2/3 of the history of Earth, the Earth was totally a microbial world, ruled over by all the microbes, no higher life forms. The higher life forms started evolving much later. And if you look at man, man has a history of probably a couple of 100,000 years or slightly more. And therefore, firstly, we must realize that the microbes, they brought us on Earth. Secondly, that we should not complain about microbes invading every part of the world, including our body. Rather, we have invaded a world which was solely belonging to the microbes, and they brought us on Earth. So you cannot find any part of the world or Earth which is free of microbes. Even 10 kilometers below the ice in Antarctica, the Lake Vostok, when people accessed the water by digging 10 kilometers, they found that it's teeming with microbes, and probably they have not seen the outer world in the last so many million or billion years, for the last so many billion years. You look at our own body, every accessible place is colonized with microbes, particularly bacteria, the human microbiota. And truly speaking, the total number of cells of bacterial or microbial cells in our body exceeds the number of our eukaryotic cells by a factor of anywhere between 3.8 to 10. And they are essential part of our body, making the largest organ of our body, approximately 1.5 kg in weight. Now, that's how Earth originated, microbes came, man came. Now came the antibiotics. And the antibiotics, they posed a threat to organisms and selected the resistant bugs which were already resistant to the antibiotics. Remember that antibiotic resistance existed much before the antibiotics came into practice. Even in the intestines of Egyptian mummies, which were stored long before the antibiotics were introduced, they have antibiotic resistance. So it's said that in 2000 BC, man said that here, eat this root. After 3000 years, in 1000 AD, they said the root is heathen, here say this prayer. In 1850 AD, we became more intelligent, that prayer is superstition, here take this potion. By 1920 AD, with the introduction of the first antimicrobial molecule, Prontosil, they said this potion is snake oil, here swallow this pill. By 1940s, that pill is ineffective, here take this penicillin. In 1955, within 10 years of introduction of penicillin, oops, bugs mutated, here take this tetracycline. And then between 1960 and 1999, 39 years, and there were 39 more oops. And we said here, take this more powerful antibiotic. And gradually by the turn of the century, the bugs have won. Here, take this route, thereby completing the cycle after 2000 AD to a situation where we started in 2000 BC. Let us look at what is antimicrobials and what is antimicrobial resistance. See, emergence of resistance is spontaneous. It's random. And it's independent of antibiotic exposure. Antimicrobials are not mutagens. They don't enhance recombination or genetic transfer. Antimicrobials provide survival advantage to resistant population, thereby they select resistant bugs over the sensitive bugs. And they alter the ratio of resistance is to sensitive bugs. If you look at resistance, we have constitutional resistance, which is present in entire genus or entire species. It's a predictable thing, and we cannot do much about it. Whereas the acquired resistance, it emerges in susceptible strains within a species by either mutation, a vertical process, a slow and stepwise increase in MIC, or by acquisition or transfer of genetic determinants horizontally, which is rapid one-step jump to very high MIC in contrast to a slow stepwise increase in MIC by mutational drug resistance. Look at the timeline of antibiotics. The antibiotics were first introduced in 1940s, penicillin, and after that lots of newer and newer antibiotics came during the golden era of antibiotics starting from 1945 to maybe 1975. Most of the different groups of antibiotics were introduced. And after 1980s, if you look at it, the new antibiotic introduction gradually slumped. But between 1980 and 2000, there were two big groups of antibiotics which came into being, the cephalosporins, third generation, fourth generation, the fluoroquinolones, ciprofloxacin, ofloxacin, pfloxacin, levofloxacin, and others. By the turn of the century, we had oxazolidinone, that is linezolid. Then we had daptomycin and tigecycline. Now, as the antibiotics came, the drug-resistant bacteria also came up. And some of these antibiotics, they survived 10 years or less. Look at penicillin, methicillin, oxyamino beta-lactams, ceftazidime, linezolid, daptomycin, ceftaroline, that couldn't survive even 10 to 15 years before resistant bugs started getting selected out. But some of the antibiotics were luckier. For example, streptomycin, chloramphenicol, erythromycin, vancomycin, imipenem, which survived for anywhere between 15 to 25 or 30 years. Now, this battle between the bugs and the drugs is an eternal battle and has been rightly depicted by this cartoon, where a bird is trying to swallow a frog and the frog in turn is trying to smother bird, and both of them are actually in danger. And one has to be very clever to get rid of the situation. Otherwise, it will bring peril to both of them. Now, let us look at what is the current scenario of antimicrobial resistance. There are many organisms which are opposing antimicrobial resistance. Let us come to the community-acquired pathogens. Neisseria gonorrhoeae, resistance to penicillin, fluoroquinolones, third-generation cephalosporins. Vibrio cholerae, resistance to furazolidone, cotrimoxazole, nalidixic acid, and tetracycline. Streptococcus pneumoniae, resistance to penicillin, multiple drug resistance, Salmonella typhi. Then we have organisms which are posing a problem in hospital practice: Staph aureus, coagulase negative staphylococci, resistance to methicillin, resistance to vancomycin. The gram negatives, enterobacteria, non-fermenters, producing extended spectrum beta-lactamases, carbapenemases, colistin resistant MDR, XDR, PDR organisms. And we have Mycobacterium tuberculosis, which poses a problem both in the community and in hospital practice. Let us look at the different organisms which posed a threat and how they changed over the time. In the 1990s, with the introduction of the third, fourth generation cephalosporins and the fluoroquinolones, which had potent activity against gram negatives and reasonable activity against gram positives, there was a slight decrease in infections caused by Enterobacteriaceae and slight increase in gram positive cocci causing infections. But by 2000, we had MDR gram negative bacteria producing ESBLs. We had carbapenem resistant Enterobacterials, Acinetobacter baumannii, Pseudomonas aeruginosa. Amongst gram positives, we had vancomycin intermediate Staph aureus and vancomycin resistant Staphylococcus coagulase negative and Enterococci. And we had fungi. ITSA has popularized the term escape organisms, which pose a problem in hospital practice. 2 of them are gram positives, Enterococcus faecium, Staph aureus. 4 of them are gram negatives, Klebsiella pneumoniae, Enterobacter species, and 2 non-fermenting gram negatives, Acinetobacter baumannii, Pseudomonas aeruginosa. If you look at the CDC list of dangerous organisms, serious threat pathogens, that also includes Acinetobacter species, XDR, PDR, Enterobacteriaceae, we now call them Enterobacteriales, ESBL positive and carbapenem resistant. MDR Pseudomonas aeruginosa, we have the methicillin resistant Staph aureus and vancomycin resistant Enterococcus, particularly faecium. We have the priority pathogen list for India also. That also includes Enterobacteriaceae, carbapenem resistant, tigecycline resistant, colistin resistant, mainly Klebsiella pneumoniae, to some extent Escherichia coli. We have non-fermenters, Acinetobacter baumannii and Pseudomonas aeruginosa, carbapenem resistant, colistin resistant. Then we have medium priority organisms and high priority organisms. These are mostly the community acquired pathogens except Staphylococci. And here we have Staph aureus, Enterococcus species, and Salmonella species. The drug resistance has gone so high that, truly speaking, if you happen to go to England and visit the Science Museum, London, they have introduced a superbugs section where you can see preserved cultures of multiple drug resistant bugs on petri dishes. Now, if you look at the ICMR surveillance country data for Enterobacteriaceae, all the species together, you will see that less than 1/4 of the organisms are susceptible to third generation cephalosporins. Less than 1/3 of them are susceptible to the fluoroquinolones. 50% are susceptible to beta-lactamase inhibitor combinations. 65% sensitive to amikacin. The same is the number for meropenem or carbapenem susceptibility. And we have colistin. The resistance is building up. Still, we have nearly 95% susceptibility to colistin. But you know already the problems of colistin use as a drug for multi-drug resistant pathogens. If you look at the AMR genes in Enterobacteriaceae, you will see that we have a plethora of antimicrobial resistance genes in the various species of Enterobacteriaceae, starting from the TEM and SHV variants to OXA. And then we have the CTXM15. Out of the carbapenemases, though IMP, VIM are less, NDM is very high amongst our isolates. Look at the non-fermenting gram-negative bacilli. Pseudomonas, which was earlier the bad boy in the group, now has been relatively a better organism when Acinetobacter baumannii, multiple drug resistance, emerged. Nowadays, the Acinetobacter baumannii isolates are, majority of them, nearly 80% of them are resistant to most of the drugs except minocycline, tigecycline, and colistin. Look at the new antibiotics which have been introduced in the last couple of decades from the turn of the century. There is only one new group, oxazolidinone, which was introduced in 2000, linezolid. After that, most of the drugs are actually modifications or improvements of the drugs in the groups which are already available in the market. Some of the cephalosporins like ceftaroline, cefiderocol, and some of the newer combinations of cephalosporins with beta-lactamase inhibitors like ceftolozane, tazobactam, ceftazidime, avibactam, imipenem, relibactam, meropenem, verbactam. This has actually prompted an increase in the use of carbapenems. And if you look at the increase in carbapenem use between the periods 2010 to 2005 to 2010, you will see that India is third after Egypt and Pakistan in the whole world. And if you look at the CDDP drug resistance index data, which is a very complex calculation of representation of drug resistance amongst pathogens against antibiotics, India leads the world at the highest drug resistance index. There has been a lot of efforts at the international and national authorities levels in control of drug resistance and showing the pathways, and lots of documents have come out in the last 1 decade. Looking at the Global Action Plan on Antimicrobial Resistance, World Health Organization. Then we have National Policy for Containment of Antimicrobial Resistance. We have National Treatment Guidelines for Antimicrobial Use in Infectious Diseases by ICMR, which is updated every year. And then we have the Food and Agriculture Organization action plans in antimicrobial resistance and in animal production. India has released its own National Action Plan on Antimicrobial Resistance, which is in line with Global Action Plan on Antimicrobial Resistance by WHO. And if you look at that plan has got 6 components. The first component is definitely to improve awareness and understanding of antimicrobial resistance through effective communication, education, and training. The second one is to strengthen knowledge and evidence through surveillance. Lots of surveillance networks are at this time working, successfully operating in our country. We have the NCDC network, we have the ICMR network, we have the WHO network. Then reduce the incidence of infection through effective infection prevention and control. You will hear much more about it in this particular conference as it evolves. Strengthen India's leadership on AMR. And then we have 2 more points here. The first one is to promote investments for AMR activities, research and innovations. And the second one is optimize the use of available antimicrobial agents in health, animals, and food. I'll talk to some extent about this particular point and this particular point. So this is innovations and research and development. We need new medicines, new diagnostics, new innovations. What are the available areas of innovations, future options? There are many non-antibiotic alternative approaches, and those approaches, in addition to the preventive approaches like vaccines, immunomodulation, infection prevention control, we have many other non-antibiotic approaches of controlling infection. We have antivirulence therapy, quorum quenching, bacteriophage therapy, bacteriocins, antimicrobial peptides, killing factors, non-antibiotic drugs, microbiome modulation, and finally we have optimizing available resources. What is antivirulence therapy? You know that pathogens, they produce virulence factors which help them in resisting clearance and colonization of the body and then injuring the host cells to invade deeper sterile tissues. This principle is that do not kill the organism, just block the virulence factors so that there is no pathogenesis to disease. So disarming and immunity and adjunct antibiotics will clear the organisms if we can disarm them from harming the tissues. It is somewhat akin to not if you are afraid of a dog biting you, it's not necessary to kill it. You can put a muzzle on the dog so that the dog cannot bite you. There are many different approaches targeting toxins by chemical inhibitors, antibodies, the secretory system inhibitors, the monoclonal antibodies against different toxins. Many of these monoclonal antibodies and the small molecules are already in clinical trials. Then we have targeting biofilms, targeting signaling and regulation, particularly quorum sensing. And then we come to bacteriophages. Bacteriophages are one of the most abundant biological form on earth. For each bacterium, it is believed that there are 10 different phages. Some of them are highly specific. Some of them, they are broad range, recognize multiple receptors. They are devoid of metabolic machinery, and therefore they multiply only in the bacteria without harming the host tissues. Advantages being they have a very good primary pharmacodynamics. They grow exponentially depending on the bacterial load. They're highly specific and they have no effect on common cells and no effect on eukaryotic cells. But the problems are they need ID of the pathogen, autodosing. Sometimes by lysing the gram-negative organisms, they will release endotoxins. They are susceptible to mutation and induction of immune response, thus they may become in effect very difficult to purify them, and formulation stability, systemic delivery has remained a challenge. Then we have lysines, the enzymes produced by bacteriophages to digest cell wall and release prophage. There are purified recombinant lysines. Some of the lysines, they are already available. They are used as food preservatives. The disadvantages being because they work against the peptidoglycan, they are usually only active against gram-positives, and possible uses are against staphylococci and enterococci, Clostridia bacillus species. Then comes the bacteriocins as bacterial agents. The bacteriocins are again more effective against gram-positive organisms rather than gram-negative organisms because the smallest bacteriocin is 3 kilodalton and the gram-negative outer membrane doesn't allow any molecule more than 0.6 kilodalton to enter into it unless they have very specific porine specificity or an active transport system. So then we have the lantibiotics, lanthionine containing peptide antibiotics. The term lantibiotics has come from that. There are more than 60 lantibiotics characterized. They are produced by many organisms. Then we have antimicrobial peptides, and these antimicrobial peptides, many of the antibiotics we use, they are also antimicrobial peptides, bacitracin, polymyxins, gramicidin, tiotrothrin, daptomycin, niacin, they are already in use. Some peptidomimetics are in clinical trials. We have certain bacteria which live inside bacteria like the Delovibrio, which lives and lyses Vibrio cholerae. And then we have non-antibiotic drugs with antibacterial activity. The barbiturates, diuretics, mucolytics, PPIs, beta-adrenergic receptor antagonists, antihistamines, NSAIDs, psychotherapeutics, and many of them, they have a combinatorial advantage like beta-lactam with phenothiazines in MRSA, tetracycline and promazine, streptomycin diclofenac like this. The advantage is that all these molecules which are non-antibiotic but has some antibiotic activity, the PKPD is already established in non-infectious disorders. The disadvantage is that the antibacterial dose is much higher than the recommended dose in which they are right now used, and it's very difficult to use them as antibacterials without side effects. Then we have the nanoparticles. The nanoparticles, antimicrobial nanoparticles, some of them, they are inorganic nanoparticles, metals and metal oxides. And then we have the organic nanoparticles, which act as carrier molecules or carrier particles, which kill by releasing antibiotics, antimicrobial peptides, and contact killing of cationic surfaces. So that's about the future research. Now, what we have at this moment, it belongs to the fourth point: optimize use of what we have before we lose them. There should be regulations and regulated access of antimicrobial use, which is only possible by antimicrobial stewardship in human health and antimicrobial stewardship in animals and agriculture. I'll use a couple of slides on this before I end my presentation. So we need antimicrobial stewardship. You all must have heard a lot about antimicrobial stewardship, which is actually the buzzword at this moment. And lots of different webinars and seminars are going on antibiotic stewardship. Even ICMR has a program of extending antibiotic stewardship programs from tertiary care hospitals to secondary and primary care hospitals. It's a multidisciplinary activity to ensure the right drug in the right indication, in the right dose, at the right moment, for the right duration, and monitoring it in the right way. So our earlier belief that the microbiologist's duty ends in telling whether a bug is there and what is the identity and susceptibility of the bug, there the microbiologist's duty ends. Rather, right now, the concept is that is the point where it starts. Now, which antibiotic to choose, which route it should be given, for how long it should be given, de-escalation, escalation, all of these things are extremely important in deciding the outcome in the individual patient, and is extremely important in the outcome on emergence of drug resistance. And the second concept is the One Health concept. That means human health, animal health, and environmental health. The three things are so intertwined together that you cannot address or target one of them without targeting the other two. There is extensive sharing of organisms, both drug sensitive and drug resistant, between all three compartments of human health, animal health, and environmental health. And therefore, one has to look at all three together in an integrated way to address most of the problems, including the problem of antimicrobial resistance. Now, before I end my presentation, I want to show a very important slide, which is my favorite slide. You know that our body has got a huge plethora of microorganisms as normal flora, which our body has actually hosted to carry out the physiological and metabolic functions and immunological functions of our body. And we are understanding them much, much more with passing time and more research work. And they are absolutely essential for our well-being. Whenever there is an antibiotic therapy, we actually kill as side effects the normal microbiota, and that itself has got a very big bearing in the disease process in short term as well as in the long term. So this particular poster came into Nature in 2011, which says stop the killing of beneficial bacteria. So whenever we go for antibiotic therapy, essential to treat an infectious procedure, we must be aware of the whole lot of antimicrobial stewardship so that we minimize the harm to our beneficial bacteria. So with that, I end my presentation and thank all of you for your kind attention. All the best for the conference.
Thank you very much, sir. I mean, it's you people are mesmerizing, sir. I mean, I must say that it is a treat always to listen to the stalwarts and how they bring about linking various aspects and so well. In fact, you started off with actually understanding of how the microbes evolved on this earth, and you brought in the nature into fore. You talked about first life forms to be which had come up on earth, and you talked about what we are discovering in the world, which actually from the whole talk, in fact, it looks like we should not be disturbing these microbes who are lying so dormant. Till the time climatic changes bring about these, we should know about it, but let's not disturb and try to delay. So that is what I think I could get from your talk. And also, you talked about universal presence of microbes. You talked about the human superorganism and the weight of microorganisms that contributes to the human body. You also talked about so emphatically on how they are integrated. We talked about natural resistance, so well brought about, sir, that before introduction of antimicrobial agents, we must look at the natural resistance of various microbes in nature. And because many a times those things are seen that, in our colleagues, when we discuss antimicrobials on bedside, it becomes, sometimes we do feel that our curriculum lacks that sort of active interaction in MBBS days and postgraduate days. Because it should be very clear to them that what is natural resistance. Some of the, like GPC won't, or gram-positive cocci would not respond to the cephalosporin so well as compared to the second generation or first generation cephalosporins. So those type of things are generally not looked well into and also like polymyxin B. The general notion is fine if polymyxin B can act against the hardest of bacteria which are causing infection. So why is it not effective against Staphylococcus? Why do you want us? Why do you stop us from adding on, vancomycin or teicoplanin into this? So one has to, tell them that, okay, fine, things might be covered by certain antimicrobials, things may not be covered by certain antimicrobials. Some of the antimicrobials would not be effective naturally against many bacteria. So that you brought out very well, sir. You talked about a very interesting example of London Museum, where you got in the preservation of superbugs on culture plates, and we would make an agenda of it. I think many of us would make an agenda to visit that once COVID settles down. So you talked about resistance in gram-positive, gram-negative amongst the NIC fermenters. As we know, them of Pseudomonas has been a challenge for centuries, for decades. In fact, I won't say decades. And one of the very difficult organisms to tackle, but still most of it would respond to polymyxins or combinations. Acinetobacter baumannii, everyone knows about that, how badly it affects, but surprisingly, Enterobacteriaceae takes the cake. So we are still, better off dealing with such organisms which we know about more. And you talked about how you linked the 6 components of the national program. Was wonderful, sir. That is what great teachers are, in fact. So how you link the whole program with your talk is something which is, and linking the national AMR program brought out in 2017. So again, HISI was is a partner in that, and we were instrumental in giving our inputs at that time. So you also talked about the newer techniques. Amazing, sir. Yes, world is looking towards beyond antimicrobials. So at one point in time, one used to think about whether it's goodbye to the antimicrobial susceptibilities and such like dependence on labs. I think the microbiology has got much more promise in future. So a lot of things would be there in which the clinical help, clinicals would be requiring microbiology help. So you talked about that. You talked about quorum quenching. You talked about bacteriophage therapy, the advantages, the disadvantages brought on so well. I wish we had more time from you, and I would request that one of the national webinars that we have, somewhere in next weeks, after the conference, we would request your talk, a more elaborative talk on these lines. It would be a lot of knowledge, lot of information, lot of hope that you would be giving to clinicians also, as well as microbiologists to learn from. You also talked about the delivery systems and how the use of license, bacteriosense, and also about antibiotics. And you also talked about the antimicrobial peptides, some of which we know are in use now, so or the derivatives. And you also talked about Vibrio and such like organisms, very well brought out again. One of the very promising things that which you have highlighted and which might silently be contributing, because we used to muse about it when we read about that there are more than 500 drugs which are of common use, even like paracetamol and ibuprofen and such like anti-inflammatory drugs, which do have a suboptimal antimicrobial effect. So how much they are contributing to antimicrobial resistance and what they can do to gram-positive or gram-negative organisms is something which future should entail with microbiology labs. So you talked about barbiturates and mucolytic agents and other things. So that is something which was again mesmerizing with your. You also talked about beautiful. This thing was on the combinations with other drugs. So that is something where like you talked about Tobra and propranolol and Cipro and chlorcyclizine. So a tremendous hope for future which occurs in fracture. So that is something where I think the labs should start working on such things, at least in Indian circumstances, well-established labs, so that we are fully prepared once these molecules are launched. Rather than taking our own time for a couple of years before we actually get used to it. So this would be expected of excellent research labs that we have in AIMS or at PGI or SGPGI or other centers of excellence. So that's something which we definitely would be looking forward to. Sir, your the talk that you ended with microbiota and how the whole complexity of the gut-brain axis and other things, the metabolic disorders that we can assign now to the presence of certain type of bacteria, certain type of lifestyles leading to presence of certain type of bacteria, certain types of diet leading to certain type of bacteria, and what their causation is or association is with non-infective disorders. primarily things like obesity, diabetes, hypertension, psychiatric disorders. I mean, amazing, sir. So you actually brought out the whole gamut of things together in 30 minutes. And I know that justice is not done with your time, but it was a pleasure listening to you, sir. A wonderful and amazing talk, mesmerizing as always, sir.
Thank you.
Thank you very much for being with us today, and we look forward to your inputs with HISI. You are a part of HISI, so you know about it. So we will be banking more and more on teachers like you. Thank you. So I believe we have got 15 more minutes. We have got Dr. Pallab Ray, beyond his talk, if he wants to talk about something, or Dr. Aarti Kapil or Dr. Geeta Mehta, if they want to contribute on something with for the audience. So Dr. Pallab Ray, if you want to, beyond this talk, maybe, because we don't ask for any question answer on keynotes. So just as a matter of disseminating knowledge, that you can say something or.
I don't think let me hear the others' comments.
That's the humble user.
Yeah.
So Dr. Aarti Kapil, would you like to be, or maybe you can engage him better with.
I mean, Professor
So
J,
I was
Dr. Geeta Mehta, they can contribute their views.
I also agree. I think let's hear from Dr. Geeta Mehta. After all these years of trying to reiterate infection prevention, and now in the context of COVID, how it has evolved.
Yeah, thank you, Aarti. I think we all know how important it has become now, and everybody does. So we really, really, I mean, need to put our act together finally. And I think what our country really needs is, I mean, at a national level, we've been singing about this, that we need IPC to be at the national level, a program at the national level, which combines all of us in the private, in the public sector, and go down to the various levels of healthcare. And it's only at the national level that this can happen, because a few of us tertiary hospitals, we are doing everything. We are doing stewardship, we are doing everything. We're doing, you know, patient safety, health, hand hygiene, and winning awards for our health hygiene and I mean hand hygiene. But really, is it trickling down to the bottom? And that is what I think all of us in our society, we should really think about it, because we just have to give back to this nation. We are so well trained, and we have achieved so much, all of us, in infection control. But we really need to reach out and train our countrymen, train our healthcare, our hospitals, and some, as achievement in terms of quality, in terms of care and run the last mile. Dr. Pallab, it was absolutely delight to hear you. I haven't heard of the entire gamut of antibiotics from history, from everything, from the latest, combined so well. It was tremendous. I really wish I was your student.
I'm still, ma'am.
I can imagine how happy their students would be, to hear. And you made the whole big, this whole vast problem seem so simple and explainable and, doable. Hats off. It's really excellent to hear you. And so many colleagues, actually, Dr. Raman, Dr. Jain, you really put all the key notes as such good talks, and such good people to be talking about them. I mean, it was just excellent. Thank you so much, for, sort of giving me the opportunity to be on this forum.
It's
I'm
an
really
honor.
grateful
It's
and
an honor.
happy,
It's
and
always an honor.
I look so much forward to with our society.
Evening also, ma'am,
Thank you.
though we know that you would be far away in faraway lands, but would request you to join at the inauguration today at 6:30 p.m. IST. We have got two orations, ma'am.
I
One
know.
is, about Dr. Brahm Prakash oration. So this year it goes to, it's been awarded to Dr. Shashank S. Kale, who's HOD Neurosurgery at All India Institute of Medical Sciences. So it would be a pleasure because he was one of the treasured students of Sir, Dr. Brahm Prakash. So we thought that, we approached and we deliberated. We thought that this would be a good thing and he has proved himself to be an excellent surgeon. Dr. Aati Kapil would vouch for it. A wonderful human being, also an excellent surgeon, worthy of Sir's love and affection. Second oration in Dr. Ajita Mehta's oration has been awarded this year to Dr. Dr. Priya Abraham, who's Director NIV. She has done a tremendous task in a very difficult task in COVID era. So a professor in virology shifted on to, just 2 months prior to the COVID outbreak to head NIV Pune. A tremendous task done by her and her team. And not a single infection in her lab where they were propagating virus. So that's something which goes wonderfully. So we requested her. I mean, throughout her career, she has worked beautifully on viral hepatitis, and also on HPV, a name in HPV, in fact. So we thought that none better than her at this time. So
I know. I think it's tremendous that we have all these very, very eminent and have done so much to contribute, and
so
we can hear them.
I think we request the audience also, everyone, to log on at 6:30 for the inauguration. And ma'am, if you can make it, that would be wonderful. In fact, I mean, I know that it will be pretty early for you, but try, ma'am. This is just.
Thank you so much. I will try. I'm 12 and a half hours behind.
I know that, ma'am.
So,
but we'll request a presence if that is possible.
Thank you so much.
Dr.
It's
Jain,
at
would
6.
you like to?
Thank you.
Dr. Jain? Yeah. So from our point of view, I think if you have listened to the keynote speakers, one thing is definitely has come out that people are looking forward to his role in HISI's role in India in a big way in infection prevention and antimicrobial stewardship programs. And that is what Dr. Vinod Paul talked at length and repeatedly, not one time or twice or something just for the sake of it that he was addressing us, but he was very serious about our role in these two aspects. And I think none better than this organization. I mean, I won't say that other organizations are bad or something, but I think this organization's prime aim is on those lines, So I think this is the time, sir, we all would be looking forward to coming together, as he said very well, that we should come together and work with the government, under the government's way of looking at the things, perspectives, and also contributing our own way of doing things, implementing things, and what we think, how it can be implemented best on grounds, both with public and private sectors. And India being India, I mean, more than 70% people are still attached to private sector care. So that is something which we need to work very quickly on. So I would be requesting all our colleagues in HISI will be forming shortly, moving in that direction We have implemented the Hisicon activity. It has taken time to mature, but now I think it is an acceptable norm. The workshop which we conducted day before yesterday has been a big success, in fact. So I think and it was based on Hisicons and decreasing SSIs in healthcare institutions and facilities. So that's something which we look forward to. We've got 6 modules, which Dr. Jain had very well put across. So right from how to address the viewpoint of management and administrators down to what ICUs, syndrome-based diagnostic stewardship, how to utilize that to come forward. And Dr. Paul also said something on those lines, that this is a time for the country to invest in microbiology labs. So I think that is a tremendous opportunity for all of us to come together and do it, rather than wasting our efforts in individual lines. So let's have a after this, sir, jaise aap uche samjhenge. So we'll
I'll put it in one line again. Let us build a momentum.
Yes, sir. So that is what it is not. That is what we have been telling people, that it is not CMEs and educational awareness now. It is much more than that. We move on with the healthcare facilities and institutions to work out their infection control programs. So we will looking forward much more and more of these opportunities, and would request that the audience which goes back to their own institutions, they must convince the management to set up a program. If there is no already, if you don't have a program, HICC program or a IPC program in their hospitals, or if something is deficient or more challenges, I would say, if they are facing more challenges, and how Hisicon can be of help to them. So that is some way of interacting with all the people during this conference. If you see the scientific program, it is not just it's not just a patronized situation with what is very familiar, what is very repeated repeated things. No, what we have tried in this program is to go as much diversified as possible, keeping the pattern in mind and addressing as many challenges as possible, giving more and more role to nursing. That is one of the things you will see. One of the keynote addresses by a very eminent nursing official on private sector, but she works very closely. Captain Usha Banerjee works very closely with other public sector units also, and how academic programs can be developed. So she would be talking on those lines. Then we have got a full-fledged section for nursing, where a whole symposium is devoted to nursing, besides sterilization, disinfection, and other interesting topics for nursing. I believe that each one of the talks is for everyone, rather than just addressing a particular staff member or a healthcare professional. So they are, each one of them, each of the sessions and the talks, they can impart a lot of knowledge, lot of resolving of issues and clearing doubts that occur in the minds of people at all levels. So I think please don't leave the scientific program. That my thing would be that since it is all on a digital platform, so there is no way in which one can move out to see the beautiful cities, and I believe that Fatima would have been very happy, and the organizers there, Dr. Haris and Dr. Mohit, would have been very happy to have all of you visit Aligarh. It's a beautiful university. Whosoever has visited, is a beautiful place. Old monuments and good. So with this, I think we'll take about 10-15 minutes off, and then we'll be back at 1:30. So please do not leave don't go far away. Have your whatever you want to have for lunch or something, and then be back at 1:30. We'll start sharp, 1:25 in fact. So thank you, all of you. Thank you, Dr. Gita ma'am, for joining from
Thank you
US.
very much.
And Dr. Ati Kapil ma'am for taking out time. Dr. Pallidev sir, you आपका तो जितना कहा जाए उतना कम. So thank you. Thanks a lot, sir.
Thank you very much.
And Dr. Jain sir, your guidance always. Thank you. So we'll meet in 10 minutes time, please.
This has been a highly intellectual session. Hello? This has been a highly intellectual session. I'd like to thank all our respected speakers for enlightening us, and of course, our attentive chairpersons. All participants are requested to register for the quiz and to download the Mentimeter app. Thank you so much.
Good afternoon. Good afternoon, all dignitaries and delegates. Myself, Dr. Sanafreen. I welcome you all for our symposium on infections. Vaccines have been incredibly successful at stemming the morbidity and mortality of infectious diseases worldwide. I'm glad to welcome our esteemed chairs, Dr. Ashraf Malik, an eminent professor of Department of Pediatrics, former principal of JNMCH and Chief Medical Superintendent. Dr. Shalini Pradeep, notable professor of MS Ramaiah Medical College, Bangalore, an active member of Hospital Infection Control Committee and has been serving as nodal officer for COVID vaccination. And Dr. Uzma Firdaus, associate professor and MARC neonatologist of Department of Pediatrics, JNMCH, AMU. So I hand over to you, chairpersons. Welcome you all. Thank you.
Okay, thank you very much, Sana, for the introduction. And at the outset, I wish to thank the ever enthusiastic team of Hisicon 2021 for organizing this wonderful annual conference. And I just wish and hope that all the deliberations that are being done by the stalwarts in different fields may help in improving the current knowledge and practices of everybody who is participating in this wonderful conference. This symposia is so very uniquely timed, considering that the world is struggling with the pandemic of COVID-19 and everybody wants to know everything possible about the impact of vaccines, how to prevent this deadly menace and how to just uproot that. And for that, we are having a constellation of some wonderful speakers who are doing wonderfully well in their own domains. And to start with, we are having Dr. Deepti Nair. Ma'am is professor and consultant microbiology at Safdarjung Hospital, New Delhi. She's a peer reviewer of over 10 national and international journals. She is also a part of editorial board of Journal of Patient Safety and Hospital Infection Society of India. She has around 10 awards for oral and poster presentation in international and national conferences. She has 43 projects to her credit, and her publications are a whooping number, around 119 publications in peer-reviewed national and international journals, 8 chapters and 2 monographs. And she is credited with more than 15 international presentation and more than 100 national presentations. Ma'am will be deliberating upon the immunology of SARS-CoV and COVID disease. So we will love to hear from you, ma'am, and learn from the vast plethora of experience that you have, and maybe we'll be helped in a very delightful way. Over to you, ma'am.
Given me this opportunity and a very wonderful topic. The topic given to me was SARS-CoV-2 and COVID-19 immunity. I have added this last bit, the immune repertoire, and I will eventually tell you why. So coming to the this slide over here, This was taken as several screenshots from the Worldometer showing the state of affairs on 24th June 2021. And as we can see in the graph, which represents the total number of cases as they're evolving when they cross 10,000 in different parts of the globe, the leading was USA, United States of America, followed by India. India, from the whole pie of COVID-19 infections of the globe, accounted for 17.3% of the infections and was at number 2, and Brazil was at number 3, and Russia and a whole lot of other nations followed over there. The richer colored maroon on the globe's map actually represents the number of nations which have crossed the 1 million mark. And as we can see again, it's the United States of America, India, Russia, and Brazil which have done so. This shows you the situation from December 2019, which shows very distinctly the two waves which are represented by the graph of COVID-19 infecting various regions of the world. And let's hope the third wave does not really come. This is a very hopeful graph which shows the green shows the number of recovered patients, which is always been quite high at about 80. And the number of deaths, which has, after the initial hump, has been reasonably low. So the mortality rate in SARS-CoV-2 hovers around 2 to 2.5%, whereas in its other sister viruses, which belong to this same group, MERS lies at 35% and SARS-CoV-1 lies at 10%. So this is a screenshot which was taken day before yesterday. And what has changed? We have 195 million cases of SARS in COVID-2 infection globally, with 4 million deaths. It's devastating, really. What is one of the reassuring things is that we have fallen a percentage in total occurrence in globally of this infection from 17 to 16.09. And we've also fallen in position from the number 2 position after USA to number 3 position. The rest of the graph remains roughly the same. This virus emerged from zoonotic. It was originally a zoonotic infection and went on to become a human infection. The order is Nidovirales, and there are several families. The Coronaviridae family is what interests us, and subfamily Coronavirinae, which has 4 important genera: alpha, beta, gamma, and delta. The alpha and beta have adapted themselves to become human coronaviruses, or HCOV. The important ones are 229E, NL63, HKU1, and OC43, which normally cause ordinary cold. NL63 and OC43 have sometimes been reported from pneumonias also. The emerging viruses are MERS-CoV, SARS-CoV-1, and SARS-CoV-2. So the emerging viruses happened in the last 2 decades. The first to come through was SARS-CoV-1, which emerged in China in 2002. And the last reported case of SARS-CoV-1 was in 2004. It did not really spread globally. The movement of this virus was, the virus originally was a virus of bats. From there, it moved to the amplifier host, civets, which are a form of, a mongoose-like mammal, and then into man. The MERS virus originated in Saudi Arabia, in Jeddah, and there the movement was from bats to camels, which acted as amplifier hosts, and from camels to man. This happened in 2012. It hasn't really ended. There was a local outbreak of cases with a very high mortality, and sporadic cases are still being reported from that region of the world. SARS-CoV-2 emerged in China in the end of in December of 2019 and has rapidly spread through the globe. It emerged from bats and moved to pangolins and then came into humans. So looking at the coronavirus structure overview, and it's called corona because of the crown of spikes. It is a medium-sized enveloped virus. We would think there's nothing special, but what is most special about this virus is that it has a huge RNA, in fact, one of the largest RNA genomes. And the genome directly behaves, it is a positive stranded RNA, so it directly behaves as an mRNA and can translate proteins immediately. So acute infection. 4 important structural proteins are there, of which the most important is the outermost spike protein, which we can see over here, a trimeric molecule. Spike proteins lie on the envelope and they bind with the human receptor, which is the ACE2 receptors. The other proteins, structural proteins, are the membrane protein, nucleocapsid protein, the envelope protein, and there are several non-structural and regulatory or accessory proteins. The ACE2 receptor was actually acing done by the SARS-CoV-2 virus, because this receptor now, as we discover in this disease, is present literally all over the body. Highly prevalent inside the lungs, in various regions of the lung, right from the upper respiratory tract, goblet cells, right down to the alveolar type 2 pneumocytes, in the GI tract, in the tongue, oral cavity, esophagus, upper intestines, in the enterocytes, in the heart, myocardium, kidney, proximal tubule, bladder, conjunctiva, cornea, etc. So what does this offer? This offers the virus multiple areas for which it can cause disease. The RNA of the SARS-CoV-2 virus is very similar to the SARS-CoV-1. There is an 80% similarity and a 50% similarity to the MERS virus. As we said, it is a positive sense, single-stranded, non-segmented RNA. What is special is it has more than 29,000 nucleotides. So huge possibility of change over here. Another thing which is very special about this RNA is most RNA organizes itself into genomic RNA, or one RNA unit from which everything else is coded and emerges. The new virus emerges. This has not only the genomic RNA, it also forms something called a subgenomic RNA. And the subgenomic RNA actually is responsible for coding mostly the structural proteins and also a few accessory proteins. Along with this positive sense RNA, it also has negative sense RNA. And both these RNAs, positive and negative, undergo transcription within the human cell when they are infecting and multiplying. And this is called canonical and non-canonical transcription. And they code for the structural genes, as we said, spike, nucleocapsid, membrane, and envelope. They also code for accessory proteins, which act as regulator and transcriptor genes. These are numerically numbered as 3, 6, 7, 8, 9, and 10. And 2 large open reading frames, ORF1A and 1B, which code for non-structural proteins. And it is these non-structural proteins which are enzymes responsible for both replication as well as transcription and translation. ORF1A forms a polyprotein PP1A, which breaks down to 11 NSPs, and ORF1B breaks down to PP1AB, which produces 17 NSPs. One of the most important non-structural proteins is the enzyme RDRP, or RNA-dependent RNA polymerase, which is NSP12. This is the entire structure in the form of a diagram. It shows you 29,903 nucleotides. You have the leader sequence, the ORFs, 1A and 1B, and then come the structural genes, and in between scattered are the accessory genes. And then you have the UTR at the 5' end. The spike protein is a protein of immense interest because it is the virulence marker. This is that the differences which have occurred in the human infecting SARS-CoV-2 compared to the bat and pangolin show you its lineage. Therefore, it's important for that too. Apart from being the important virulence marker, it has 1255 amino acids. It is arranged as a trimeric molecule, with the upper end having the S1 subunit and the lower end, which is transmembrane, having the S2 subunit. It is a type 1 membrane glycoprotein. So when the virus enters our body, the spike protein as such will not cause any infection or attachment. It has to be pre-activated or primed, and this is done by a serine protease present in the human cell, which lies right next to the ACE2 receptor inside the pulmonary cells, in the type 2 pulmonary cells. This is the transmembrane serine protease 2, or TMPRSS2, which breaks down the spike protein to its two subunits, and then only this S1 subunit can attach to the ACE2 receptor. This attachment has two very important features. One is that it is 10 to 20 times stronger, the attachment. Therefore, it makes this virus highly infective. The other is that there is an extra hydrogen bonding which is seen with the ACE2 receptor of SARS-CoV-2 compared to SARS-CoV-1, again making this attachment very firm. Gamma interferon which is produced by the human body as a response to antiviral activity, actually increases the number of ACE2 receptors, so that also propagates and allows the SARS-CoV-2 propagation. Another peculiar feature which has been seen in ACE2 receptors is that they have single SNP, single nucleotide polymorphisms, and the scattering of these polymorphisms is different in different parts of the globe. And therefore and also in different sexes. So males and females have a different pattern. This could explain the variations in disease severity and the clinical patterns which are seen possibly. Now, the S protein, which has the S1 subunit, which attaches to ACE2, attaches by virtue of a region which is called the receptor binding domain. And this is the most important region and possibly the region of interest in terms of the immunity and all things that we can do related to the immunity. This RBD has two conformations. One is, it's like a switch, which is one when it's lying down, when it's inactive or switched off, and the other is when it's standing up and it is actually active. So this shows the respiratory tract having various cells which have ACE2 receptors. In the nasal cavity, predominantly it's a goblet cells. Ciliated also have. Similarly, in the bronchi, it's mainly the secretory cells, and in the lung parenchyma, it is the pulmonary type 2 pneumocytes. And this shows you the actual attachment of the virus to the receptor, which occurs with the activation of the serine protease TMP-RSS2. And that causes the opening up of S1 and S2 and the switching of positions from the lying down position of the RBD to the standing up configuration. And this conformational change resulting in a very strong bonding with the ACE2 receptor. So the S1 binds to ACE2, and there is a conformation change from standing up, from lying down to standing up. Now, how this conformational change occurs and activates is not really known. This is the last step and one of the most important steps between the virus and its attachment to the host cell, and we don't really know exactly what happens at this stage. Once this attachment happens, the S2 portion gets activated. This has the fusion peptides and the peptide repeats, which cause the membrane or the envelope of the virus to merge with the host cell membrane. And then the infection proceeds on. So this interaction between S protein and the ACE2 receptor has been the focus of all attention of publications and is considered the key to prevention of this disease. And the priming and cleavage, which occurs because of the enzyme TMP-RSS2, which is the serine protease. Apart from this, there are many other enzymes which can also do the same thing. And the cleavage which occurs, which exposes the S1 and final conformational change, which why it happens exactly is not really known. One emerging infection which came out in 2021, in fact, this is a publication which happened in May of 2021, is that there are other receptors also apart from the ACE2 receptor. So you have neurolipins, sialic acid, CD147, heparin sulfate, etc., etc. And these may be a reason why that a vaccine which is targeting the spike protein and ACE2 interaction is not 100% effective, because there are other methods for this virus to enter. So once the fusion has occurred, what happens after that? The viral RNA enters into the cell. The first gene to be translated from the genomic RNA is the viral replicase. And this enzyme is produced and replication starts. It begins with the translation of the entire gRNA of the initial section of which codes for the non-structural protein, the open reading frame 1A and 1B. And these large polyproteins create a huge cesspool of enzymes. These enzymes, along with their, with the NSPs, actually lie inside a bubble, inside a vesicle. And this complex is called the replicase transcriptase complex. And why does that form? It protects the virus and its enzymes from the human immunity. And it's a very, very clever maneuver. And these double membrane vesicles can now produce the next line of RNA, which is the subgenomic RNA. And from there form the structural proteins and the accessory proteins. The subgenomic RNA has a peculiar feature in that this also gets protected. And how does it do that? It forms a looping attachment with the genomic RNA, within these bubbles of RTC, replicase transcriptase complex. And this nested RNA is characteristic of this order, nidovirales, and one of the reasons why they are very, very successful pathogens. So inside the cell, you have the genomic RNA, you have the subgenomic RNA, which has been formed within the RTC complex, and there are also the negative sense intermediate RNA, and this entire lot actually makes the human host cell into an RNA cesspool. So RDRP enzyme, which is responsible for replication, has a peculiar ability that it can cause the replication of all these RNAs. It's not singly, it's not specific only for the genomic RNA. So it performs rapid class switching, allowing for homologous and non-homologous recombination, which, what is the sequel to that? What is the sequel is that you can create multiple variants of the virus. Finally, after the viral RNA has been replicated and the proteins been translated, this entire lot moves to the endoplasmic reticulum. The proteins embed themselves on the membrane of the endoplasmic reticulum, and the entire virus is going to be assembled using the structural proteins, accessory proteins, and the viral RNA, which is going to be packaged inside. So the viral RNA, the genomic RNA mainly, moves towards the ER using the N protein and the NSP3. And this entire process of packaging is directed by the M protein with its 3 subunits. The final transport occurs from the endoplasmic reticulum to the Golgi apparatus, which forms an ER-Golgi complex. And here the final virus is made, packaged, and secreted, as is seen in this rather elaborate diagram. So this is the portal of entry using the ACE2 receptors, the RTC complex. Here you have the endoplasmic reticulum, the Golgi apparatus, and finally the virus bubbles out through the exocytosis. So here, at this point, we're going to shift gears and now talk about immunity to viral infections. You have 2 limbs of immunity, as we all know, innate and adaptive. This is roughly how the graph goes for any acute respiratory viral infection. Initial is viremia, this thick line, which eventually ends when the body succeeds in overriding the virus. First to rise is this blue line, which is the innate immunity. Then comes the IgM, which is a black line, and then comes the purple line, which is the IgG, which starts roughly around 7 days to 14 days of the initial infection. And this blue haze, which we see over here, is the symptomatic phase. So in COVID-19, the overall knowledge of immunity is still emerging. There are, tens of thousands of articles which have been written from 2019 till currently. As of now, the knowledge is that the immunity is short-lived, probably like the human coronaviruses which cause cold, and those which are like the serious coronaviruses, SARS-CoV-1 and MERS, where maximum immunity was seen for 2 to 3 years. Usually the immunity lasted only 80 to 90 days. However, there is a May 2021 article which examined patients who have recovered from MERS, and what they found was there was B-cell memory which was playing up 17 years later after the initial infection by MERS virus. So is it true that there is only short-term immunity, and can B-cell and T-cell memory be playing a huge role in SARS-CoV-2? So what is the first limb of immunity which we see in SARS-CoV-2? This is the innate immunity, and it is, it starts right from the time when the virus enters our body, which is in the nose. And it binds to ACE2 receptors on the goblet cells, but we have no idea if at the nasal level is the virus being kicked out. We really don't know. We possibly think that there may be some individuals which may be clearing the virus at this level. And why don't we know? Because at this level, the patient is not showing any symptoms. The moment the virus can multiply over here and then move to the bronchi, that is the upper part of the respiratory tree, certain pattern recognition receptors like toll-like receptors and RIG1 and MD5 are triggered on the bronchi. And they start the early type 1 gamma interferon release, which is vital in the clearance of the virus. And how can this virus this virus actually overrides this initial in about 20% of the patients in whom mild to moderate or severe disease happens, is because at the bronchi stage, this primary gamma interferon response is inhibited. And how is it inhibited? They inhibit MDA5 and RIG1 pattern receptors, and they also directly inhibit gamma interferon. And there is a consequent upregulation of IL-6, which starts off the pro-inflammatory process, and symptoms start at this stage. From here, the virus will multiply and move downwards into the alveoli. Now comes the time when the virus dominates and our immunity starts receding. Here it binds the type 2 pneumocytes, and what happens is they're helpless. They start dying. Programmed cell death occurs, and as the cell death is occurring, they release CXC motif cytokines of CXCL1, 5, and 10. These attract the phagocytes over here, because what is it trying to do? It's trying to restrict the infection and inflammation to one site. Unfortunately, what happens is the neutrophils go on overdrive and they create what is called the neutrophil extracellular traps. These are little regions in which you have the phagocytes, you have a massive amount of cytokines released. The first level of cytokines, which are the CXC types, then the second level, which are IL-6, TNF alpha, IL-1 beta. And at this point, the cytokine storm is starting. So the disease has gone from what was mild to moderate to severe. And then come the later cytokine, where there is further IL-6, IL-8, and VEG1 and MCP1. This results in a vicious cycle of vasodilation, inflammation, and fibrosis, which occurs inside the lung. There is alveolar as well as interstitial edema. There is loss of surfactant activity, and therefore alveolar collapse and consolidation starts. Loss of oxygenation, ARDS, and what we see inside the CT scan as GGOs and consolidation, and the CT scan can be marked for severity. So this is a cartoon image showing you what exactly happens inside the alveolar. This is a war between the pulmonary immune system, innate immune system, and of course the virus. And once it reaches a stage, we don't know what that stage is. It triggers, virus defeats us completely. And so innate immunity fails because there is a dysregulated innate immune response with neutrophilia and monocytosis, and a massive release of cytokines with IL-6 dominating, and IL-1 beta, TNF, and LDH increase because of cell damage. And therefore, there is the cytokine release syndrome. The cytokine release syndrome caused by COVID-19 is different from that which is caused by ARDS and CRS caused by sepsis or tumor therapy. These are neutrophil driven, they are acute, and they cause very high levels of IL-6. The COVID-19 CRS is macrophage driven, it's subacute to chronic, lower IL-6 levels, and death is not because of circulatory failure, but is because of respiratory failure. And that is why this disease is caused to cause happy hypoxia. Adaptive immunity, the single important signature feature is a massive lymphopenia in severe disease. There is a loss of lymphocytes of every type, T cells, both helper and suppressor or cytotoxic, as well as B cells and memory cells. Along with that, there is a decrease of eosinophils, basophils, and natural killer cells also. To compensate for this, there is a huge increase of neutrophils, and this neutrophilia results in a reversal of NLR, that is neutrophil lymphocyte ratio. There is also a huge increase of naive T cells, both of these which result in huge pro-inflammation and again cause the help in the cause of cytokine storm. So why does lymphopenia occur? It occurs because of T cell exhaustion, because of cytokine storm induced exhaustion, and also because possibly now there are papers emerging that T cells are directly infected by SARS-CoV-2 and they have a deleterious effect on T cells directly also. B cells help by producing anti-RBD, neutralizing and protective antibodies, but this immunotherapy has been seen to be double-edged. Memory cells are emerging as important, particularly there have been experiments and papers which quote as memory T cells playing a huge role. B cells, not enough is known about them, and possibly they are going to play an important role. Neutralizing antibodies, we said, are anti-RBD neutralizing antibodies, which primarily are directed against the spike protein, but N protein and M protein also have a role. These neutralizing antibodies kill the virus, but they also go on to stimulate B and T cell and memory cells because of the presence of the Fc gamma receptors. The first to come is IgA and the last to remain is IgG. The longest it has been seen is for about 10 to 12 months. It's not been seen, actually only 10 months. And the immunity, is it always protective? Because it has been seen that in asymptomatic to mild patients, there is no antibody seen. And in severe disease, it has been seen that huge titers of antibodies are there. The mistake is actually in us because we are not measuring the protective, that is anti-RBD neutralizing antibodies. We are measuring total antibody. And total antibody will not really tell you much about the disease. We have to measure for this particular aspect of the antibody marker, and only then can you truly say that antibodies are there and are protective. So this was actually a misnomer in these experiments. There are many factors we all know which affect immunity, and they affect immunity in SARS-CoV-2 also. This diagram shows that the ORFs, which produce NSPs, actually stimulate T cell epitopes, whereas the structural genes stimulate the B cell epitopes producing antibodies, and the most important of which is the neutralizing antibody, which is produced against the S1 RBD subunit. CMI is extremely important and is probably the game changer in SARS-CoV-2. CMI starts in the first week and progresses on to the third week. CD8 cells are extremely important in killing the virus-ridden, laden cells. And CD4 cells produce a Th1 response, which increases gamma interferon, which will also kill the viruses. They produce IL-2 and TNF alpha, which are also protective. And the Th1 response stimulates T follicular helper cells, which go on to stimulate B cells to produce neutralizing antibodies. So severe disease is seen when there is lymphopenia, probably because of T cell exhaustion and direct T cell invasion. There is also a subset of T cells, the Th17 cells, which increase during this time and probably lead to pro-inflammation via their marker IL-17A. Other limbs of innate immunity are complement and platelets. All the three pathways of complement are stimulated. Massively is the alternate and the MBL pathway. The alternate pathway is directly, and the MBL pathway are directly stimulated by the virus using its N protein. The nets which form also go on to stimulate the alternate and MBL pathway. The stimulation of the complement results in direct endothelial damage of the lung. It also co-stimulates the coagulation pathway, leading to a hypercoagulable state. The nets also produce thrombin, which leads to a hypercoagulable state. This is contributed also by stimulation of platelets, because by virtue of the fact that they have ACE2 receptors and the virus attaches to them, and there is platelet aggregation because of upregulation of adhesion molecules. This entire situation leads to thrombotic events, eventually going on to thrombocytopenia and a depletion of coagulation factors also. There is a dysregulation and downregulation of immune response genes which are related to interferon production, also related to the PRR signaling, and also other accessory markers of immunity like cathepsin, the chaperones, and lysosomes. HLA has been associated with both protection as well as severe disease. HLA-B 4601 is associated with humans having this pattern of genetics are associated to have severe disease, whereas those having HLA-B 1503 are seen to have extremely good T cell activation, and they therefore have mild disease. This is the huge interplay inside the lungs of the cells, and this is called the game of cells. I'm trying to correlate it with Game of Thrones. You can see the number of cells which are involved, and these are the cell signatures. I will not go into all this because the time restrictions are there. So immune signature, does it really exist? Yes. In severe disease, an immune signature exists. There is a rise of IL-6, there is lymphopenia, neutrophilia, and there is T cell exhaustion. A final balanced immune response if there are high neutralizing anti-RBD antibodies with Th1 based response. This would probably lead to protection and memory, T cell memory. Or you have a fabulous innate immunity right in the upper airways, and you deal with the virus without even having a simple mild cold. There are a whole lot of unanswered questions still, my friends. Is there a single trigger event for dysregulated immunity and CRS? If there is, then we could control this disease. Does COVID-19 directly affect all these immune cells? T cells, it has been shown, yes, it does directly. So does it have direct immunosuppression? What is the story of variants, their virulence patterns, immunity, and vaccine efficacy? Is there an immunity passport? Can we say that, yeah, I did the ELISA, I have antibodies and I'm immune? No, we can't really say that. Not even with anti-RBD antibodies, because there are many limbs to immunity. And as we're seeing that there are many receptors also by which the virus can enter our body. So a whole lot of studies still need to be addressing a lot of these things. And I'm sure there are many more questions. So I would end by saying everything we do before a pandemic will seem alarmist. Like when we said social distancing and masks, so a whole lot of populations, and vaccines, there are still a lot of populations which are anti this. And everything we do after a pandemic will seem inadequate, as was seen with the second wave all over the globe, which had affected so many millions of people and so many million deaths. Thank you so much.
Thank you, ma'am, for this very wonderful and lucid presentation regarding the immunology of SARS-CoV. As we were all struggling in the second wave, as has been rightly pointed out by you, and just hope and pray that we do not have the third wave with us. Ma'am, I just have a query regarding the immune mechanism. I'm sure there may be so many more in the future part of this panel discussion in the last, but I just have a query regarding the immune mechanism, all of the cells coming into play, and you do get this thrombocytopenia as well as lymphopenia. And as we see patients coming to the OPDs after recovery, and they seem to get those low platelets for quite some time. So, ma'am, can you just make it clear what is usual time frame for all these to come back to normal? When do we expect, and when do we start getting jitters if it is not getting back to normal? Especially the platelets, because we are seeing much percentage of children and small kids getting low platelets for quite some time.
Yeah, thank you so much. That is an extremely wise question, ma'am. On an average, what they say is between 6 weeks and 12 weeks, you should see a recovery and a wash away, So your antibodies should wash off, and immunity, as we said, on an average should last only up to 90 days, maybe up to 10 months. But what we are seeing is post-COVID. And what is happening is, like, some people are going in for an immune complex disease. Some people are going in for a kind of a, it's like manifestation of delayed hypersensitivity. So we don't know. It's a huge spectrum of disease which is unfolding itself, right from, we are mentioning only platelets and the immune cells. It's going to the brain. I had recently taken a talk in June. In fact, that's why I had that screenshot of June in an international eye conference. It's amazing the post-COVID effects in the eye, apart from thrombotic. So, direct affecting the retina because of some sort of cross-reacting antibodies which are forming. This is actually unfolding. We can say that the patients should improve completely by between 6 weeks and 3 months. The critical period is considered to be 4 to 6 weeks. But this is not a rule, because, there are people coming with post-COVID almost 7-8 months. And I think in a recent WhatsApp circulation, there was a lady, I think she's a doctor, whose whole family was affected by COVID. She has had 3 or 4 recurrences, and post-COVID also, post-COVID syndromes also. So it is extremely difficult to predict this.
Thank you so much, ma'am. I have so many more, but the organizers are running short of time.
Sure. It's an exciting topic. Yeah, thank you.
Definitely. Taken in such a beautiful way, this so difficult topic.
So.
I congratulate you, ma'am.
Thank you so much.
Thank you so much.
Thanks.
So that comes up, take us to the second of the lecture in today's symposium. And for that, we have with us Dr. Rajesh Bhatia. Sir is a technical advisor in Asian Development Bank, Food and Agriculture Organization of the UN, in EcoHealth Alliance, New York. And presently he's Director of Communicable Diseases, WHO Regional Office for Southeast Asia. And his major achievements include being a fellow of Indian Society for Communicable Diseases. He has so many gold medals to his credit, like Indian Association of Vaccinology, Indian Society for Malaria and other communicable diseases, Indian Association of Medical Microbiology. And he has so many publications, so many books and chapters to his credit. And we just seem to be awed by the achievements sir has, and I hope this is going to be an equally exciting session. And I request her to kindly take up this talk of his. Over to you, sir.
Good afternoon and namaskar. Thank you very much to the organizers and the unseen audience for giving me this opportunity to share some recent information and thoughts on vaccines' role in containing antimicrobial resistance. I wish to make a submission upfront. During next 15 to 20 minutes, I am not going to share anything new. Common sense says that vaccines reduce infectious diseases, leading to reduced burden of disease and lesser use of antibiotics with minimum resistance to antibiotics. Today, I shall try to make it evidence-based and will make an attempt to promote greater use of this amazing public. Since our focus in today's presentation is on antibiotics and vaccines, let us begin by paying gratitude to pioneers in this field. Fleming, Florey, and Chen, who discovered penicillin and set the ball rolling for development of new antibiotics, and Edward Jenner, Louis Pasteur, Jonas Salk, and Albert Sabin for making available vaccines that have resulted in eradication of diseases such as smallpox and polio. While both vaccines and antibiotics aim to act against infectious diseases, their mechanisms of action and some other characteristics differ. Antibiotics are therapeutic tools and vaccines prevent onset of infection. Antibiotics are short-acting tools and vaccines accord long-term memory. The combination of these tools have been phenomenally successful. These two tools, along with sanitation and safe water and improved living conditions, brought down significantly the incidence of infectious diseases during last century in the USA and many other developed countries. The success was so heady that the then Surgeon General of the USA, Dr. Bill Stewart, made a famous statement that the time has come to close the book on infectious disease. But as we know, it was not to be. Infectious diseases are still major issues. Two reasons for this. One, survival instinct of bacteria, and second, indiscriminate use of antibiotics, which we know is the greatest driver for promoting resistance in bacteria. Though a large number of antibiotics have been discovered during past 8 decades, the resistance emerged to almost all of these rapidly. 50 years back, when I was a medical student, we were told that diagnose typhoid fever, treat it with chloramphenicol. Diagnose gonorrhea and treat it with 1 shot of penicillin and your patient will be fine. It is no longer true at all, and all because of antimicrobial resistance. The antimicrobial resistance has been defined as the unresponsiveness to antibiotics when administered in standard doses, and it has serious implications for a patient and treating physician as well as at a much higher national and global. The adverse impact of AMR on health include the longer duration of the illness and treatment, which results into higher mortality and morbidity and is associated with economic loss to the patient as well as to the community. Infections with microorganisms which are resistant requires additional investigations and treatment with expensive drugs which may be more toxic. All these produce extra burden on the health system and also increase the possibility of transmission of resistant organisms to the community. The modern technologies and complex surgeries, including transplantations, frequently fail because of invasion by resistant pathogens post-surgery. It has huge impact on economy and human development, which one can easily understand. But the implications of AMR are mind-boggling at the global level. I'm sure most of you would be aware of the findings of O'Neill report that projects a jump in annual mortality due to resistant pathogens from current estimated number of 700,000 to 10 million. It's not difficult to imagine that this would be accompanied with substantial loss to economy, higher cost of treatment, and even a threat to the food security. There are several solutions to contain AMR. Perhaps the most important is reducing the disease burden. Vaccines can play a significant role in minimizing it. Along with safe water and sanitation practices, vaccines can do wonder in our collective fight against infectious diseases, even in the developing. Vaccines have remarkable potential in preventing several viral infections, thus preventing misuse of antibiotics. Elimination or reduction in bacterial diseases shall not only reduce the use of antibiotics, but will also prevent the spread of drug resistance. There are several evidence-based success stories on vaccines. Two of the most important achievements of humanity ever, not only in health sector but in all sectors, is the eradication of smallpox and elimination of poliomyelitis, and these are well known to everyone. So I will focus next few slides on other diseases where vaccines have demonstrated great impact on reduction in disease burden, leading to substantial diminution in use of antibiotics. Measles vaccine, which has been a part of Global Universal Immunization Program, also known as Mission Indradhanush in India, has prevented more than 21 million of deaths across the world in less than 2 decades from 2000 to 2017. We must acknowledge India's contribution in this global success story. More than 65% of children in 170 countries are protected against measles using vaccines produced in India. Measles virus per se does not kill a child. It is a superinfection leading to ARI and diarrheal diseases that cause morbidity and mortality. Both these conditions require massive use of antibiotics in children. Obviously, vaccine can have a huge impact on use of antibiotics in children subsequent to infection with measles. Influenza vaccines come in a new avatar every year based upon WHO recommendations. These vaccines help prevent 85,000 hospitalization every year in USA alone. The use of this vaccine amongst Indians is still not very popular, despite the fact that flu is a major disease among senior citizens, which usually invites long-term administration of antibiotics and hospitalization. Another viral vaccine that is making its impact on reducing acute diarrheal diseases in children is rotavirus vaccine. In Bolivia, as an example, among children of less than 5 years of age and during a span of 4 years, this vaccine could reduce 30% age-specific hospitalization, 40% rotavirus-specific hospitalization, and 50% reduction in age-related deaths. Coming to the few of bacterial vaccines, it is estimated that the universal immunization with any of pneumococcal vaccines has the potential to reduce 47% antibiotics consumption in children less than 1 year of age. This estimate is supported by the fact that in California state in USA, this vaccine prevented 35 antibiotic prescriptions per 100 vaccinated children, which were equivalent to 1.4 million antibiotic prescriptions per year in the state of California in USA alone. Not only children, but vaccine against pneumococci also has a significant impact on adulthood disease, as has been demonstrated in this slide, in which a rapid and steep fall in incidence of disease was observed following introduction of PCV in the US during the period 2005 to 2013. The pneumococcal vaccine has also demonstrated substantial reduction in use of antibiotics in different countries in both children and in senior citizens, with significant and quantitative reduction in the use of antibiotics. Similar reduction in disease burden has been seen in Africa using the meningitis vaccine, again produced in India. The decline in incidence on the year-to-year basis is very obvious in this slide. The dotted line is of data for 2009 and the solid line at the bottom is 2013, thus showing huge lessening of disease burden and inter alia use of antibiotics. This, friends, is the magic of vaccine in limiting disease burden and thus neutralizing AMR selection and spread even in the most underdeveloped of the country. At the beginning of this millennium, invasive H. influenzae disease was a major issue in Italy. With the introduction of H. influenzae vaccine from 2000 onwards and maintaining it constantly at 90% plus level, as shown in the green line, as shown by the green line in this graph, cases among infant as well as children less than 4 have reduced dramatically, saving precious lives, morbidity, and reducing the use of antibiotics. Typhoid fever is a curse with which all developing countries, including India, have been grappling for decades. More than 50 million cases are diagnosed globally and treated with antibiotics every year. Thanks to resistance, it has now become a difficult to treat entity. We don't have many antibiotics left to treat typhoid fever effectively. It is a matter of grave concern that today the mortality rate in children following typhoid fever is almost same as it used to be in pre-antibiotic. Vaccines are the solution to this disease also, and vaccines that are currently available, including the oral, injectable and conjugated versions, though with moderate efficacy, must be used extensively not only to prevent typhoid fever but also to obviate its carrier state. We can keep on discussing various other vaccines, but time is a bit constrained. However, I cannot conclude without taking a little bit of your time about the ongoing pandemic and the irresponsible use of antibiotics in millions of cases of COVID-19 with obvious ramifications of selection and spread of resistance. A recent study has shown that while 8% of patients admitted to a hospital developed bacterial and or fungal infection, 72% of the patients in the same hospital who were admitted received empirical broad spectrum antibiotics. Well, this has been happening all over the world, and among all the cases, most of the cases of COVID-19 who are admitted to the hospitals, the real impact of this indiscriminate use of antibiotics shall become known only in near future, but it is certainly bound to augment AMR significantly. Pandemic may die off soon, but resultant AMR shall persist for a longer period. And here also, we are seeing it now that vaccines can play an important role in reducing the number of cases of COVID-19, thus causing reduced usage of antibiotics, as shown by recent data from the USA. And this is the data for up to July this year of USA, where you can see the green line is among the people who have been vaccinated. So the number of daily deaths has been going down dramatically because of the vaccination of a large number of people in that country. Let me conclude by enumerating 5 challenges for augmenting use of vaccines as important tools in containing AMR. These are availability of safe and efficacious vaccines, their access to majority of targeted population, especially the poor people, their cost effectiveness so that the developing countries can also buy or produce and use these, their awareness amongst the beneficiary to augment the demand side, and development of new vaccines for several important pathogens, more importantly the hospital acquired infection agents. And friends, this can be achieved only through concerted actions by all of us. Wish you good luck and thank you very much, friends.
Thank you very much, sir, for this wonderful lecture. And I'm sure the questions will be there and they will be taken up in the last. And coming up next, we are having another interesting topic on impact of drug and device regulations and implementation on antimicrobial resistance. For that, we have with us Dr. S. Ishwar Reddy. Sir is a joint drug controller of India, and the major contribution include holding the position of Joint Drug Controller of India for about 1.5 years. Sir is hailing from Andhra Pradesh. He did his degree in pharmacy from College of Pharmaceutical Sciences, Manipal in 2009, started his career in 1998 as drug inspector of CDSCO West Bengal and promoted as Assistant Drug Controller for India in 2009. He has participated in many national and international seminars and workshops on drug regulations. He was awarded with Best Drug Inspector, Best Drug Controller Award, as well as Distinguished Alumni Award. He has recently been honored with Education Trust Award given in appreciation of valuable contribution in the field of pharmaceutical sciences. Over to you, sir, for your wonderful lecture, which I hope will be coming up.
Thank you, Uzma. I hope I am audible to you.
Yeah, sir.
Yeah, thank you very much. Can I
Thank you,
share
sir.
my presentation? Is my presentation visible?
Yes, sir. Please.
Yeah, very much, sir. Please
Yeah.
carry on.
Yeah, thank you very much. So first of all, let me thank organizers for giving me this opportunity to part of this program. The topic given to me is impact of drug and device regulations and implementation on antimicrobial resistance. So before going on to the main thing, just I would like to briefly give some idea about overview of Indian drug regulatory system. The drugs, devices, and cosmetics are at present regulated under the act called Drugs and Cosmetic Act. This act is 1940 Act. As all of you know, the drugs falls under the concurrent list of the Constitution. There are three different types of items under the Constitution: central list, state list, and concurrent list. Concurrent list means both state and central government have the powers to enforce or implement these items in the concurrent list. So as I said, this act is a central act enforced by both central and the state government. The main objective of this act is to ensure safety, efficacy, quality of drugs, medical devices, and cosmetics. Actually, what we regulate under this act is we regulate manufacture, we regulate import, we regulate sale, distribution of drugs, cosmetics, and devices. Under the Drugs and Cosmetic Act, we have 4 different types of rules. Rules regulating the drugs, that is called the drug rules. And we have specific rules for medical devices, that is Medical Device Rules 2017. And we have recently come up with the new rules on clinical trials and new drugs rules, that is 2019. And recently we have come up with the specific rules for cosmetics that's called as a cosmetic 2020. If you see the basic principle on which our act operates is through the system of licensing. That means to manufacture you require a license, to sell you require a license, to distribute you require a license, to stock you require a license. That means if anybody other than consumer end user is using the product, all people, those who are engaged in the handling of drugs require a license. The basic philosophy under which the Act is operates, actually manufacturers are responsible for quality of drugs, devices or cosmetics manufactured by them. As a government drug regulatory agencies, we are responsible mainly for monitoring of the quality of the drugs. So how will you monitor? We'll monitor by periodic inspection of the manufacturing and sale premises conforming to the provisions of Drugs and Cosmetic Act. We also monitor the quality by through system of surveillance, that is quality. We'll draw the sample from the market and analyze it, tested at our government laboratories to ensure the quality. As I said, this act is enforced by both central government and state government, but however, we have a specific defined role and responsibilities of central and the state government. Under the act, the major responsibilities of the central government are all new drugs. It means if any drug first time to be introduced, either it is antibiotic or cancer drug or any drug first time or to be introduced in the market, it requires a central government approval before it is placed in the market. Similarly, if any drug or device to be imported into India, so the all import regulation is done by the central government through CDSCO, and also to conduct any clinical trial of any new drug, the permissions are granted by the central government. And also the central government is responsible for to lay down the standards for the drugs, and any amendments to the act and rules also the central government responsibility. Finally, the pharmacovigilance, where it will ensure the safety of the product in a real world situation, and also to identify signal detection, collecting the adverse events, analyzing and reporting. This activity is the central government. However, states have a specific responsibility. All licensing activities, either license to manufacture, license to sale, or license to distribution given by the state drug controllers, they will also monitor the quality of the drugs and cosmetics through inspection, surveillance. And if any violations are there, they will also do investigations and prosecution. The next slide, I talks about what measures we have taken, Health Ministry and CDSCO, to bring the transparency and predictability in the central government regulatory system. So we have implemented the e-governance through the SUGAM. Almost 80% of our all applications are received through online for various approvals. These are reviewed through online, and approvals also granted through online with digital signature. We are expecting in another couple of months, the rest of 20% also going to be complete online. Thereby, we are going to have a paperless office. And we also come up, as I said earlier, new rules for medical devices, clinical trials, and new drugs. And the first time we have introduced our system specified timelines for processing of applications. For each category of application, the timelines have been prescribed. And earlier we have all license have a validity. So like 3 years and 5 years. After that, again, they have to make application for renewal. So now we have introduced system of perpetual validity of license. Means once the license is issued, that is continued to be valid. There is no timeline for that. However, the company has to submit the fee for every 5 years as per the rules. And we also established the public relation officer at our office to interact with all the stakeholders to support investigators, to support the innovator, to support the startup companies, to assist the regulatory requirements to market their products. We also enhanced our CDSCO manpower. We also doing capacity building activity of states and central drug regulatory system by providing manpower, by set up the new laboratories to enhance the capacities. And we also issued the various guidelines and FAQs to make ease of doing business in India. As I said, we come up with the new drugs and clinical trial rules. These are very important. We have a provision for waiver of local clinical trials for drugs approved by identified countries. If the drug is already approved in some identified countries, then that automatically that local clinical trial waiver will be granted. We also made a con to encourage the innovation in India, especially the domestic innovation. If the applicant is not received any reply within 30 days, then that applicant can consider deemed approval system we have included in our regulations. So to ensure the accountability of the officers, the timeline for the processing of application is 30 days. If the CDSCO is not able to communicate any response within 30 days, then that application is deemed considered as approved. We also have provision for the pre and post submission meetings wherein the applicant can approach before submitting of application or even after submission of application with the drug regulators to know details about the regulation about his drug. We also have a separate provision for approval of orphan drugs. It means there is a provision for waiver of clinical trials, waiver of fee, and also we have defined what is orphan drug as special provisions have been included. And we also have a provision for academic clinical trials. Earlier, to conduct academic clinical trial of approved drugs, the permission was required from the regulatory authorities. Now there is that has been exempted. There is no regulatory permission to conduct a academic clinical trial of already approved drugs. And provisions for post-trial access as per the recommendation of the investigator and ethics committee is also been included. If that particular patient requires that particular investigational drug after even completion of clinical trials, based upon the recommendation of investigator and ethics committee, that investigator drug can be made available to the subjects. We also have provision for manufacture of unapproved or new drugs for the treatment of patients in government hospitals and government medical institutions in case of any emergency. We also have a provision for the accelerated review and approval provision. On this condition only, nowadays you must have seen CDSCO has approved various COVID vaccines and drugs meant for COVID treatment on accelerated review process. We also has come up with the new medical device rules to regulate the medical devices of clinical investigation, import, manufacture, and sale. We have classified the medical devices based upon the risk. Class A is a very low risk device. Class D is a very high risk device. Class A and B devices are regulated by the state government, whereas Class C, D regulated by the central government. We have concept of notified bodies. They will audit class A and B devices to support the state governments. We have a special provision for clinical investigation. This is similar like clinical trial in case of drugs. In case of medical devices, if any new device to be introduced, the importer or manufacturer has to conduct a clinical investigation. We also have provision for the let down the standards for medical devices. And here also there is no concept of renewal of license. There is a perpetual validity. In case of medical devices, we monitor the adverse events through materiovigilance. Like in case of drugs, we monitor through pharmacovigilance. However, in case of medical devices, through materiovigilance, we monitor all the serious adverse events and reactions, if any. And we also come up with the recently medical device roadmap to regulate all devices under the Drugs and Cosmetic Act and rules. Coming to the regulations, what we have at present for drug and devices and how we are implementing the effectively EMR. As all of you know, EMR is one of the greatest health risks to emerge in the 21st century. And it is predicted that these antimicrobial resistant infections will lead to nearly 10 million deaths if not steps taken properly per year by 2050. And around approximately 2 million deaths are projected to occur in India due to MR by the year 2050. If you see MR issues Indian scenario, mainly it is because of the uncontrolled use of antibiotics in humans and animals. And another major reason is inadequate technical infrastructure to generate the usable EMR data. The another reason, mainly inadequate quality assurance at the AST labs and inadequate interaction among the clinician, laboratory experts, and the regulators. If you see one of the major reason for AMR, as I said in the earlier slide, it is mainly because of antibiotic usage in animals. So these antibiotics mainly used for three purposes in the poultry and the animal feed industry. Actually, they are used either as a therapeutic agent for the treatment of disease. They also used as a prophylactic agent for the treatment of disease via feed or drinking water when signs and symptoms of infection are absent but suspected. This is another major reason. When unfortunately, some of the antibiotics have been recommended as a growth promoters in poultry industry. So mainly it is to increase growth rate and productivity characterized by administration of very low dose of antibiotics on a regular basis, mostly over lifetime of the food producing animal and given through the feed. So these are the main reasons why AMR, through the uh, animal food. And this slide talks about what are the regulatory actions we have taken by the CDSU or Ministry of Health to curb the AMR. And if you see in the year 2012, we made it mandatory on the label of medicines. They have to specify clearly the treatment of food producing animals shall be labeled with the withdrawal period of the drug. So before that animal is going for any culling or as a food it is used, the manufacturer has to specify a withdrawal period before it is used as a food. In 2013, the government of India has taken a major decision to come up with a new schedule. It is a schedule H1 under the drug rules, where all antibiotics and other drugs like which are this type of AMR issues and habit forming drugs brought under the schedule H1, mainly to making the provisions that the drug formulation shall be labeled with the symbol of prescription in red color, and the schedule H1 clearly says warning, it is dangerous to take this preparation except in accordance with the medical advice. And also it need to be sold by retail without the prescription of, not to be sold by retail without the prescription of a registered medical practitioner. In addition to this, the manufacturer, the manufacturer also has to keep the documents for the purchase, sale, and distribution of any schedule H1 drugs separately. And as all of you know, colistin is one of the mainly used antibiotic in the poultry industry, and for this animal feeds as animal feed supplement. The government of India in the year 2019, so we have prohibited colistin and its formulations for the manufacture, sale, distribution for food producing animals, poultry, aqua farming, and animal feed supplements. We also given the directions to the state drug controllers from time to time and other stakeholders, mainly for the strict compliance of the requirements, raising the awareness in the public regarding the adverse effects of misuse of antibiotics. And we also is to ensure that no drug in Schedule H1 are sold by retail without the prescription of registered medical practitioner. The CDSU is also prohibited many irrational antibiotics. In fact, earlier, these antibiotics are more than 2-3 antibiotics together were manufactured and sold in the form of a fixed dose combination. As per our new drug definition, all FDCs are new drugs. So before it is approved by the state authorities, they had to get the necessary permission from the CDSCO. However, unfortunately, some of the states granted the fixed dose combinations without approval from the CDSCO. So thereby the government has prohibited many antibiotics which are irrational. And we also restricted the availability of certain tuberculosis drugs. For example, if you see bedaquiline, we have approved to sell this bedaquiline only for the National Tuberculosis Program. So these are not easily or readily available at the pharmacies, for any unused, mainly for the irrational use by the any patients. And there is also very important to assure the diagnostic devices, because of whenever they will go for the resistance to the particular antibiotic, until unless the sensitivity and specificity of the particular diagnostic kit is effective, then only it will give correct results. Otherwise, this may give either false positive or false negative results. Thereby, there is a chances of wrong antibiotic prescription. So finally, I will make my conclusion. CDSU and Ministry of Health, we have been continuously taking the various regulatory steps to curb the misuse of antibiotics, and especially we are promoting the rational use of antibiotics to adhere to the mission of use of medicines appropriately to safeguard the right, rights, safety, and well-being of the patients. We also promoting the innovation of medical products, including drugs, vaccines, and diagnostics. In earlier speaker is mentioned about the role of vaccines, how it can prevent the AMR. So we have taken a special regulations. Yeah, I have stated in the earlier my slide about the new drugs and clinical trial rules, where we brought mainly these rules we brought to promote innovation, especially in India, to address this AMR and other related issues, to develop the vaccine, to develop the diagnostics, and how regulator or regulations can promote innovation in India, and how regulator can give support to the innovators to make his innovated product to commercially make available commercially in the market. And we also establish the expert committee. So before approval of any new antibiotic, so its rationality, its safety, and its efficacy will be examined by the expert committee before it is approved by the national drug regulator like CDSCO. And to ensure this proper rational use and supply of drugs without prescription, there is a proper coordination is required among all stakeholders. I think like clinicians or practitioners, they should make sure that they don't prescribe any irrational combination of antibiotics or unwanted antibiotics. And there should be a role of nurse, role of the regulator, retailers, wholesalers. Everybody has to play important role, and there should be a proper coordination. And in order to effectively implement various provisions of the drugs and cosmetic rules, one of the concern we will come across from time to time is availability of antibiotics without prescription. Just you go to any pharmacy and ask for any antibiotic. Unfortunately, in some of the pharmacies, in some of the places, patients are able to get such type of antibiotics without prescription. That's really making a disturbance to the system. Mainly maybe because of inadequate manpower at the state drug regulatory organization. So we have strongly recommended state government to strengthen the state regulatory organizations by having adequate manpower and infrastructure. We also time to time made awareness and requested the All India Chemist and Druggist Association to educate their members to follow the conditions of license for sale of drugs strictly. As I said, because they plays very, very important role. The Chemist and Druggist Association, it is their responsibility to ensure the antibiotics have been issued, dispensed as per the valid prescription. So thank you very much for your kind attention. Over to you, the organizers. Over to you, Uzma.
Thank you very much, sir, for this wonderful talk. And as we are running short of time, we'll be taking the questions in the end.
So sorry, I have another meeting at 3:00, so I may not able to be available.
Okay.
So we will see you some other day. Otherwise,
thank you so much, sir, for your valuable time and a very beautiful presentation. Thank you so much.
Thank you very much. Bye.
Now I request Dr. Shalini to maybe introduce the next speaker.
Good afternoon to you all. Thanks to the organizers for providing me an opportunity to be a chairperson for this conference. Healthcare workers are a high-risk population, and in the healthcare institutions, you see a heterogeneous group of people, those who are COVID positive and those who are COVID negative. So along with COVID appropriate behavior, it is apt that vaccination is made mandatory. With that background, I introduce Dr. Anita Sharma, Madam is Associate Director and Head, Lab Services and Infection Control in Fortis Hospital, Mohali. She has had a diploma in hospital infection control. She is APSIC Hand Hygiene Award recipient. She is the editor in the editorial board of JPSIC. She is also the treasurer of HISI, faculty in various national and international conferences. She has various scientific publications and chapters. Over to you, madam, to speak on mandatory vaccinations in healthcare institutions.
Good afternoon, everybody, and thank you, Team HISI, for this very important session on vaccinations. In the next few minutes, I'll be, talking to you something about the vaccines in healthcare workers, whether they're mandatory or not. That is still a point of discussion, and we'll discuss as we go further. Now, I'll be basing my talk under these headings. Briefly, we'll set a context to the vaccine history, the requirement in healthcare workers, and the definition of healthcare workers. And then we'll briefly touch upon the vaccine program in a hospital and a word about mandatory vaccines in healthcare workers again. So if you look at the vaccines, the impact of vaccinations on the health of the world's people is hard to exaggerate. With the exception of safe water, no other modality, not even antibiotics, had had such a major effect on mortality reduction and population growth over the past 100 years. I would say that's the science's biggest gift to mankind, which has led to so much of improvement in our healthcare across the world. And when we trace back the history of vaccines, most of them have been actually discovered in the 20th century. And whatever vaccines that we see in our various programs, they are the gift of the 20th century. And they've really, really made our world a much more healthier place to live in. The vaccine success stories are there for all of us to see. Look at smallpox, look at poliomyelitis, how we have successfully eradicated or are the verge of eradication from this world. Other diseases like mumps, measles, rubella, tetanus have shown a real declining trend. And the COVID vaccine story, although it's still evolving, there is a lot of hope around it. And that's what is actually sustaining all of us through this particular pandemic. Now the question comes, why vaccines in healthcare workers? Why indeed? Well, we know that hospitals are not safe places and there is risk to patients and healthcare workers alike in a hospital, right? So we all are at risk when we're coming to the hospital as a part of our occupational, work profile. And the healthcare workers, just like any other adults, they have these major infectious risks to deal with. There could be these airborne or droplet infections, for example, varicella, pertussis, influenza, SARS-CoV-2, mumps, measles, or they could be, the bloodborne pathogens of HIV, Hep C, and Hep B. Rarely, they can also have these contact-related infections like MRSA, adenovirus conjunctivitis in a hospital. And of course, food and waterborne infections, hepatitis A and typhoid could always be there in a certain segment of population, and which could pose a risk to the others, for example, what we know as a typhoid, the food handlers. The healthcare workers in an organization can acquire these infections, either ways. They can get it from their colleagues or the patients, and similarly, they can pass to either of them. And many a times you have seen these mini outbreaks happening in hospitals because of this reason. And as the small little chart shows that the healthcare workers definitely are at risk, once a patient is admitted in an area, especially if, for example, they've had measles, up to 75 minutes that, particular surroundings could pose a risk to the healthcare workers. And for SARS-CoV-2, we have always talked about this exposure of more than 10 minutes could be again risky to the healthcare workers. But the good news is that for many of these infections, at least most of these infections that we listed in the slide, the vaccines are available. And therefore, there's a great chance that we can reduce this risk to our healthcare workers, especially those arising from the small clusters of patients in a hospital. So vaccination of healthcare, when we talk about, it has multiple advantages, right? For example, it can prevent the transmission of vaccine preventable diseases to the employee themselves. What does it do to us? It eliminates the unnecessary work restrictions. It reduces the loss of man days. It prevents mobility. So it is in the interest of the organization also, and also, of course, the healthcare worker themselves with respect to their reduction in mobility. It also safeguards the health of the patients because we are here to take care of patients, and if we have infections, we can also pass on to them. And therefore, if you are vaccinated, if you are having a reduced risk, it will also protect our patients from exposure to these infected healthcare workers. So overall, there is definitely a reduction in the risk of infection. It reduces both the number of susceptible healthcare workers or providers and risks for transmission of these vaccine preventable diseases to other workers and patients. And that's the reason these vaccinations occupy a very important position in the occupational health program of any hospital or organization. But it's important to find who's a healthcare worker. Is it just the nurses or the doctors or the ones who are directly coming in contact with patients? Well, anybody who's working in a hospital, whether it's a paid or unpaid person who's working in the healthcare settings, who has a potential for exposure to blood and body substances, whether directly or indirectly, they fall into the category of healthcare workers. I mean, as an organization, you're not to discriminate that this is a contractual, this is a student, they're coming to us for 2 hours, they're volunteers, or they are in direct patient contact. All of them may have some risk because of their nature of work in the hospital, and therefore they all are to be considered the healthcare workers. But for the purpose of further simplifying or understanding who's at a greater risk, they have also been risk categorized, and one of such is also given by the CDC, and where we categorize the patients into our staff, not the patients, the staff, into 3 categories of category A, B, and C, with the laboratory forming a special category on its own. And the basis for this categorization is their exposure to blood body substances. So in category A, the staff has a direct contact with blood and body substance, and therefore they could have a risk of blood droplet and airborne diseases. And most of our direct caregivers, like our nurses, doctors, like our the general duty attendants, the housekeeping staff, and even the biomedical and engineering staff will probably come under this category. The category B is of staff who has indirect contact with blood and body substances. That means that they're not directly into patient care, but by virtue of being them in the same environment, they stand a risk of these droplet or airborne diseases. And this would majorly include a catering staff with the ward clerks posted who are surrounded by the patients, although not in the direct patient care. The category C is of staff who has got minimal contact with patients, and their risk is as per the general population, and this would primarily be your admin staff or the gardening staff and such. Laboratory, by virtue of it handling all the infectious samples, is a very high risk area. There are staff who's handling these samples directly. They're centrifuging those samples. They could come in contact with bloodborne and the airborne pathogens, and therefore the lab staff and microbiology staff would remain a high risk category in any hospital. Having said that, with this background, let's look at what is the vaccine program in a hospital all about. Now, the WHO in this position paper, it's a slightly busy slide, but it does give recommendations for vaccines of healthcare workers, and it does list 8 or 9 vaccines which could be considered by any country for their national immunization program, basis the risk that could be there. And then there are certain diseases for which they do not give any current recommendation for healthcare workers. In fact, when we look at this review, it does talk about the vaccination or seroprevalence rates in the developed world of Europe, Australia, US, Canada, and as you could see that barring influenza, there is a very good either seroprevalence rate or vaccination rate, and all these vaccines have been recommended for the healthcare workers in these particular countries. Apart from these 6 or 7 vaccines, there are certain other vaccines which are to be recommended in very special circumstances. For example, rabies vaccine, and that would be mandatory for people who are working in rabies research labs, and similarly meningococcal vaccine in laboratories which are handling a lot of CSF samples, so they could also be given these vaccines. Typhoid and hepatitis A can be given to food handlers, and many of the vaccines can be actually based upon the risk of exposure either before or after, and therefore they can be certain recommendations can be made basis that. But as far as the Indian healthcare practices are concerned, these 7 vaccines are the one which find a place and which have been recommended to be given to the healthcare workers. And they include hepatitis B, the COVID vaccine, the SARS-CoV-2 vaccine, influenza, varicella, tetanus, hepatitis A, and typhoid vaccines. And what are the driver for these vaccines? Now, although there's no national mandate as such, but there are recommendations or regulations from the accreditation agencies like NABL, NABH, and JCI, which make it mandatory for these organizations through the accreditation process to have these vaccines in place. Similarly, Pollution Control Board statute recommends a mandatory vaccination of tetanus and hepatitis B for its waste handlers. The food safety requirement is for typhoid and hepatitis A for its food handlers. And above all, they could simply be a part of a good governance framework of a hospital. So therefore, what hospitals, what vaccines are to be given in a hospital, you can choose any of your driver, but it's important that we take care of the employees who are working in the hospital and we from these occupationally related diseases. So in the next few slides, I'll just quickly share, why these vaccines are important in our hospitals. Why should they be made a part of the occupational health program? Now, hepatitis B, we all know, is vaccine preventable. That's a great thing about it. It was introduced in Universal Immunization Program in 2008. By that corollary, the present healthcare workforce is unimmunized. There's high prevalence of Hep B, Hep C in our patient population. And we all know that the cost of one positive injury from Hep B could be upwards 20,000 rupees. And the cost of rehabilitation of occupational injury is even higher. So, and in fact, in the data from the US hospitals, it did demonstrate that the Hep B vaccination led to a reduction in the infection rates amongst healthcare workers from 18% to 6% in 10 years. So they are definitely effective. So therefore, all healthcare workers, especially of the category A and B who have direct or indirect contact with blood and body substances, need to be vaccinated in a healthcare. Also, a post-vaccine screening for adequate seroconversion is recommended because we all know that about 5% of our population will not seroconvert and they will need to be given an extended schedule of vaccines. So therefore, it's important, it's vaccine preventable, and we have to give this chance to our healthcare workers to protect themselves from this particular infection that can be quite devastating in a few of these patients. The SARS-CoV-2 COVID, this is a hot burning topic. We are still in the middle of this novel pandemic. We all have seen a huge global health and economic impact of this particular virus. We are still learning about it. The evolution of mutants and transmission is given as it multiplies. The chances of mutants evolving is high. And the routes of transmission, that is airborne and droplet, it makes control that much more difficult. We've all seen nosocomial outbreaks being reported within the hospitals and the community. And therefore, hospital needs to ensure safeguards to continue its services. On one hand, we need to cater to these COVID patients. On the other hand, we need staff, we need healthy staff so that we can take care of these patients. So, and it's often said that vaccination is an important tool to get out of this pandemic, and therefore all healthcare workers need to be vaccinated. So this is a given, and we have heard about this ad nauseum on different platforms. And even when we look at the data, I mean, there's published and otherwise also, like, these are the two big hospital networks that published their data, and Apollo said that only 4% of the healthcare workers got breakthrough infections even after full vaccination. So that means vaccination has been effective, and Fortis data shows that only 0.5% of these fully vaccinated healthcare workers had severe COVID. And that was the aim of the vaccination, that it has to prevent a serious disease. Of course, if it prevents transmission, that will be the cherry on the cake. But for now, we are looking at a reduction in the severity because, mediated through these vaccines. In spite of all this information available, in spite of the accessibility, in spite of so much of, campaign being done across these vaccines, our vaccination rates are really slow, and that is multifactorial, of course. But COVID-19 vaccine hesitancy amongst healthcare workers is real, and this is something we really saw when this campaign was launched for the first time for the healthcare workers, and we did see this people just not coming forward, even the healthcare workers, in spite of knowing so much, especially the younger categories of the healthcare workers that did not come forward for this vaccine in the first go. And this is something we need to really address. And that would be true for any adult vaccine, because while we are very comfortable with the pediatric immunization program, the adult vaccination is another ballgame. Enough hasn't spoken about it, and this would be seen probably for the newer vaccines that would keep coming as we go into the future. Influenza in healthcare facilities is something well established. We have got very good programs in the developed world, around influenza. And why we need to have that? Because we know that infected staff may initiate outbreak or aid in propagation. Infections lead to absenteeism and disruption of healthcare, and that is a major reason why organizations want to take this vaccination up in their respective institutes. Outbreaks can occur in acute care facilities or wherever their patients and staff are there. And importantly, some of the times these infections can get passed on to the sicker patients that we have in the hospital, and can lead to morbidity and mortality amongst them. And we also know that there's a high rates of immunization among staff, which may lead to a decrease immunization. Attack rates in residents. So a better immunization rate can safeguard our patients also with respect to getting these infections. So what is the status in India? We know that flu vaccine majorly got introduced after the H1N1 outbreak. Before that, we really were not too much worried about it. We probably didn't even talk about the flu vaccine as the West was doing. So when we started, it was slow to pick up amongst healthcare workers. What we saw in COVID, we also saw in the flu vaccines, because there was a lot of concerns around it. However, it's a very effective strategy to reduce the loss of mandates in the hospital, although it's not mandatory. But it's important that the hospital, both the admin staff and the healthcare worker, is sensitized to the need of it. It protects you. And now we've seen that many hospitals are actually offering the same to its healthcare workers, which is a very, very good practice. On the other hand, varicella and chickenpox is something we all need to be concerned about, because one, it's not a part of universal immunization program in India, although it's been recommended by the Indian Academy of Pediatrics. Also, we see that in tropical countries like India, there is a late stage seroconversion happening. So, which means that even in the age group of about 20 to 30% of our adult population, close to 25% of young adults may still be varicella seronegative, and hence they would be vulnerable. In hospitals, we know that our workforce is usually in this age group. Our nurses are young, and also they tend to stay in PGs and staying in hostels in close proximity. So therefore, we have a good number of vulnerable population to the to this particular entity, and and they also have the propensity to initiate an outbreak. And in fact, we have seen this risk of transmission happening both to the patient and to the healthcare workers. And every year, probably most of us see a mini outbreak of chickenpox happening in their own respective hospitals. So it is definitely something to think about, although not much effort has been spent on chickenpox in many hospitals. And we definitely need to reduce the risk from this particular entity. And universal vaccination or screening through varicella antibodies may not be cost effective, looking at the high prevalence of this particular infection and also the high cost of intervention. So we can't expect the organizations to do either universal screening followed by vaccination. Moreover, it's a live vaccine and therefore cannot be universally offered to the staff, because we have young female population in the hospital where we need to be a little mindful about this implications of this vaccine. So therefore, an important strategy could be that one could do a risk stratification of our healthcare workers to identify the vulnerable population, good screening for chickenpox history at the time of joining, followed by a good follow-up, where we can identify the cohort of staff who gave a negative history, and we can probably run an antibody screening onto them, and those who are negative, vaccination can be offered. It's a little tedious one, and we have seen practical in experiences that the history is not very forthcoming. People sometimes are not very clear about it, and even if they are, they don't want to kind of comment very categorically on it. But on the other hand, one can definitely look for is that the staff which is posted in high-risk areas like transplant patients and all, one can do a mandatory screening of staff, and only those staff are posted there who are vaccinated and protected in the interest of these very vulnerable population of our patients. Tetanus, again, is used to be a very serious disease, and with the advent of vaccination, we have seen its impact really go down. But it's still in India, the 40% is still global tetanus cases are still being reported from India. And in fact, it's the only nationally recommended vaccine for adults, which has also found its way into the PPCP guidelines, which mandates it for the healthcare worker handling the waste. In fact, many organizations have also extrapolated to all healthcare workers in the hospitals, which is a very good thing, because we are giving this opportunity to our population to be safe from this particular very dreaded disease. It's inexpensive with good benefits for all. However, there's another thought coming, with respect to this particular vaccine, that is it time for healthcare workers to get the tetanus, diphtheria, pertussis, or Tdap as we know it, vaccine instead of just tetanus. Lately, we have seen diphtheria and pertussis cases getting. There's a resurgence of these infections, and it's the global bodies are now recommending that the adults should in fact be given a Tdap instead of just a tetanus vaccine going forward. Hepatitis A and typhoid, not much to talk about it. These diseases are endemic in India, and these two vaccines have been mandated by food safety norms in both health and hospitality industries, and there's also an accreditation requirement, although there are certain controversies around it. But yes, these vaccines can prevent morbidity and can also prevent an outbreak, especially in areas or establishments like hospitals or factories. Having, now with this little word about all the vaccines, where I've just briefly touched upon them, there are certain special considerations, special issues with respect to vaccine, which we should be mindful of. The first is the pre and post-vaccine serological testing. Should we do it or should we not do it? Regarding the pre-immunization testing, that is, testing for antibodies before you give the vaccine, it is not cost-effective. It should not be done regularly, and there's no need to obtain a serological screening for immunity. And unless there are certain situations where the vaccine is contraindicated, for example, before giving these live vaccines, MMR, varicella, and certain population, you may want to check for their antibodies level before you offer it to them. And on the same lines, for post-immunization testing of these vaccinations, it's only indicated as of now for hepatitis B, where we should know the titers for all our healthcare workers, and also the rabies who are working in a high-risk exposure situation like a rabies research lab, because again, we would want to be very sure that our staff is protected from this very dreaded and dangerous disease. On the other hand, a lot of vaccine testing is being done in the country. People really want to know what their antibodies are with respect to COVID, both pre and post vaccination. As of now, we really do not know how to interpret these antibodies, and therefore we are saying, all the bodies are saying that the antibody screening is not recommended, not indicated for COVID vaccine. What happens to the healthcare workers with respect to the work restrictions? Can they work after taking vaccine? Very well, they can, except for a couple of situations. For example, very rare situations where somebody has been given a live attenuated nasal influenza vaccine, and they should restrict from working in a stem cell transplant unit, for about 7 days. And in a very rare eventuality of somebody developing a varicella vaccine rash, again a leave of absence till the rash disappears. Otherwise, there's no work restrictions recommended. The immunized employees can work with neonates, pregnant women, and immunocompromised patients also. And which brings me to this very important aspect that, these are the three groups that I just mentioned: the newborn babies, the transplant patients, and neutropenic patients are the most vulnerable group in our hospitals. And therefore, please ensure that all those immunized healthcare workers which are posted in these areas, they are immunized with all these vaccine preventable diseases, or they have immunity, they have demonstrable immunity to these particular infections, in order to reduce the risk of infections to these vulnerable patients. Now it's one thing to talk about vaccine, but it's another thing to have a good program, good vaccination program in place with respect to its implementation and follow-ups. And as is true with any good program in any good organization, it starts from the top. So leadership commitment for a good solid program is of utmost importance. We need to have a leadership which has a demonstrable commitment regarding the safety of its healthcare employees, whether it's through good governance policies or is it through the various accreditation requirements. Having said that, all these things have to be backed up. We need to have policies and SOPs as per the laws and the statutes and the good practices. We need to have resources, which means vaccines which are free of cost for the employees. But the most challenging thing is the on-ground implementation of the vaccine. We need a very robust system around it. We need a lot of people, committed people, and process flows directing this. We need to have a vaccine nurse. We need to have vax campaigns, and we need to have a process where we collect this data and we can do a retrieval and do a risk assessment on top of that. So therefore, all these things have to be a part of your vaccine program. And a good idea would be to make this program, which should be driven through the HR team again. It's a collaborative. Of course, we need to have many people on board, infection control, the nursing, the management, but the HR team should be the major stakeholder driving this particular vaccine program in any organization. Having said that, as I shared earlier, there's a lot of barriers and vaccine hesitancies associated with adult vaccines, and this very evidently came out during the COVID pandemic. And the major barriers could have been related to the knowledge, attitude, behavior, or the influence of the families, or the access or availability of the vaccines. But otherwise also, as logic would say, it's the for a healthcare worker, it's the easy access and convenience with respect to timings, which is of utmost importance. And therefore, we need to make sure that the vaccines are available and they are conveniently available to our employees. The concerns for adverse events is another area which probably does not make them come forward for the vaccines. There could also be certain religious and personal beliefs, and the social media platform, what we call as a WhatsApp University, is the biggest source of information to majority of our people, and we all know that much of this information is unsubstantiated, and therefore it makes an opinion about these kind of aspects with respect to safety. So these are some of the common barriers to vaccine compliance, and if there are barriers, there are also solutions. And what are these for the effective healthcare worker immunization? As I said, it starts with strong and visible leadership, and one can actually start with the visible vaccination of key leaders. For example, for COVID, it was majorly led through by all the senior doctors coming forward and taking the vaccines, and that probably enthused a degree of confidence in the junior staff as well. Importantly, you have to make vaccine free of charge. If you put some charge to it, there would be people who will not come forward to take it. We have to have a good targeted education program to dispel the vaccine myths. Importantly, vaccination has to be made available at the site of work. Many times we take our trolleys to the clinical units to vaccinate, because we know that for them to come down to the vaccination center may not always be easy, and people generally tend to shrug it off, maybe not today, maybe tomorrow. They tend to procrastinate. So important is that you take it to their site of work and make it easy for them. And having done all these, it's important to do an accurate tracking of individual and unit-based compliance for any gap analysis and solutions to address those gaps. On the other hand, as a healthcare organization, you can still put some mechanisms to ensure better compliance. For example, for employees to join an organization, it could be a requirement for employment. As we see in many other organizations, when we go abroad, they make it mandatory that if you do not have these vaccines, you cannot enter the country. Medical staff, again, it could be, to encourage their participation, it could be made a part of their credentialing process, that it's a mandatory requirement for you to get credentialed in an organization. For students and volunteers, it could be a mandatory requirement for attending to their classes of volunteering work. And for contract workers, you can easily put it in their contract. So these are some of the ways by which organizations can promote better compliance amongst its own healthcare workers. And lastly, which was actually the topic for discussion, what are the mandatory vaccinations for healthcare workers, and should it be made mandatory? Whose rights should come first? Is it the patient or is it the healthcare workers? And there are no easy answers for it. In fact, there's a lot of being discussed in with respect to the legalities of this mandate. The advocates of patient safety says that the patient safety is prime. It has to be prioritized over the healthcare workers' freedom for vaccination choices, because we know that the risk rising out of vaccines are minimal, which can actually be minimized by good screening of the healthcare workers for these potential adverse events. So there's no ways that we should listen to healthcare workers. It's required. Just go ahead and make it mandatory, because it serves everybody's interest. On the other hand, in the context of individual freedom, it is said that healthcare workers are also entitled to freedom of choice, because if there are advantages, we also know that all vaccines can pose a certain amount of risk, and there's no guarantee that a new vaccine will always be effective. So there is, like, a tough balancing act here required. The jury is still out, and therefore we don't see most of these vaccines being made mandatory. In fact, they're just good, strong recommendations, and there are enough drivers to make sure that they are available in the organizations and are they accessed by the healthcare employees. But the only way to increase the compliance in anywhere would probably be a good advocacy, a good access to information and vaccine, and accountability on the part of the employees as well as the organizations. So to summarize, this is how do we advocate, how do we educate. So this is the kind of poster that we have made in our own hospital, and we kind of have flashed it, put it everywhere, where we put down the recommendations for the healthcare workers regarding the vaccines which are available with us, and along the dosing schedules. It also gives you small information bit as to what should you do in case you miss the dose, and if your titers are less than 10. So it is a very user friendly kind of information that we broadcast, and we share it with our employees. And to this list now we need to add the COVID vaccine too, which is a recent entry to this list. So ladies and gentlemen, thank you very much for this time and attention, and I'll be happy to take questions as and when they come.
Thank you, Dr. Anita, for reasoning out why vaccination is needed. And since we are short of time, let us go to the last session of today by Dr. Sanjeev Sharma. COVID-19 is an enigma. Nevertheless, healthcare system and the stakeholders have a major role to play in dispelling the fear, the myths, and the doubts regarding vaccinations, the controversies surrounding it. Dr. Sanjeev Sharma, he is a clinical pharmacologist from Indraprastha Apollo Hospital. He is the lead medication management for and Joint Commission International Inspection. He has won applause for the good work by international inspectors. He has an internal assessor for Apollo Hospitals for medication management. He conducts ethics committee inspections for clinical trials. He has been a panelist and speaker for various conferences. He has conducted 4 clinical trials as a co-investigator. He is a member of American College of Clinical Pharmacology and member of Medication Safety Officer. He has plenty of publications to his credit, and he has authored about 5 chapters on clinical research, pharmacogenomics, and clinical evaluations in national and international medical publications. Over to you, sir, Dr. Sanjeev Sharma.
Thank you very much, organizers, to give me this opportunity. Thank you all my previous speakers who have completed vaccination, most of the aspect, and it won't complete unless we talk about vaccinovigilance counter, which is like pharmacovigilance for vaccines. We say vaccinovigilance. What vaccines are, as all of you know, vaccines are not new. What we have learned over the years from vaccine as far as safety issues are concerned. In 1926, we had diphtheria toxin, which was incompletely inactivated. In 1929, we had BCG vaccine, which was contaminated with a strain and killed 72 infants. In 1942, we were using human albumin as a stabilizer for yellow fever vaccine, which was contaminated with hepatitis B. In 1955, polio vaccine was incompletely inactivated. In 1997, we saw hepatitis B, and it was linked with demyelinating diseases. In 1999, rotavirus was associated with interceptions. In 2010, Pandemrix, which is an influenza vaccine, was found to be associated with narcolepsy. So what this vaccinovigilance aid, it is basically science and activities related to detection, assessment, understanding, preventing, and communicating the adverse effect following immunizations, whether it may be related or may not be related. In short term, if we say vaccinovigilance is nothing but vaccine safety. Why we need to talk about vaccinovigilance is we need to protect the vaccinated individual as well as population from harm from the vaccines. We need to ensure batch related safety of vaccine. We need to ensure effectiveness of the vaccines because these viruses keep on mutating. We need to ensure positive benefit risk ratio and identify the signals from ongoing adverse event following immunizations. We need to always balance the risk benefit ratios, and we need to differentiate from false positive signals from the true positive signals, and we need to respond to safety crises which keep on emerging in vaccine cases. Why we need to see vaccine as a different from drugs? Usually we see vaccines are used for prophylactic purposes, and drugs, which are basically small molecules, they are used for therapeutic purposes. Even for adult, when they take it for a disease. If you have a headache, you take paracetamol, it get relieved. But that is not the case for vaccinations. And vaccinations are usually either recommended or mandatory or imposed through administration, as was the last previous topic of this discussions. Vaccines are basically complex molecule and may have batch to batch variability. They may have potential contamination, and attenuation process may be problematic. And till now, vaccines were commonly used for children's, and now is the time for talk about vaccine for the adult population as well as. Benefit risk ratio, the perceived benefit for the drugs is much higher because it may immediately relieve the sign and symptom of the disease. But in case of vaccines, that is not there. The population, herd immunity and all that benefit is there, but that is not perceived immediately. There's low risk of acceptance by the parents for their children's, and there is definitely lack of vaccine confidence, which is a real trouble which may happen. If a drug fails, that particular individual may get affected. But if vaccine fails, your population, your herd immunity get affected by doing that. So in case of drug, perceived benefit is much higher. But in case of vaccine, perceived benefit is much less. In case of adverse event, acceptance of adverse event because of drugs is much higher, but for vaccine, 2 or 3 deaths may derail your vaccination programs. So what we need to do is we need to have good signals. Signals are nothing but new causal association, new aspect of causal association with the vaccine, which comes from spontaneous reporting. It may come from active surveillance. It may come from patient registries, from literature reviews and observation, or experimental or data mining. So once we get these signals, we need to validate these signals based on risk benefit ratio. We need to prioritize, and then we need to assess these signals based on epidemiological or biological plausibility of these studies. We need to look into post-authorization safety studies and post-authorization efficacy studies. And we need to do mechanistic studies, which are behavioral studies to find out like mechanism of action of one particular adverse event. And we need to characterize this causal relationship. Either they are confirmed related to vaccine, or they are rejected not related to vaccine. And in many times we get that further investigations are required for this. Once this signals comes in, we need to have standardized definition of that particular problems what we are facing, and in this case Crichton collaborations is important tools. Like I told you, rotavirus induced interception, so you need to have good definition of interceptions or narcolepsis. HPV vaccine was was associated with chronic pain syndrome and postural orthostatic tachycardia syndromes, and which is still under investigations. So when there is an adverse event following immunization, it may be just a coincidence. It is a natural event, may not be related to vaccine, but it may be observed after vaccine, or it may be adverse reaction caused by the vaccine or vaccine itself, which may be further because of errors in preparing the vaccines or handling the vaccine or administering the vaccine, or there may be a reaction to the injection itself, or it may be reaction to the vaccine, which may be inherent property of the vaccines. So now looking into the reaction to the vaccine, it may be because of antigen, which are, as we know, different vaccines are prepared either by attenuation, inactivation, fragmentation, conjugations, or recombinant DNA technology. Or there may be adjuvant like aluminum salt, MF59 and so on, and or it may be a preservative or stabilizer causing that particular reaction to the vaccines. And there are certain important terms we need to understand. Vaccine product related reaction, when it is vaccine is exactly given as qualified as by the manufacturers, and there is no it is basically because of inherent property of that particular vaccine, or it may be a defect related reactions, which may be a manufacturing defect, quality issue in that particular batch. It may be a immunization errors because of improper handling, improper prescribing, improper administration of that. And all these immunization error related reactions in vaccination programs are preventable. And it may be a immunization anxiety related reactions. Basically it is fear of injections, anticipating pain, or it may be a coincidental event which is not related to reactions vaccines. So what we see, how we check the observed rate of that particular signals, and we look into background rate of that particular event in the populations. So we need to have good data of the population of that, like interception in general population, how much it is common, and what is attributable rate to the vaccines. Now it is 6 in this particular vaccines, 4 is in general population. So attributable rate is observed rate minus background rate. So 6 minus 4. So 2 is the attributable rate because of that. There may be a vaccine failure because of administration errors, wrong dose, route frequency. It may be a vaccination schedule not adhered to, or wrong storage, or expired vaccine used. All these are preventable, and good SOPs and good training may prevent this. Program related, it may be because of suboptimal recommendation or vaccine storage issues. It may be vaccine failure. And of course, host related issues, immunodeficiency or immunosuppressive therapy. It may be age related decrease in immune response, or interference with other antibodies of other vaccines or infections, and there may be non-responders. It may be vaccine related. We know all vaccines are not 100% efficacious. It may be incomplete coverage of strains, variant, mutant, like we are talking in COVID vaccine now. The newer variant may not be covered by the present vaccines. Vaccine interaction, when there are two vaccines are given together. Manufacturing related batch variation, quality defect, all this may lead to vaccine failure. And this vaccine failure may be because of failure to vaccinate, or if there is a potential failure, either this is confirmed by the appropriate test or diagnosis, or there is a suspicion, and or there is other efficacy related cases. All need to be reported to vaccino vigilance program. There are certain diseases which most of the time are always thought about because of vaccines like autoimmune disease, like diabetes mellitus type 1, because children we use a lot of vaccines, grave diseases, multiple sclerosis, neuroinflammatory diseases, neurodevelopmental disorders, rheumatoid arthritis, SLA. More or less, these diseases are always attributed to the vaccines. So there are certain one term called adverse event of special interest. It is a predefined or predefined medically significant event which is potentially to be caused by the vaccine product. We need to confirm it and conduct specific studies. What type of this special interest are anaphylaxis, encephalopathies, neurological disorder, Guillain-Barré syndrome, Bell's palsy, thrombocytopenic purpura, aseptic meningitis, vasculitis, or vaccine-enhanced disease in case of COVID-19 vaccine and dengue vaccine. You will find even with COVID vaccine, all these are thought to be of special interest vaccine following immunizations. Immunization, if you see the vaccine, initially disease will be more prevalent, vaccine coverage will be minus, and people will have more concern about the vaccines. When vaccine coverage start increasing, you will have a lot of media attention, and now social media attention also is there. Concern about vaccine started increasing about their safety. Lack of evidence-based safety data, if we do not have, we lose the confidence, and then we need to do the crisis management. After that, the confidence comes back. So in this particular, that completes my talk on this vaccinovigilance. Thank you for that.
Thank you, Dr. Sharma, for the steps that you have told us on the safety and efficacy of a vaccine, which will help us to clear the doubts, the misconceptions, and the controversies which surround the vaccine. Thank you once again. Over to the organizers for the next.
Any questions arising?
Thank you so much, chairs and the speakers. We have two questions here. One question is for Dr. Rajesh Bhatia. Sir is not with us. So if any of the panelists would like to take the question, is it possible to treat carbapenem resistance by using vaccines? Or is it there any current program in India going to combat this resistance via vaccines? Shall I repeat the question?
No, I think, Sana, we've got the question. As far as my knowledge is concerned, I don't think there's any vaccine as yet effective. I think Raman may be a better, and Dr. Anita may be better to answer that, but I'm not aware of any vaccine as yet, at least.
Yeah, even I'm not aware of it.
Yeah.
There is no vaccine as such. I take the permission of chair that today's keynote address by Dr. Pallav Ray was an eye-opener. So we probably need to wait a couple of years for the new developments to take place on clinical grounds, especially the delivery systems, the bacteriophages and license and such like antimicrobial agents which are on the anvil, and they would soon be available because we don't have anything else to fight the infections in any case. So I think more than the vaccines, world will be looking towards these agents in the coming future. So those of you who had tuned in to Dr. Pallav Ray's keynote address, you would have gathered what exactly I'm talking about. And the rest of the people can listen to the recorded version once the conference is over.
Thank you, sir. So there's another question. Can vaccine be able to prevent resistance which caused by intrinsic factor due to mutation in genes or in bacteria?
I think if I can take that question in a very generic manner, what we are seeing in COVID that is being talked about, that vaccines, they prevent the transmission there, and all these bugs that we talk of, the more they multiply, the more mutations they gather. So by that principle, one, of course, they can, prevent these mutations by simple fact that they will reduce their multiplication transmission. But specific answer to your question, I'm afraid I don't have an answer for it.
For this answer for this particular question is directly we don't have a vaccine for this. Indirectly we have many vaccines. Basically, one of the strategy to prevent antimicrobial resistance is to avoid the use of antibiotic themselves. How we can avoid when we vaccinate people for vaccine preventable disease? If persons are already vaccinated for typhoid, we won't misuse antibiotic. They won't have typhoid, and hence you won't misuse antibiotic for typhoid. Similar is the case for influenza. So these are indirect markers for indirectly helping us. Like for animals, when we don't give antibiotic, we are preventing. Same way for vaccine, we can, but we don't have a direct vaccine for that.
Well said, Dr. Sanjeev. Well said.
Okay, thank you, sir. So there's one question for Dr. Anita Sharma, ma'am. What all vaccines will be recommended to staff posted at transplant unit in hospital?
Yeah, thank you for the question. And I think, yes, I did refer to it in my talk as well, that it's absolutely imperative that the staff which is posted in transplant area is safe for our very vulnerable patients. So the mentioned vaccines definitely take a point, like, for example, hepatitis B, flu vaccine, and now COVID vaccine, and estimation of a determination of their chickenpox status, whether they have had chickenpox in the past. So one can do a serological screening, and if not, then must offer the varicella vaccine to them. Same goes for their MMR status also. One should definitely look for it. And as the new recommendations are that instead of tetanus, if they can be given Tdap. So these are the certain vaccine preventable diseases that we can avoid. And we must always have the status available for the staff who's posted there, taking efforts not to post vulnerable staff with these kind of patients, because should they develop any of these diseases, there's a high risk of them transferring it to their patients, which could be catastrophic.
I had a question.
I take the permission of the chair to actually, what wonderful lectures. I heard Anita's lecture on vaccination on healthcare staff. I think the chair would agree that one of the best lectures around on vaccination that I have heard in recent past.
Indeed, indeed. Very nice.
Thank you, Dr. Raman, for your very kind words. You've always been so encouraging.
I just had one question, actually, Dr. Anita. This thing of diphtheria and pertussis, so like a Tdap, how much is the risk in adults over here, of a recurrence of, say, a diphtheria or a pertussis? And what is the occurrence of a side effect in such an age group?
So to be very honest, if you ask our personal experiences, it's not that we have seen them in our regular practice that often, but they're definitely finding our recommendations, looking at the epidemiology, which is globally there, and as well as in our country also, especially about diphtheria. They are definitely talking about increase in cases, and they said it's vaccine preventable, so one must undertake going forward. But it hasn't really found a place as yet. We still need a lot of conversation around it. And what was the second part of the question? Sorry.
Are there any side effects, like adult immunization will?
No, I don't. No.
Create a hassle?
No, I really don't think so. There are any side effects. But Dr. Raman, would you like to add to it? Because in terms of data, at least I am not privy to any such data where we have documented the research. I mean, at least in our practice, we haven't seen patients coming to us with
Thank you so much. Thank you.
The best person would be Dr. Sanjeev Sharma to answer. We're still on because he deals with vaccinovigilance, and in fact, he deals with pharmacovigilance, one of the pioneers in Indian setup, when this was incorporated a decade and a half back. So Sanjeev is still around. You can answer that question.
Yeah, if you see, ma'am, in Western countries, they routinely Tdap is one of the vaccine which is for adolescent and adult. They are recommended. In India, adult vaccination has not picked up. Definitely, it is safe. People who are traveling to those Western countries for studies and all, this is one of the vaccine many universities still ask. because in adult there are outbreaks which happens in between. We don't have that much good surveillance mechanism to capture each and every case. That may be the reason we are not able to. Otherwise, there is no reason we won't have similar cases.
Thank you, sir.
And side effect, as far as side effect are there, we have not seen any different in adult rather than pediatric.
Okay, lovely.
Also, the thought process is as the our pediatric immunization program is being strengthened. There's a shift in epidemiology. The younger adults are also getting to see these infections a little later also. So that will be that's correct.
That was indeed a very interesting and much needed session. Thank you so much, respected chairs and all the speakers for sharing your knowledge of excellence. Thanks so much.
Thank you so much.
Thank you. Thank you very much.
Thank you.
Can we start the next session, please?
Good afternoon. Myself, Dr. Midhat. I welcome you all to this session on infection control and prevention in special units. Infection control and prevention is a practical evidence-based approach which prevents patients and health workers from being harmed by avoidable infections. For this session, we have the chairpersons, Dr. Vivek Nangia and Dr. Sonal Saxena. Dr. Vivek Nangia, he is an internationally renowned interventional pulmonologist, and at present, sir is the principal director and head of the Institute of Respiratory and Critical Care Medicine, Max Hospital, New Delhi. And Dr. Sonal Saxena, ma'am, at present, ma'am is the director, professor, and head of the Department of Microbiology, Maulana Azad Medical College, New Delhi. Ma'am has worked on various projects with WHO, Ministry of Health on antimicrobial stewardship, antimicrobial resistance, and medical education. Handing over to you, chairs.
Well, good afternoon, everybody. It's indeed a pleasure to be chairing this very important session. We always tend to use antibiotics on the pretext that our measures or the surroundings are not hygienic enough, and there's always a probability of infection. What we forget is that if we follow proper infection control practices, probably our antibiotic usage would go down significantly. So that is why we've collected this session today, where we'll be talking about the infection control measures in the various settings, the OPD, the dialysis unit, so on and so forth. And to present to us about hemodialysis unit, for the first speaker is Dr. Gaurav Sagar, who's a senior consultant nephrologist at Indraprastha Apollo Hospital. He's been instrumental in organizing a workshop on vascular access. Since then, he's been organizing several other conferences on interventional nephrology, has had many abstracts on vascular access, and carried the first ABO incompatible transplant in northern India. May I hand it over to Dr. Gaurav Sagar to begin his presentation now.
Good afternoon, ladies and gentlemen. I'm Dr. Gaurav Sagar, Senior Consultant Nephrologist at Indraprastha Apollo Hospital, Delhi. At the onset, I would like to thank Dr. Raman Sadana and the organizing team of Hisicon 2021 for this wonderful opportunity. I'll be speaking on infection control in hemodialysis patients. Dialysis patients are at a higher risk of infections, which include sepsis, UTIs, pneumonias, rather all infections compared to non-CKD population. So why are dialysis patients more prone to infections? It's because of the vascular access, which is used for dialysis. There are multiple repeated opportunities for person-to-person transmission of infectious agents by contaminated devices, equipment and supplies, environmental surfaces, and hands of personnel. Dialysis patients, because of multiple pathologies, are immunosuppressed, and that is what makes them more vulnerable to infections. Even the mortality is higher in dialysis patients compared to normal patients, and the exposure to bloodborne pathogens is a serious risk factor for the patients as well as the staff members who are providing care to these patients. So we need to understand the various causes and the preventive measures for it. reducing the transmission of infections. So coming to the epidemiology of infections, they can be viral infections or bacterial infections. Bacterial infections are 57% because of the vascular access, 23% because of skin and soft tissue, 15% lung, and importantly 5% because of the liver tract also. So can we achieve an infection-free hemodialysis? Can we always control infection in these patients? The answer is yes, probably by following simple precautions. Contact transmission is the most important route by which pathogens are transmitted in hemodialysis unit. It occurs most commonly when microorganisms from a patient are transferred to the hands of a healthcare worker who does not comply with infection control and then touches the patient and the environmental surfaces. These patients and the healthcare workers sometimes can become reservoir for pathogens and they keep on transmitting infection to others. Contact transmission can be prevented by hand hygiene, that is hand washing or use of a waterless hand rub, glove use and disinfection of environmental surfaces. Standard precautions are used in all patients and include use of gloves, gown or mask whenever needed to prevent contact of the healthcare worker with blood, secretions, excretions of contaminated items. So what are the indications of routine hand washing in dialysis units before and after dealing with dialysis machines? Before and after performing non-invasive techniques, after removal of gloves, if hands are visibly dirty, after leaving the patient's particular dialysis station and before dealing with any of the patient's station. What are the indications for aseptic hand washing? Before inserting catheters and before and after connecting the patient to the dialysis machines through the AV fistula. Alcohol-based hand rub can substitute hand washing. So coming to the gloves, non-sterile disposable gloves have to be used for performing non-invasive procedures and cleaning or disinfecting instruments or environment with the dialysis machine. Sterile gloves have to be used for performing invasive procedures or connecting the patient to the dialysis machines, especially for the AV. General measure, items taken to a patient's dialysis station, including those placed on top of the dialysis machine, should either be disposed of, dedicated for use only on a single patient, and cleaned and disinfected before being returned to a common clean area. Vials should not be shared between patients. The additional measures to prevent infection is not handling or storing contaminated, that is used supplies nearby a clean area where unused medications or supplies are handled. Delivering medications separately to each patient. Common carts should not be used to prepare or distribute medication. If trays are used to distribute medications, clean them before using for a different patient. Environmental issues, after each patient treatment, clean and perform low-level disinfection of the environment surfaces, including the dialysis, bed or chair, countertops, and external surfaces. All linens should be changed between patients. Medical equipment, example, scissors, hemostats, clamps, stethoscopes, blood pressure cuffs, cleaned and should be disinfected. Blood spills should be cleaned up immediately. The housekeeping staff has to be very vigilant in the dialysis units and should promptly remove soiled and potentially infectious waste. External surface of the machine should be cleaned and disinfected between patients using disinfectant. For single pass machines, it has to be done at the beginning or end of the day. For dialysis machines, after every session of dialysis, they have to be cleaned. Draining the dialysis fluid and rinsing and disinfecting the machine has to be done after each use. Do not attach the venous tubing directly to the base container during hemodialysis priming. Venous pressure transfusions, of course, have to be changed between the dialysis sessions and should not be used. An important process is dialyzer reprocessing, in which dialyzers are used for 3 to 4 sessions. This is used worldwide. Reprocessing is done worldwide to reduce the cost of dialysis. Outbreaks of bacterial infections and pyogenic reactions can happen because of inadequate reprocessing procedures and failure to maintain standards for water quality. Reuse has been associated with transmission of bloodborne viruses. Risk for HPV transmission from reuse of dialysis primarily affects the staff members. Water treatment is also an important component of dialysis. In every dialysis session, there is about 150 liters of water which enters the human body. So strict adherence to quality assurance standards has to be done. We have to conduct microbiological testing specific to water dialysis settings, disinfect water distribution systems of regular schedule, and try to use ultra pure dialysate, which has a very, very low microbiological content. Coming to viral infections, important are hepatitis B, HCV, and HIV. Prevalence is reported for hepatitis B, the prevalence is reported to be 1 to 44%. It can be percutaneous or per-inclusive exposure. Hepatitis B is a very stable virus and remains viable for 7 days on environmental surfaces at room temperature. It can be present on environmental surfaces even in the absence of any visible blood. So it is a very contagious virus. Most HPV infection outbreaks are caused by cross-contamination. Environmental surfaces, supplies or equipment, if not routinely disinfected, can cause problems. Multiple dose medication vials and intravenous solutions that were not used exclusively for one patient. Medications for injection that were prepared in areas adjacent to areas where blood samples were handled. And staff members who simultaneously care for both HPV infected and negative patients. So I'll not go into the clinical development of hepatitis B infection, the clinical course, and important is to routinely test for hepatitis B for all patients in our dialysis units who are initiated on dialysis. We check for hepatitis B, HCV, and HIV. Results of HPV testing should be promptly reviewed. Isolation of the seroconverted patients, and important is to offer vaccination to all susceptible patients and staff members. Rather, for all patients who have CKD, we try to immunize them prior to their starting on before their initial dialysis. Test for response to the hepatitis B vaccine is also important. This is basically the schedule of the vaccine. Dialysis patients, you have to give 4 doses and double doses, 40 micrograms instead of the 20. For the staff, you have to give 3 doses, each dose is 20 milligrams, 20 micrograms. And we have to test for the response also. Non-responders have to be checked repeatedly, and if required, a booster has to be given. So, coming to prevention of hepatitis B, there must be a separate room or isolation area for hepatitis B positive patients in our dialysis unit. Also, we have isolated dedicated machines for hepatitis B and HIV. There should be a dedicated machine, other equipment, supplies, instruments, and medications that will not be used by HPV negative patients. Staff members who are caring for HPS antigen positive should not care for HPS antigen negative patients. Machine used on an HPS antigen positive patient if needed for an HPV susceptible patient. That means sometimes there may be an emergency and you may have to use a negative machine for a positive patient. Then of course it can be done, but you have to then disinfect the machine using the conventional protocols. External surfaces should be cleaned using soap and water. Dialyzers for HPS antigen positive patients should not be reused. We should vaccinate all susceptible patients, all negative patients, and test them monthly for HPS antigen. Hepatitis C, the prevalence is reported between 4 to 45%. It is transmitted by direct percutaneous exposure to infectious blood, cross-contamination by chronically infected persons, and inadequate infection control practices. Detection and evaluation of HCV, all patients on maintenance dialysis should be tested when they first start dialysis, when they are transferred from another HT facility. And screening anti-HCV and qualitative HCV RNA can be done. In our unit, what we do is, we do anti-HCV, HPS antigen, and HIV ELISA every 6 months. For all patients, liver functions are done, CBC, LFT, KFT are done monthly. So if there is any rise in the liver enzymes, we check for anti-HCV or qualitative HCV RNA. Strict adherence. So for prevention of hepatitis B, we have to adhere to strict adherence of infection control precautions. Monthly ALT testing, as I told you before, testing for anti-HCV every 6 months. If unexplained ALT elevations are there, repeat anti-HCV testing is warranted. So for anti-HCV seroconversions, we have to identify the source, review of newly infected patients' recent medical history, example the blood transfusion, hospitalization, history of high-risk behavior, and practices and procedures. if more than one patient seroconverts over a 6-month period. More frequent, example, every 1 to 3 months, anti-HCV testing should also be done for HCV negative patients. For HCV positive patients, the CDC does not recommend isolation. The same is being done in our hospital also. They can participate in dialyzer reuse program, and in case there is worsening of liver functions, a hepatologist opinion has to be taken. Coming to HIV, the prevalence of HIV infection in dialysis population varies according to different countries and geographic areas. Over an 18-month period, 512 patients requiring hemodialysis were screened for anti-HIV antibodies. The prevalent rate in patients with chronic renal failure was 0.56%. But in our experience, the patients on dialysis, the patients with HIV who require dialysis is going down. I am not sure, I will have to check the statistics, but I think the use of antiretroviral drugs has significantly reduced the incidence of HIV-associated nephropathy. There are wonderful retroviral drugs which are available, and we see lesser patients on dialysis with HIV now compared to what we used to do about a decade ago. The prevalence of HIV infection in dialysis population varies. There is a lesser risk of transmission, mainly due to breach in universal precautions, and CDC does not recommend isolation. But unfortunately, most of the dialysis units do isolated dialysis for HIV patients because of the stigma attached to it. So coming to vascular access, which are a very important source of bacterial infection in these patients. They can be catheters, they can be grafts or the fistula. Catheters are the major source of dialysis access infections, and they can cause all sorts of complications, including endocarditis, osteomyelitis, sepsis, thrombophlebitis, and death also. So catheter-related infections can have multiple sites from the skin, the dressings, uplines, the drugs, and of course, the hematogenous source. The exit site should be examined at each hemodialysis treatment, and exit site dressing should be done. Use of dry gauze dressing combined with skin disinfection, using either chlorhexidine or povidone iodine solution, followed by iodine ointment or mupirocin ointment at the catheter site, exit site placement at the end of each dialysis session should be done. Manipulating a catheter should be avoided as much as possible. During catheter connect and disconnect procedures, nurses and patients should wear a surgical mask or face shield. Catheter hub caps or blood bag connectors should be soaked for 3 to 5 minutes in providing iodine and then allowed to dry prior to separation. Catheter lumen should be kept sterile. A cap or syringe should be placed on or within the catheter while maintaining clean fluid. Patients should wear a surgical mask for all catheter procedures. Dialysis staff should wear gloves and a surgical mask or face shield for all procedures that remove catheter caps and access the patient's bloodstream. A surgical mask for the patient and mask or face shield for the dialysis staff should be worn for all catheter dressing changes. So skin preparation technique for permanent AV accesses: locate and palpate the needle conversion sites, wash access site using antibacterial soap or scrub, clean the skin by applying 70% alcohol or 10% betadine using the circular rubbing motion. Alcohol should be applied in a rubbing motion for 1 to 1 minute immediately prior to needle conversion. Betadine needs to be applied for 2 to 3 minutes for its full bacteriostatic action to take effect. Clean gloves should be worn by the dialysis staff for conversion. New clean gloves should be worn by the dialysis staff for each patient. Briefly about COVID infection also. So in our hospital, we were doing dialysis 24/7 for the COVID patients. So hats off to all the dialysis technicians and nurses who have been providing care to the COVID patients. In our hospital, we had a dedicated area and dedicated machines where dialysis for the COVID patient was being done. All the universal precautions were being followed, and for staff protection, they were all given personal protective equipment. So putting it all together, hemodialysis patients have unique vulnerability to healthcare associated infections because of a number of human, environmental, and procedural factors related to dialysis. They have a higher risk of infection. Establishing an infection prevention and control program and strict adherence will reduce the risk for both employees and the patients. Environmental cleaning and disinfection is important. Equipment cleaning and disinfection is important. In my opinion, hand hygiene is the utmost thing which has to be drilled into the minds of technicians, nurses, and the doctors. We have to use immunizations and screen for patients and employees. Medication injection safety has to be followed. Patient, family, employee education has to be done. Standard transmission-based precautions have to be followed. Vascular access infection prevention has to be done during insertion and care. Water treatment and testing is important. So I would say we all know what to do, but unfortunately, we just don't follow. Thank you all for your kind attention. Prevention is primary. With this, I end my talk. Thank you.
Thank you, Dr. Gaurav, for a very informative and a very educative talk about dialysis unit. There are certain basic precautions which should be followed, but unfortunately, we tend to forget them. There's a very valid question that we have here, which talks about what is the role of cohorting hepatitis B staff members? Dr. Gaurav, are you there? Okay. So we move on to our next topic, which is about emergency care units and ambulances. How to manage the infection control in these settings. And we have here with us today Dr. Priyadarshini Pal Singh to talk about it. He's the head of the Department of Accident Emergency in the Trust Apollo Hospitals. She's been appointed the CMO for the Formula One India GB in 2013, and then the Deputy CMO in 2012. She's had extended training to many people. She's been instructor faculty, ACLS, faculty to the Critical Care Societies, instructor faculty of Primary Trauma Care Foundation, faculty and academic coordinator for DNB Emergency Medicine. So she's the right person to discuss with us about the infection control measures in the ambulances and emergencies. Dr. Priyadarshini, over to you.
Yes, hi. Thank you, respected chair. And at the outset, I would like to thank Dr. Raman Siddhana, who invited me and thought me capable to do this talk today. And I'm really grateful to him. So I'm going to start my talk. And what I'd like to say is that, amidst the COVID-19 especially, it has taught us that doing infection prevention and control in the emergency is the toughest thing, because we always knew it earlier, but now we've realized that people who come into the emergency, and when there are hordes of them, there is just no way to know who is carrying the disease and who's not. So at that I'm going to start my talk now. So, as I said, it remains a major challenge in emergency care. Is my screen showing, sir?
File is not showing. Click on file.
Is my screen being shared?
Yes, ma'am.
It is.
Screen is being shared, but your PPT is not visible.
PPT is not visible.
So if you double click this PPTM of Hisicon, probably you'll get onto the PPT then.
Okay. It says I'm screen sharing. Is it now?
Ma'am, first, please stop the sharing first and open the PPT, and then you can share your screen.
Okay. Just one second. Sorry for that.
Yes, ma'am. Please start.
Go to the full screen mode, ma'am, please.
Unmute, ma'am. Ma'am, unmute, please.
Yes. Can you hear me?
Yeah.
Okay, so acutely ill patients with undifferentiated illnesses will come for treatment in the emergency, and these patients could be carriers, not only carriers, but they are also susceptible to new infections. The emergency department is a very complex and dynamic environment, and one needs to have a risk recognition and medical decision making, most often based on, though there is very limited but evolving data, and we have resource constraints because of the number of people coming in and the number of people managing them. So there is always that. So the most important, which I'm sure has been covered several times in today's talks, is the standard precautions, which we focus on, which is hand hygiene, cough etiquette, both for the patients and for the staff, safe use and disposal of sharps, appropriate personal protective equipment, which could range from just hand hygiene and a 3-ply mask, and moves on to the complete personal protective environment equipment, which we saw during COVID. How to dispose of and manage the linen and waste management, and environmental cleaning. So, just to disseminate knowledge among staff, there should be visual cues at the patient bedside, posters, verbal reminders from supervisors, supplies to be in designated carts and pre-organized packs so that there is immediate access, because you will have a sudden code and you will have trauma and you will have an MI, or you will have, just a patient who is very sick. So there should be everything which should be ready for the staff to use, especially in resuscitation settings. There should be monitoring through environmental safety rounds, or maybe counseling in terms of somebody is observing, and if somebody is repeatedly defaulting, so that has also proved to be effective. So you come to transmission-based precautions. They can be transmitted, we all know, airborne, droplet, contact, and so it is with the immediate environment. If we don't usually have the knowledge of whether a patient is infected or colonized with a pathogen, so empirical transmission and precautions are crucial to prevent the spread of spread infection in the ED. Contact, again, the most important in the emergency is good triaging, depending on what disease is it. Like this time it was COVID, sometimes it is H1N1, or it is influenza. So depending on what the endemic is, to be able to triage and get on update with the tools and what the signs and symptoms are, and clinical decision-making instruments, contact through physical touch, MRSA, VRE, herpes zoster. They will require standard precaution, limited access of people and equipment which is placed in the patient cubicle. You should be using protective gowns and gloves during patient care, and to prevent healthcare associated infection. With the exception of patients presenting with diarrhea and incontinence, the decision to actually initiate contact precautions can be difficult, but we need to have policies which guide us through this. Then we have droplet transmission, which is of course, bigger droplets which are not suspended in the air, which include influenza, mumps, rubella, meningococcal influenza, COVID, which then started off as droplet and moved on to being airborne. Standard precautions with appropriate level of PPE. At screening, at triaging, masks must be given to each patient. You should avoid aerosol generating procedures till such point that you have put them in separate areas. Donning a surgical mask has become the most important thing at the entry for every patient, every healthcare worker. And I think we've all learned that and are continuing to do that. Airborne transmission is, small droplet nuclei which remain suspended in the air for long periods. So, you have TB, chickenpox, measles, COVID. Again, other than the standard precautions, you need to put these people in airborne infection isolation rooms where barriers created through the negative isolation and there is enough barrier between the patient and the doctor. There is rapid identification and isolation of these patients so that again, it depends all in, it all has to be your clinical suspicion. Again, screening tools and clinical decision-making instruments can help inform this process. Importantly, as has been said earlier as well, that healthcare personnel should be vaccinated, whether it is hepatitis B, all the vaccines which Dr. Gaurav spoke about. And we must remember that these vaccines do not replace the practice of hand hygiene or droplet precautions, but it can be effective in preventing infection. But there is, of course, more research needed on that. We move on to the ambulance. Again, you have to ensure that standard precautions. It is, ambulances is a very, it is moving all the time, and you don't know who's going to. You're just going to pick up a patient. You don't know what is going to, what sort of patient you're going to receive half the time. Pre-hospital information is not great in our country, so we just, instead of being faced by a surprise, we should follow the standard precautions each and every time. Hand hygiene, full sleeve gowns, plastic aprons, gloves. Be very careful of what you're doing in terms of handling secretions and spillages, cleaning up infectious body fluid spills, or treat every spill as infectious until you know it with 1% hypochlorite. Sharp containers and waste containers should be present in the ambulances appropriately and appropriately discarded. And each person involved in ambulance transport, whether it's the driver or the housekeeping boy, and of course the nurse and doctor should know this. After the ambulance call is completed, every part of, whether it's the bedding or it's the equipment that is being used, everything should be disposed of or sent for sanitizing in an appropriate way. During the transport, there should be movement, should be restricted as much as possible. If possible, and the patient is not very aggressive or any of that, a surgical mask should be put. So it minimizes dispersal of droplet nuclei. All wounds should be covered with impervious dressing or at least have some sort of a barrier. All the personnel should be notified prior to arrival in case you think this is somebody who possibly could be a communicable disease patient. Conscious patients should be, educated to the nature of infection, and all patients should be instructed to follow respiratory hygiene and cough etiquette. At the end, I would say that it is also about capacity building. So, evolving and updating triaging tools and identifying communicable diseases is right at the top of it, because only if you're able to identify can you segregate. So training is important, isolation and management too, and donning and doffing of PPE, and what is the appropriate PPE needed for what kind of communicable disease you're dealing with is very important. Thank you.
Thank you, Dr. Priyadarshini, for another very important talk. I fully agree with you. When the patient comes to the ER, you have no idea what you're dealing with actually, and all the infection control has to begin from there only to prevent cross infections. Otherwise, ER can actually become a hub of cross infections very, very easily.
Yes.
I guess we'll take the question in the end. And so let's move on to our next speaker for the day now. The next topic is on radiology, and we have none other than the legend in radiology, Dr. Harsh Mahajan, to talk to us about how to maintain infection control practices in a radiology center. He's the founder and chief radiologist of Mahajan Imaging, Padam Shri awarded. If I start reading his CV, I'll probably spend an entire day on reading all the awards that he's got. He's a very close friend, a very dear friend, and always has come to our help whenever needed. So I'll hand over the mic now to Dr. Harsh Mahajan.
Thank you very much, Vivek. You've been very generous, and we are very, very close friends. Are you able to see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Yes.
So much more visible, sir.
Yeah, thank you very much. So I'll really be speaking on radiology practice in COVID times, how it has changed, because frankly, in radiology, we have not been very cognizant of the fact that we may cause infection, or that our personnel may get infected, except for those who have HIV, where you have been taking precautions forever. So I'll really take you through how things changed in COVID times. One was maintaining service during this pandemic, and then the other thing was managing the post-peak surge, when patients, who had been waiting for a long, long time came back. And there were guidelines, the Radiology Society of North America, the American College of Radiology, our own Indian Radiology and Imaging Association, and the Indian College of Radiology all came out with statements and as to how you could actually be safe for the healthcare personnel, and safety also for patients whom we were seeing. And the current situation, it is unclear how long the pandemic will last, and it may persist for months. And throughout this time, it will be important to perform safe, comprehensive, and effective care, recognizing that there is asymptomatic transmission, which is very common. As Dr. Nangia would agree, about 60 to 65% of patients are asymptomatic, and that's a huge problem with this disease, because in asymptomatic who don't even themselves know how to stop transmission. Now, there are comprehensive strategies which are based on these factors, the consideration of local COVID-19 stats, the PPE, these government mandates, our own institutional regulatory guidance, local safety measures, healthcare worker availability, which we've seen fell off during the peak of the pandemic, especially in the second wave, patient and healthcare risk workers, and then factors specific to radiology care examination. The overriding principle for risk benefit analysis for postponing versus performing diagnostic procedures. If the risk of illness or death to a healthcare worker or patient from healthcare acquired COVID-19 is greater than the risk of illness or death from delaying radiology care, the care has to be delayed. And this is something which we realized very quickly. And if the opposite is true, then radiology care should proceed in a timely manner, taking all precautions. The critical components of safety measures: screening for disease, testing, using PPE, and of course, infection control processes. And the safety measures are screen all patients. All patients who were coming in were being screened. And even during scheduling, we were trying to pick up those who may have possibility of COVID. Screening all patients when they walk in, develop a plan to manage individuals who screen positive on entry. Of course, ensuring sufficient PPE, which thankfully, with the huge amount of PPEs that is now manufactured within the country, this is not a problem as it was during the first wave. And we actually are using it left, right, and center now. In the first wave, we were very, very picky about who would use the N95, who would get a proper gown and all of that. Then, of course, training staff and implementation of universal masking, not only of healthcare workers, but as we learned in the early parts of the first wave itself, that masking universally anyone who walks into the department. And then, ensure a specific PPE for aerosolizing procedures, which some of them are done in the radiology departments, enable social distancing within waiting rooms, hallways, and work areas, streamline patient flow to minimize unneeded contact. One-way corridors were created in many hospitals, implement methods to minimize time in waiting rooms. Patients were made to wait in cars and asked to come in only after, when their turn came, and then optimize the efficiency of every patient encounter. The idea was walk in, walk out, and provide care in designated areas to patients with known or suspected COVID-19. Then cleaning and decontaminating patient care areas according to guidelines, restricting the number of visitors accompanying the patient. In fact, this was very, very important. And thankfully, most of the accompanying people understood this. Prevent symptomatic visitors from accompanying patients, even that could happen. Create a policy for safe ambulatory imaging of patients with recent COVID-19, enable remote work, and this for radiology worked very, very well. Radiology is all digital, images are all digital, and hence we had, rather than having our radiologists come to the imaging center or in departments where, in hospitals where we do radiology, most were working from home. And it's only those who actually needed to be there, say for doing ultrasound or things like that, were those who came to the department. Otherwise, CT, X-ray, MRI, nuclear medicine, PET CT, they were all being reported from home. Enable telehealth when feasible, pre and post procedure visits were avoided, and develop an effective communication strategy for safe best practices. Even when we were interacting with patients who would come in, we would rather interact on the phone than physically. Then we had to respect local pandemic statistics. Delhi currently is in a great place, but less than 0.1% of positivity rate. But so it varies from the 40%, which we had nearly reached during the second wave. So we have to defer time insensitive care until at least 2 weeks after the local peak of the pandemic. We ensure PPE needed for low risk care will not consume PPE needed for high risk care. Especially during the first wave, we learned this. Follow institutional and government regulations, monitor on a daily basis local data to predict secondary and tertiary peaks, and prepare for repeat de-engagement of non-urgent care if local data again starts going up. Then we have to look at risk versus benefit decision making. Is this test going to be more benefit rather than risk to the patient? And this was very, very important. And for this, we had to consider clinical acuity, risk factors, underlying disease, and the risk from COVID-19, and also referring providers and stakeholders were brought into this and told that why send people for non-urgent care, and then determine whether lower risk diagnostic strategies can be pursued, and then coordinate re-engagement strategies with institutional plans for ambulatory care. Postponement of non-urgent outpatient imaging, all screening radiology exams, mammo, lung cancer screening, colonoscopy. We said you don't need to do it anymore, at least at the peak of the pandemic. Other elective diagnostic examinations, after discussion between the radiologist and healthcare provider and the patient, were deferred. However, critical and time-sensitive imaging necessary for treatment decision-making was performed within the needed time frame. Now, there could be suspected or confirmed cases of COVID-19, and we had to develop a method to identify such patients. And we had to, there were staff in direct contact with COVID-19, and persons under investigation should be fit tested for N95. N95 masks also come in different categories, and this needed to be done especially for our own staff. And some N95 masks have metal strips, and it's important to know that these should not go into the MR room, and the patient should not be wearing it when he's being scanned, because that can lead to burn injuries. Protection of radiology staff was very important, taking appropriate precautions while conserving PPE. Two types of precautions for patients: less stringent standard droplet contact precautions, which applied to most patients, and more resource-intensive airborne contact precautions, which applied to patients who were critically ill, intubated, or were to undergo aerosol generating procedure. Then, of course, airborne contact precautions, we all know about these, and there are multiple, radiology procedures where these kind of precautions had to be taken. And then to address the backlog of previously deferred and delayed care, there again, risk versus benefit had to be considered. Now, estimating the risk from imaging delay, urgent or imaging and procedures like severe abdominal pain, you can't, defer this. But routine, but time-sensitive imaging and procedures like cancer, staging CT, where it was important for instituting treatment quickly, you couldn't defer these. But elective and screening and research, all of those were deferred. The decision to image patients who are COVID positive or suspected is based on how the imaging will impact patient care. So even the COVID positive, and we saw positive patients rushing for getting CT done all over. I mean, there were queues of patients and they didn't need it. And this is something which had to be brought home to the GPs who were referring them, or to patients themselves who were rushing in to get this done. Now, what was the approach to imaging during COVID? Actually, portable radiography was the mainstay imaging tool for the emergency department and in inpatient settings. And this helped us a great lot. Room cleaning, which was multifactorial with consideration for room air exchange rates, which, became very important, something we never considered before in radiology departments. The higher the air exchange rate per hour, the shorter duration needed for room closure. And this became very important because you couldn't have a CT scan room closed, for an hour between positive patients and negative patients. And that's where rapid room exchange was helpful. Then elective procedure cancellations, like I said, the goal is to conserve resources, conserve inpatient capacity that may become needed, consolidate staff for mobilization, and protect our patients from exposure. However, this should not affect emergency or critical procedures. Now, radiologists' workflows, section, faculty, trainees, essential staff was scheduled to work in exclusive teams that alternatively cover weeks to minimize exposure across the section and maintain the workflow. You don't want your 4 of your best radiologists or your best technicians to fall sick at the same time and not be able to come to work. So you had to ration them. You had to divide the workforce and have only certain people come in, divide them into team A, team B, working for alternate 2 weeks and 2 weeks out. Luckily, radiologists could stay at home and still be very effective in reporting And this, frankly, every radiology department in the country started using teleradiology. Then phone communication between radiologists and other staff were preferable rather than in-person communications. And similarly, we considered workflow for virtual consults with the ordering clinical teams, including phone and telecommunication capabilities. And this is something which has now also become pretty mainstream, even though the number of cases have come down. Now, what to do with employees with symptoms of COVID? They stayed home, and of course, there were strategies which were made. Test-based strategy for return to work, and non-test-based strategy, which was the 10-day, where the last 3 days was asymptomatic, and we followed this very, very diligently. Then formation of a radiology crisis management team or task force. This will provide quick decision making, policy discussion, information gathering, and policy dissemination. And all of this was very, very helpful to us, where people from the ground were also part of this task force in reducing the infection rates within patients and to the healthcare workers. Social distancing within radiology, trying to add workspace, emphasis on social distancing throughout the department, no crowding together in the console rooms, and corridors were made one way. And also, we had these fixed timing where within the hospital the positive patients were scanned, whether inpatients or outpatients. There were fixed hours, and during that time we had no one else could mix. These green corridors were created, and these frankly worked very, very well, and there were hardly any complaints of people having been infected. Now, how do we open after the pandemic? The timing for opening depends on institutional, state, and city policies, and depends heavily on the course of the pandemic in your region and capabilities of the institution. Consideration for a slow ramp of imaging volume should be made with the goal of preventing increased staff and patient exposures, and most importantly, regaining public confidence. Then the scanning protocol approach. We move outpatient examination schedules in hospital departments to an outpatient setting, or designate within a hospital an MRI and CT just for patients who are positive for COVID-19. Of course, this was possible only where there was more than one CT in a hospital. And then we had to follow this maxim of few hours of the day. Limiting potential patient exposures in outpatient locations with ample convenient parking. A pull rather than a traditional push workflow was implemented. Patient check-ins were done remotely from the safety of their car, either by phone, text, or app, and the patient were made to wait in their car until the facility was ready to perform their procedure. This worked very well in our diagnostic centers as well as in our in-hospital departments. And then, of course, healthcare worker protection. They were told not to congregate, not to eat together, or preferably eat one at a time. But now we know that with the airborne, transmission that is there, you may come 2 hours after a positive healthcare worker has had his food, and if you eat in the same area, you may still get infected. So this is something which has to be given a lot of importance to, and eating in the open air may be the best approach. Now, we also, from the Mahajan Imaging Center for Advanced Research in Imaging, Neurosciences, and Genomics, gave some evidence-based recommendations. The first was that CT should not be used for screening or initial diagnosis of COVID-19, something which went absolutely berserk in the second wave. Then CT can be used to identify early markers for lung impairment in symptomatic patients with RT-PCR proven COVID-19 disease, especially those who have respiratory impairment. CT can be used for patients with non-resolving symptoms to study the progression of disease. And this is very important. Here, one decided whether one needed to be admitted in a hospital, one needed to go to an ICU, or one could be treated still at home, even though the symptoms were persisting. Then CT, we found, has a limited role in stable pediatric patients because most of them get better on their own. Then a major recommendation, I think, which really prevented infection of within the departments was that X-ray may not be performed on patients with history of fever, dry cough, and high pre-test probability of COVID-19 unless they had reduced oxygen saturation going below 94. And because many people were just coming for an X-ray with these symptoms, even the RT-PCR hadn't been done. X-ray should not be used as a screening modality for COVID-19. Then the main thing was that we considered every patient coming to the radiology department with any respiratory ailment as COVID positive and acted accordingly. Of course, the aim was for zero waiting time, fast in, fast out, sanitization done as per guidelines, where 2 CT scanners are available, dedicate one to COVID-19, a dedicated portable X-ray with cassettes should be used in the ICU, teleradiology to be preferred for reporting to minimize exposure to the radiologist. In the OPD setting or the fever clinic, again, a patient who comes, I mean, there was this, thing that they would be sent straight to the radiology department to get a chest X-ray done. And over time, after discussion with our clinical colleagues, this practice was done away with, and rather hemogram was done if there was suspicion. If COVID-19 testing, the RT-PCR was taking time, because lymphopenia also is a good indicator of infection in a pandemic setting. A chest X-ray recommended for those who came with severe symptoms, where there was possibility of a positive chest X-ray, and dedicated portable X-ray machine for fever clinics to be used where logistically possible. The portable X-ray really came into its own during these times. So in IPD patients, X-rays for all confirmed COVID-19 patients or those whose reports were awaited should be done at point of care, again using portable X-ray, and this reduced infection rates. The portable X-ray should be placed within ICU at all times and should be sanitized periodically as per guidelines. Where X-rays are done in the ICU, an attempt should be made that all those requiring X-rays should be scanned in one go, so as to limit the entry-exit of personnel, the X-ray technicians, to the minimum. Use of CT to be minimized, and scans should be done only when essential and when they are likely to impact on patient management. CT scan machines should be sanitized as per guidelines. Point of care ultrasound, which also has a role, but because of the chance of the healthcare workers getting infected, because you're right next to the patient for 5 to 10 minutes. So this was minimized and performed only in very specific clinical settings. And CT and head MRI were used in those patients who developed COVID encephalopathy or had stroke. So, in conclusion, I'll say that the radiology departments really changed the way they were before the pandemic, during the pandemic, and now are changed radiology departments. Frankly, I'll be very, very, say with a lot of humility that in the radiology department, the accent on infection control, infection prevention, this was hardly a topic of conversation. And it's with COVID that we've become aware of practices, of procedures, of methodologies which can be used to prevent infection both from patient to patient, patient to accompanying guardian, and from patient to healthcare worker and vice versa. Thank you so very much for inviting me, and it's been a real pleasure. Thank you.
Thank you so much, Dr. Mahajan, for sharing your own SOPs and a very candid talk on how you ran the center during this COVID, especially the second wave, when there was a deluge of patients. I'm sure managing them wouldn't have been easy. But believe me, anybody and everybody who came to your center came back very happy. One, because of the quality of the report, the quality of the center, how the infection control practices were being followed, how patients were being segregated. So I think kudos to you and your team completely for managing it so very well. Now,
Thank you so much.
Question that has come from Dr. Manisha, who's asking you that suites are closed, radiology suites are closed ventilation systems. Did you have HEPA filters in your HVACs, and what do you recommend when you're doing radiology for the TB patients?
See, HEPA filters you can have in all other places except in the MRI room. You know, in the MRI, some of the probably the pressures required are such that you cannot use them. So our approach in the others, even with TB patients, actually we've been very negligent. Let me be, and this goes probably across the world. It's somehow radiologists have not been, so aware of good practices, and even open cases, if you see in hospitals, whether private or public, generally will come in and be discovered as tuberculosis after the X-ray has been done. So, but the HEPA filters are there in the X-ray rooms, in the CT rooms, in the ultrasound rooms, but not in the MR room. And this is also not universal. The HEPA filters would be there in some institutions and not there in the radiology departments of others.
Excellent
talk, Dr. I'd like to invite my co-chair for this evening, Dr. Sonal Saxena, to introduce the next speaker and take it on further then.
Can we have the slide, please? Yeah, the next speaker is Dr. Syed Hassan Haris. He's professor of Department of Surgery at Jain Medical College in AMU, Aligarh. He's an extremely talented person who's been awarded the Fellowship of International College of Surgeons, and he's also been awarded the Fellowship of Association of Surgeons of India, and has more than 60 international and national papers to his credit. Over to you, Dr. Syed.
Thank you. Okay, thank you so much, the organizers and the chairpersons. Of course, the topic is infection prevention and control in endoscopy. So I'll just have a brief outline of how do we prevent infection and control. So this is how I'll go through in a very short period with aims and objectives, an overview of the endoscopic transmission of infection. The most important part is endoscopic reprocessing, and of course there can be failures. And then we will talk about general infection control and protection of the endoscopic personnel, and of course a little bit of COVID, because we've already discussed a lot of COVID in this. Now, the American Society of Gastrointestinal Endoscopy has assessment scoring, and they have a plan. And the protocol for infection control and endoscopic suits was given in 2016 by this association. And then they have recalibrated the recommendations on the basis of a lot of literature that was studied for the last 2 decades. So for the past 2 decades, they have studied all the literature that was available in relation to the infection from endoscopic suits, and they have incorporated that into the guidelines that they have made. And these guidelines have come into force in 2018-19. So going forward, we see that endoscopy, of course, we normally introduce a scope inside. This is very basic. They'll go into the oral cavity, esophagus, and the stomach and the duodenum to visualize, to do a lot of therapeutic procedures, and of course to do ERCP with the upper scope. Now also the colonoscopy is a procedure where you put in a scope through the anus and go into the large intestine, and whole of the large intestine is being seen. You can take biopsies, you can do a lot of therapeutic procedures in this. So you introduce a scope inside the lumen of the gastrointestinal tract. Now, what can happen? Millions of endoscopies are being performed annually. All of us are aware. After ultrasound, probably endoscopy is the most important investigation that is being done routinely throughout. But the chance of infection and adverse events after endoscopy remains not very, very common. They are rare. So endoscopy related transmission may occur from patient to patient by contaminated equipment. So that is the most important route. We put in a scope inside one patient and do endoscopy onto the other patient, and then there is a possibility that cross infection can occur from one patient to the next patient. So that is one option. And non-endoscopic transmission of infection within endoscopy units from patient to personnel. So the patient might be infected, as a patient might be having hepatitis B or hepatitis C, and there is a possibility that the infection can occur in the person who are doing the healthcare workers which are there. So the basic aim of this topic is to disseminate information and to promote understanding of endoscopy related transmission of infection and how do you prevent this infection. So just the overview is that external surface and the internal channels of the endoscopes are exposed to body fluids and contaminants. So you have a scope, which is the outer sheath, and then there are a lot of channels inside through which you can put in air, you can put in water, you can put in endoscopic biopsy forceps to take out tissue, you can do a lot of therapeutic procedures through the channels. So the most important thing is that the infection can be onto the external surfaces of the scope or to the internal channels of the scope. So disinfection of these reusable instruments is a special challenge. So you have to be very, very careful when you do endoscopy on a particular person and then repeat it onto the other person, that it should be properly disinfected. So, but the most important thing is that sterilization is not a possibility in these endoscopes, because they are covered with rubber and they are heat liable. So there is a possibility of damage to these endoscopes. So reprocessing or the processing of these endoscopes is usually by mechanical and detergent cleaning. And then the most important part is high level disinfection. So that is what you have to do, rinsing and drying. So these are the parts that you have to consider in endoscopy suits. Now, out of all these studies that were done during the past 2 decades, the authors, multiple studies which were taken into account and seen what were the reasons for these infections. So they found that in a study that was done from 1974 to 84, all these studies, they found that 84 cases were there of salmonella infection. But since 84, there has been almost all negligible cases in most of the studies. Pseudomonas, although rare, in 2011, they reported 4 cases of Pseudomonas infection, and they were all attributed to machine failure. So the machine which was doing the disinfection of the endoscope, it failed, and they could recognize that Pseudomonas were there. There were other rare cases of Pseudomonas infection which is resistant to glutaraldehyde. So there were a few reports which suggested that they were there. Now, another infection that can transmit from one patient to the other is the Helicobacter infection, which is a very, very common problem in upper GI endoscopy, patients having GERD and acidity as such. So what you normally do is you take a biopsy in these patients. We normally put in a biopsy forceps and take a biopsy, and then we invade into the mucosa. And then there is a possibility that if you use the same biopsy forceps in one of the other patients, then there is a high possibility that the Helicobacter infection can spread from one patient to the next patient. So there was a study in these studies in the last 2 decades that 61% of all Helicobacter transmission occurred from infected patients to a normal patient by the endoscopic biopsy forceps. So this is another reason for this. Now in these 2 decades, they have found that no reports were seen of bacterial transmission. Now, bacterial infections, usually you can diagnose. It is not very, very certain that how you would make a diagnosis of infection occurring because of the endoscopy. It is very difficult to make sure that the infection has occurred because of the endoscopy or because of some other reasons. But bacterial infections have a short incubation period. Therefore, there is a high possibility that we can make a diagnosis. And sometimes reprocessing also inactivates the clostridial infection. So most of these patients coming with chronic diarrhea, where you do a lot of colonoscopies, and this where you take biopsies from one patient to another patient, there is a possibility of infection of clostridial infection, but they are rare if the reprocessing is properly done. Rare case, there are multiple individual reports which suggest that Klebsiella, Enterobacter, staph, they have also been isolated by spread from endoscopic procedures. Now, coming to the chronic viral infection. Now, these viral infections are extremely difficult to diagnose, whether they have spread from the endoscopes itself or from some other reason. The reason being that they have a longer incubation period. So in a study, it was seen that HCV related non-endoscopic than direct endoscopy related transmission in the study. So they had done in a study where they found that HCV infection occurred not because of the endoscopy procedure itself, but because in a study there were 87 patients where they found that 7 patients developed seropositivity of hepatitis C because of propofol usage. So the non-usable vial was used in a number of patients, because of which the hepatitis C positivity occurred in about 7% of 7 patients out of 87 patients in one study. So it was not related to the endoscopy. Similarly, New England Journal published in 1997, there were 2 transmissions on colonoscopy of hepatitis C. So the same biopsy forceps was used, and this led to transmission into 2 patients by colonoscopy. Hepatitis B appears to be very rarely transmitted by endoscopes, and manual cleaning, as in the most of the studies they have found, by detergent normally eradicates hepatitis, this HIV virus in 99% of the patients, and glutaraldehyde, if they use, almost negligible possibility of infection is there. Now, all these studies combined presented that what was the reason for these bacterial infections and viral infections in these patients. So it was found that insufficient initial cleaning of the endoscopes, which is the most important part. All the debris which is there on the surface of the endoscope was not properly cleaned. There was shortening of the immersion times into the detergent, so they immersed it, but immersed it for a shorter duration of period. And all these endoscopes have channels which have to be brushed properly, because when you suck or take a biopsy, there is a possibility that debris might be there inside these channels. So brushing is extremely important, and sufficient channel flushing was not done by water. And then inadequate drying was there, because if you don't dry the endoscope properly, what happens is the environment becomes so rich and there is a possibility of transmission of bacteria. Another reason was a bottled water. So if it is unsterile water, we normally use a bottled water, because water goes into the endoscope for flushing the endoscope while doing the endoscopy. So these bottles can be unsterilized, can lead to chance of infection. And also these endoscopes have, when we do ERCP, the terminal end of the endoscope has an elevator. Now this elevator, behind this, there is a possibility of infection settling, and then there is a high possibility that infection can spread from one person to the other. So these were the reasons in these different studies. They found that these were the reasons for transmission of infection of most of these patients. Now a lot has been said about the coronavirus. Of course, it can spread person to person, droplets, and infect in aerosols and contamination from the body fluids. But despite that, there was a study from Italy published in Gut in 2020 November. It said that chances of infection occurring in healthcare workers is extremely low, in spite of patients coming with, because all the precautions were being taken care of, and the chances of infection occurring in these healthcare workers are extremely low. This is one study, but multiple studies have been going on, and we will know the data later. Now, where do we fall? This Spalding's classification is important. Medical equipment risk for infection. So this is a non-critical tray, stethoscope. These devices just come in contact with the skin, and they do not need a high level of disinfection. So low level disinfection is sufficient in these patients. But for endoscopes, this is a semi-critical equipment, where these come in contact with the mucosa, but they do not penetrate the sterile surface. So you require cleaning and high level disinfection. So endoscopes come into the semi-critical level of just the endoscopes. But once you use the biopsy forceps or spectrotomes for ERCP, these penetrate the sterile tissue or the vascular spaces, and these need to be sterilized. So endoscopes can be disinfected, but the biopsy forceps is extremely important that we sterilize. Most of these endoscopy suits, the technicians usually just wash the biopsy forceps and they give it to the next person. There is a high possibility of transmission of infection in these patients. So require cleaning and sterilization. So this is what we just discussed. The high level disinfection is needed for endoscopes and sterilization for biopsy forceps. So this is the process of reprocessing achieved by mechanical and detergent cleaning, extremely important point, followed by high level disinfection, rinsing and drying. All these steps are extremely important for reprocessing of the endoscopes. Now, reprocessing of endoscopes can occur in two methods. It either can be manual or can be automatic. Now you see, the most important thing is the physical removal of organic material or soil, generally by using water and detergents. So if you clean the endoscopes properly by dipping it into detergent for a considerable period of time and cleaning these channels by brushes, so all these channels have to be brushed inside so that all the residue which is there in different channels has to be cleaned properly. So this is the most important aspect. Then high level disinfection, of course, is all of us know that has, and glutaraldehyde, if it is used for about 12 minutes at room temperature, it normally causes high level of disinfection in endoscopes. But normally, what do you do in an endoscopy suite in a government hospital? You have 20 patients waiting for upper GI endoscopy. So normally the physicians would probably not have those 12 minutes, and they would take a little less time to do endoscopy in those patients. So this high level disinfection normally causes vegetable organisms to for reduction and destruction, mycobacteria, lipoids, even lipid viruses like coronavirus, fungal spores, and some bacterial spores are also taken care of. Now, sterilization, of course, includes bacterial spores, but heat is used. So we cannot use endoscopes, because if you use it more than 60 degrees, it would be, you would damage the endoscope. So there are in these studies for the last 12 decades, they have found that there is no evidence to suggest that sterilization of endoscopes improve patient safety. So high level disinfection is sufficient enough for reprocessing of the scopes. So I'll just repeat the steps. First is pre-cleaning, completely clean the scope, remove the debris, microorganisms, and from outside the scope. So you have to pre-clean the scope properly. Then there is a leak test. There is the equipment which is attached to the scope, and we check whether it is leaking or not. So if the patient has bitten the scope from the front, there is a high possibility that it might damage, and the chance of bacteria going there and damage to the scope also. Then manual cleaning, extremely important. You take out all the biofilms from and you brush the channels, clean everything from inside. And then visible inspection is a part where you can do by a lens, and especially, as I said, in ERCP, where there is an elevator here, there is a possibility of infection there. And then, of course, the most important step is the high level of disinfection. And as I said, glutaraldehyde is the most commonly used. Formaldehyde, other substances are there which destroy the vegetative organisms, mycobacteria, fungi, and viruses. But the time of the scope immersion is extremely important. And then drying of the scope is extremely important. As we said, microorganisms might go into wet conditions, and there is a possibility of transmission. And then storage of the scopes also very important. You have to hang the scopes, not put in a suitcase, so that all the water just goes down. Now, automatic reprocessing is another process where the machines are used for automatic. So the most important advantage of doing automatic reprocessing, important reprocessing steps are automated and standardized, and likelihood of essential step being missed is reduced. And external internal component endoscopes are reliably and equally subjected to thorough disinfection. So all the channels are connected to the machine, and it rinses all the internal channels as well as the external channels. And biopsy, all channels are irrigated, cross contamination is prevented, skin, eye, and respiratory tract exposure to the personnel is decreased, and atmosphere pollution by the disinfectant is also reduced. So these are the types of machines where you put the scope inside and connect it to the different channels, and glutaraldehyde is put in the bottles here, and 5 minutes, if glutaraldehyde is used for 5 minutes, automated machines, normally reprocessing is complete. Now, sometimes there could be failure of reprocessing, usually arises from equipment or product failure, or therefore, if there is a product failure, reporting is must to the institution. Patients at risk must be notified. Early serological testing is imperative. Patients are advised to against blood donations, and personal counseling is very, very important. So reprocessing might fail, so you have to report the reprocessing. Now, there are general infection control measures, of course, which are there in all the suits. Transmission of infection from patient to patient might occur. Transmission of infection from patient to endoscopic unit personnel can occur because of the skin, needle injuries, blood splashes into the conjunctiva, or aerosols. So from the patient it might spread. And management of endoscopy unit personnel exposed to exposure post prophylaxis, of course, is very, very important. Now, protection of endoscopic personnel, CDC recommends that standard precautions applies to blood or body fluids, secretions, non-contact skin, and mucous membrane. So how do you do the standard precautions? It is done in every endoscopic suit. Hand hygiene is important, personal protective equipment, safe medication, and safe handling of potential contaminated material. So these standard protocols must be followed. Now, terminal cleaning is extremely important in these patients. As soon as you complete the endoscopy, the room must be properly cleaned according to protocol, and there has to be a written plan for addressing the terminal cleaning all procedures. And it includes methods of chemical agents for cleaning and disinfecting. So of the space where the patients were used. Now, it's especially important is the leadership. So if there is a leader to the endoscopic suite, he would have a protocol where the procedure for control of infection and prevention would be much better. Now, endoscopy during COVID, of course, a lot has been talked about by the previous speaker, but rapid spread of COVID postponed, a lot of endoscopy were postponed because of the COVID infection. So the gastroenterologists need to exercise discretion in implementing the individual suggestions and to weigh whether it is needed or not. And of course, if there is suspicion, PPE kits and all protective gear must be used before doing an upper GI endoscopy, because there is a possibility that the patient might spit after the endoscopic procedure, and chances of infection to the personnel is quite high. Now, the take-home message, just the last two slides. Transmission of infection as a result of GI endoscopy is rare, mostly due to lapses in endoscopic processing protocols or defective equipment. So it has been studied worldwide that if you do a proper reprocessing, the infection rates are very less. But if the transmission can only occur because of the faulty processes. Endoscopes which undergo high-level infection usually are very, very safe for endoscopy. Extensive training of staff involved in endoscopic reprocessing is mandatory. So all this staff, as I said, in government hospitals especially, they do it very, very quickly, and they are not well versed with the steps of reprocessing of the scope. Efficiency of the manual cleaning of high level disinfection is operator dependent. So therefore, the training of the staff for high level disinfection is extremely important. In the event of reprocessing failure, notification is must. General principles must comply of infection control. A use of standard precautions reduces the transmission of infection and patients to endoscopic personnel. So all standard protocols must be followed, and endoscopy units must have a qualified individual who directs the infection prevention plan. So leadership is extremely important in these patients. Thank you so much.
Thank you, Dr. Saeed, for a very enlightening talk. I can see that there are no questions in the chat box. So I think we will move on to the next speaker. Thank you so much again, sir.
Thank you.
So the next is Dr. Jyotsna Agarwal, Professor, Head, Department of Microbiology at RML IMS Lucknow. She's a graduate from CMC Vellore and a postgraduate from BHU Varanasi. She was an infectious disease registrar at the Royal North Shore Hospital, Sydney, Australia for a year, and has been trained in molecular diagnostics in Japan. She is now heading the department at RML IMS Lucknow since 2017. And prior to this, she was a faculty at King George Medical University for more than 15 years. She's also in charge or nodal officer of the COVID lab at her institute, which is an ICMR approved BSL2 labs, and have been one of the big performers with done more than 21 lakhs RT-PCR since April 22. She's also the Medical Education Unit Coordinator, Hospital Infection Control Committee Member Secretary. And apart from an interest in teaching, she's also actively pursuing basic research. She has successfully completed multiple research projects with ICMR, DBT, and DST and has more than 80 publications to her credit. Over to you, Dr. Jyotsna.
Thank you, Dr. Sonal. I'll just start screen share.
Dr. Jyotsna, can you be a little louder?
Yes. Okay. All right. Am I audible now?
Yes, ma'am.
All right. Okay. I'll just do the share screen. Just a minute. Yeah. So can you see the screen, Dr. Sonal?
Yes, ma'am. Yes.
Yeah. All right.
Yes.
Thank you. Thank you for that lovely introduction, and thank you to the organizers for giving me this opportunity. So previous speakers have made my task very easy. So I'll be talking about infection prevention and control in OPD settings. And of course, the headings under which I'll be covering will be standard precautions, education to healthcare worker, emphasis on the work practice, education of patients and their attendants, protection of healthcare worker, that is appropriate PPE, engineering controls, aseptic techniques to be used, which include single-use device, appropriate reprocessing of reusable items, occupational health, pandemic preparedness, BMW, and surveillance, incident monitoring, and communication. So the infection prevention and control first guidelines actually came way back in '83 when the HIV had just begun. But the formal evidence-based guidelines only came as late as 2011. And those were the first guidelines for the OPD setting and ambulatory patient care. And a lot of the material that is available at the CDC site, and there are a lot of guidelines available from Ministry of Health and Family Welfare also. So OPD, the frontline staff at the registration desk, first of all, needs to be really trained well to recognize and triage patients who show signs and symptoms of any transmissible disease, especially in the COVID setting. And we need to have visual alerts and posters at the OPD entrance so that patients themselves can recognize if they fit into any of those criteria. In fact, some of the guidelines even suggest to have a 3 or 4 question-based sort of, a small questionnaire at the entrance, and patient could quickly fill that out and, sort of decide as to, should be waiting at the OPD area or maybe, going or maybe being triaged to some isolation. Now, given the situation in the government hospitals that we have, there is a lot of crowd in the OPD. So the first thing which it needs for infection prevention is a robust crowd management system, maybe using security personnel, maybe having a good public address system, and keep giving audio sort of warnings, how to sort of wait and where to wait and things like that. It's a good idea to have appointment-based OPD setting, though it doesn't really work totally in our setting, because that would reduce the wait time and it'll be like quick in and out kind of a procedure, but it doesn't like generally work out in the government hospital settings. It's a good idea to restrict the number of people who are accompanying a patient so that there is less crowd and social distancing can be maintained in OPDs. There should be sufficient number of available dustbins, surgical masks, hand rub stations, and wash basins with running water and soaps. Also, while the patients are waiting in the OPD area, in the OPD hall, there could be some health education video clips or posters, there in the OPD. Maybe we can, teach them about cough etiquettes and mask disposal, or how to even properly sanitize their hands. The importance of adequate ventilation cannot be overemphasized, especially in the current pandemic situation. And what is said is that the direction of airflow should be in between patient and staff and not across patient and staff, which would probably be clear in this picture. So this is what should not be done. Here the airflow is from the patient towards the doctor. If the window was here, this is in a OPD which is naturally ventilated, but in case it is air conditioned, the source or the exit could be planned, should not be planned like this. Instead, it should be preferably like this, where the airflow is just in between the patient and not across like this. So it's going, from here to here. So it's the infection from the patient doesn't come to the healthcare personnel. Hand hygiene has been emphasized by previous speakers. Hand rubs should be available in OPD, and if the hand wash facility is there, then the drying hand facility should also be there, which does become difficult because we can't really use a towel, it gets wet. So there should be these tissues available and then appropriate bin available to discard the tissues. Personal protective equipment should be available depending on the type of exposure that is anticipated, contact or airborne or droplet. And enough training on donning and doffing of these PPE needs to be done, and it needs to be continuously monitored also. Also, one needs to plan in the OPD as to where will the healthcare personnel wear the PPE, because just providing them is not sufficient. There should be an area where they can don the PPE, and appropriately that too. And healthcare worker should be educated on, say, use of gloves, whether to use sterile or non-sterile in particular settings. Then respiratory hygiene, cough etiquettes. I've already discussed that these can be displayed in the OPD area for the patient and their attendant education also, as well as for healthcare personnel, they should be made aware also. Then some administrative recommendations for outpatient settings are availability of sufficient and appropriate supplies for standard precautions, which includes your rubs, hand rubs, and PPE, etc. Making sure at least one individual is available there to manage the infection control program in the OPD settings. And there should be written infection prevention policies available, which should be evidence-based guidelines for that particular facility, because the general guidelines may not be applicable to every facility. Then the recommendations regarding education and training of healthcare personnel in outpatient setting. It is said that task-specific trainings are better than just doing a general training. So maybe you could have a separate training session for the sweepers and attendants, let them know that the task-specific, whatever they have to do to prevent infection, from getting infection themselves or from spreading infection, separate for nurses, separate for doctors. And we need to focus on both the healthcare personnel safety as well as on patient safety. And training should be repeated maybe on annual basis or whenever the policies are changed or revised. And even competencies can be documented after each training as to whether this person learned how to don a mask, N95 mask properly, or to sanitize the hands properly, and so on. Then key recommendations for cleaning and disinfection of environmental setting and in an outpatient is to have proper policies and procedures for routine cleaning and disinfection, as well as for spill management. It's preferred to use EPA registered disinfectants, or at least any disinfectant or detergent with at least the label claim, for whatever you want to use it in the healthcare setting. And one must follow manufacturer's recommendation for the amount, dilution, contact time, and disposal of that disinfectant. And recognize the frequently touched surfaces in the OPD like doorknobs, and the cleaning and the disinfection emphasis should be more on these surfaces. Then this is from the Swachhata guideline, where they advise that garbage removal can be done, maybe 2 to 3 times a day whenever the bags are 3/4 full. And otherwise the mopping or cleaning could be done once a day. But of course, this would depend on the footfall. And for the mopping, they've advised detergent and water. And for washrooms, it's 0.5% chlorine. Methods of cleaning have also been very, in detail, they've been described in Swachhata guidelines. They could be actually the hospitals which can afford, they can buy those cleaning machines. Otherwise, there is a double bucket system, 3 bucket system, and even the method as to that the mopping should be unidirectional, and how the area should be cleaned starting from one point, not going to that area again and making an exit. All these are available in the Swachhata guidelines. Preparation of chlorine solution that one may need for the cleaning and disinfection, either using a hypochlorite solution or using a bleaching powder, whatever strength you need, these are also available. One may consult these to prepare appropriate strength chlorine solution. Then for reusable medical advice, I think the previous speaker has very clearly elucidated with endoscope examples. So if any of the medical devices in the OPDs have to be reused, then there should be a protocol in place for their proper disinfection or sterilization, whichever is required as per the Spalding classification. And this is a general protocol which is followed and is given in NHM MHFW also, that a first step should be decontamination, then thorough wash and rinse. And accordingly, if the instrument needs sterilization or HLD, the procedures are given which can be followed up. Occupational health has to be sort of kept in mind for the OPD staff also, which the key components being their immunization, which has already been mentioned by the previous speaker, the necessary immunizations which should be in place, and prevention from bloodborne exposure. And the audit and surveillance of any healthcare associated infection in outpatient setting should also be monitored, and any incident reporting should be done. It is advisable to have various policies and forms available on the facility website. Even health alerts and videos can be put in there. Monthly newsletter is a very good idea to disseminate information regarding prevention of healthcare associated infections in outpatient setting, or for that matter any of the hospital area. And there could be regular multidisciplinary meetings to discuss any issues relating to these settings. Biomedical waste management, again, it's standard. The bins should be available, and staff should be educated as to what is to go in which bin. And particularly for COVID-19 waste, what is recommended is double-layered waste bags, and the waste has to be labeled as COVID-19 waste. And just touching upon pandemic preparedness, though it's been a year and a half, and I think all of us are pretty well versed with how to sort of manage these things now. So the main issues are like screening and isolating potentially infectious persons, appropriate PPE use, cleaning and disinfection. And staff also needs to be encouraged to go in for self-reporting if they have any symptoms suggestive of COVID-19 at the earliest. And this is, again, I think all of us have been doing it for last year and a half. In case of COVID-19 cases detected in a non-COVID health facility, in an OPD setup, what is to be done? That patient needs to be immediately isolated with a dedicated healthcare worker who should be attired in appropriate PPE. Then the transfer needs to be done to a dedicated COVID-19 facility, and that facility needs to be informed beforehand about the transfer. And while transporting, appropriate standard precautions are needed. And this should be followed by disinfection at the facility and the ambulance, like was mentioned before. So this is what I have for the OPD settings. And thank you so much, everyone, for patient hearing.
Thank you, Jyotsna. That was really very useful and very much needed for all purposes. There is I'll just check the question chat box. I think you can take this, although this was for Dr. Harris, that is the high-level disinfectant effective against the non-tuberculous mycobacteria?
I think what I'm aware is that HLD is the appropriate method to take care of all mycobacteria. Besides, like Dr. Harris mentioned also, I mean, there is no scope of sterilization for endoscopes because the time required is just, not practical. So this is good enough, HLD, in my opinion. What do you say, Dr. Sunil?
Yeah, I agree with you on this. That is the purpose of HLD. The other question here is that do we need to change glutaraldehyde solution depending on load of endoscopes disinfection, or we can use the same solution for a 14 days activation period irrespective of load. My internet bandwidth is not permitting me to switch on the video, so I'm requesting the organizers to not switch on my video, please.
So this one, I don't know what the manufacturer's recommendation would be, and maybe they could check with that. I'm not really sure that whether they can just go on for 14 days regardless of the load. So maybe
I
Dr.
also feel it
Harris would-
depends on a lot of
yeah.
things, presence of organic matter, whatever is there, what situation it has been used.
Can I
So,
make a comment, Dr. Sonal? Permission.
please go ahead, sir.
Namaste. So, see, that is why the role of the strip test comes, which looks at dilution, before each and every immersion. So that is something which needs to be done by everyone. And that is where India lacks, in fact, because it turns out to be expensive. It turns out to be expensive proposition. So not many people indulge into it, but that is where the role comes because it checks dilutions. We had, once we started with the strips many years back, about 2 decades back, we saw that the dilution occurs much faster than 14 days. And it comes down below 1.5% very fast at times if the staff is not careful with washing and immersion of scopes. So that is where I would recommend that each one of you, at least for endoscopes, should have, and endoscopes means bronchoscopes also along with it. So you should have that strip test done for chemical viability of the HLD. So that would be something to consider. It would detect the dilution very fast, and you have to drain out the the disinfectant, and then do it again. So that will help the standardizing the practices also of how to clean the scope, how to make it dry, and such like things.
Right, sir. Thank you. So I think now I'll hand over to Dr. NP Singh for taking over the controversies and clear. Dr. NP Singh is Director Professor and Head Department of Microbiology at UCMS and GTB Hospital. And he's responsible for, he's working on a CDC ICMR funded project on pneumococcal vaccine and has more than 25 MD theses and has evaluated multiple PhD theses and students. He's a member of the Board of Research Studies of Microbiology at IMS, BHU and AMU Aligarh, at KGMU Lucknow, SGPGI Lucknow, Jolly Grant Medical College, Dehradun. He's presently the head of Faculty of Medical Sciences at Delhi University as well, and has been an executive member of IMM Delhi chapter and the national body. He's been a president of IMM Delhi chapter and has been in multiple selection boards. He has more than 60 publications in reputed national and international publications, including Journal of Antimicrobial Chemotherapy, IJMM, and Journal of Medical Microbiology. Over to you, sir.
So, good afternoon, everyone. So, good afternoon, everyone. I'm Dr. NP Singh, and thank you, Sonal, for your kind words, and thank you, organizers, for giving me this time. And Sonal, you must be agreeing with me that most of the speakers, they have talked about the things which I wanted to talk. So my job has been, and even the last presentation was also very good. And as far as one controversy which was just arrived, that whether NTM they are resistant to, or the glutathione is effective against that. So there is a little controversy about that, glutaraldehyde may not be effective against some specific mycobacteria like Mycobacterium chiloni and Mycobacterium fortuitum. So in that case, paraphthaldehyde 0.55%, that can be one other agent which can be, and even Mycobacterium avium, that can be, that may also be resistant to this glutaraldehyde. But otherwise, glutaraldehyde is a very good high-level disinfectant for the proper working of the endoscope. So coming to my first slide, this is on infection control measures in hemodialysis unit. And infection control measures in hemodialysis unit. Hemodialysis patients, they are exposed to different types of infection, which include bloodstream infection and localized infections of vascular access and blood-borne viral infections like hepatitis B, hepatitis C, and HIV, and sometimes airborne infection like tuberculosis. And outbreaks of hepatitis C virus infection in HD facilities, it have been seen, but the source of infection most of the time have not been detected in those conditions. And all of these points has been explained well by Dr. Gaurav, because he took this thing. And to re-emphasize the points, that environmental cleaning or disinfection is important, equipment cleaning or disinfection, standard precautions, as all of the workers, they have mentioned that standard precaution in the form of one most important thing which was emphasized by all of the speakers was about the adherence to the hand hygiene. And the adherence to the hand hygiene, maybe the compliance may be increased by proper training and by the visual alerts which can be placed, or by other means, so that the staff is motivated for, like in case of hemodialysis unit, for single patient, there are at least 25 to 30 opportunities of hand hygiene. So that is one very big area where there can be a breach if it is not adhered to properly. Now, coming to, there are several other important areas for infection controlling in hemodialysis unit. And these are important, what are the core interventions that can be done in case of hemodialysis units. And the core interventions like the prevalence of bloodstream infection on monthly or quarterly basis can be disseminated. And second, the hand hygiene observation opportunities and how the compliance have been achieved, that can again be disseminated for the better of the employees' hand hygiene adherence. Then there are certain other important things like what are the different competencies which staff has to go through, and these competency may be related to the proper care of catheters, proper care of AV fistula, and proper care of scrub portal, scrub the hub portal a protocol. So I think now coming to the second important thing, that is infection control measures in emergency care units. This, you all know that emergency department is a busy place subject to rapid patient turnover and overcrowding. Half of all admissions to the hospital are from the emergency. The emergency department is also the front line in response to public health emergencies and disasters. Patients admitted through the emergency are sicker than those who report to OPDs. And there are important, like in case of this thing, the emergency department, there are various priorities which are important. What are those priorities? Like what are the key priority areas in the emergency department infection prevention, for the emergency department area infection prevention? Then again, in this case again, that the chances of patient and healthcare personnel contact in the waiting area, they are more. So that is why the the number of patients has to be limited actually. So the increase the manpower is very important for this. And in case of emergency department, the other than hand hygiene, which is very important, transmission based protocols, transmission based precautions, they become important, and which you all know that in case of airborne infection or droplet infection or contact infection, either surgical mask or respirator or proper PPE in the form of gloves and glove etiquettes and gowns, shields, and goggles, which can protect the healthcare workers also. And now coming to, so this you all know that high volume of patients may needing rapid intervention, patient present with undifferentiated illness that have been told, acutely ill and injured patients undergoing evaluation, risk recognition and decision making are often based on limited and changing data. Patient awaits diagnosis. So this waiting period jo hai, that becomes very important for the contact for infection. So there we have to implement the strategies for reducing the infection control. Like IPC in emergency care has two aspects. One is preventing the transmission of infectious disease from ill patients to healthcare workers and to other patients. And second, reducing the risk of infection associated with receiving emergency care. So basics of standard precautions, they are very important. And secondly, the reusable instruments, pre-cleaning of reusable instruments before sending to the sterilization department is also very, very important, so that the material may not adhere to all those surfaces and the disinfection may become inadequate. Infection control measures in OPD, I think Dr. Jyotsna has wonderfully explained that how the registration desk, where a short questionnaire can be there in those situations where you can expect large number of similar type of patients, and so that they can be isolated or they can be segregated. Then pandemic preparedness, again, she has very well explained that how you can prepare, like we all are doing for last 1 year, and the means how the PPE should be donned and how PPE should be doffed, and where the PPE material has to be discarded in which particular biomedical waste bags. Infection control measures in ambulance services, again it was a neglected area, but again this area is very important in the sense that we do not know much in means we have been very little informations have been there on this, though the guidelines are available, but infection control is an important part of everyone's daily life and is achieved through common sense and basic hygiene procedures. During the course of their working lives, ambulance personnel may be unknowingly exposed to a number of infectious diseases which could potentially cause them harm or be passed to other patients. Therefore, extra precautions need to be practiced and adhered to. So, immunization and guidance, like ambulance staff should be vaccinated against tetanus, against hepatitis B, rubella, poliomyelitis, diphtheria, and tuberculosis. Staff illness and reporting So again, the employee has to inform to her employer if he or she comes in contact with, or if he has done some breach of infection, so that he can be taken away and he can be replaced by other. And the infection control measures of the whether guidelines, whether what are the parameters to look for during audit of IPC practices in ambulance services, in the form of vehicle cleaning, whether daily cleaning or weekly cleaning, ambulance station housekeeping, whether this cleaning has to be done in housekeeping area or a designated area, what are the infection prevention control practices which he has to be trained for that. So this has been so vehicle cleaning is very important. A routine cleaning of vehicle should be carried out daily for internal and external structures when practicable, and weekly for removal for all the removable fixtures and equipment, unless they are contaminated. They are not contaminated. Infection control measures in radiology, I think Dr. Harsh Mahajan has done very justice to his talk, and he made his talk very lucid, and means how the infection control measures were taken during the COVID-19 pandemic between the CT between the patients, means and how it was maintained, how the social distancing was maintained, how the patients, they were informed on telephone to wait outside so that they may not the healthcare professionals may not be exposed. So there are guidelines which I think he has already mentioned, and the now endoscope, I think Dr. Harris has done wonderfully well, and until unless there is a breach in the instrument, means fault in the instrument, and infection control measures are appropriate, then there is no means only when the breach is there, then there are chances of infection. Otherwise, most of the infections, they are prevented by high level disinfectant in the form of 2.4% active glutaraldehyde. And timings is very important. 12 to 20 minutes are recommended, and this timing is again very critical for the decontamination of the endoscope. And all these procedures, cleaning, disinfection, rinse and drying, and then before the end, then it may be used for the other patients. Now coming to the questions which can be to the speakers, I think is it really necessary, like in case of hemodialysis, there are 3 or 4 questions which came to my mind, so that I shall ask. Is it really necessary to have separate dialysis machines for patients infected with HIV, hepatitis B and HCV? So Dr. Gaurav is not there. If Dr. Sardana, if you want to answer, or otherwise, most of us know that for hepatitis B virus, for hepatitis B, the machine, the hemodialysis machine should be a designated one. But in Western countries, for hepatitis C and HIV, there is no such designated machines. But in India, since the HCV has been again an important blood-borne pathogen, so there is a means some of the hospitals, they have designated machines for hepatitis B as well as hepatitis C, means they have designated separate rooms for hepatitis B dialysis machine and for hepatitis C virus designated machine. For HIV, there is there is no risk actually, so that can be taken. Then is temporal separation is a recommended, that I think Dr. Gaurav has already explained, that in case there is only one machine or there are less machines, then temporal spacing can be done, and it can be taken at the end of the day And after that, the terminal cleaning of the hemodialysis unit can be done so that the machine can be ready for the next patient next day. So what are the priority areas to reduce the bloodstream infection and bloodborne virus infections? So I think the bundle cares, which may be there in the form of different procedures which are involved in hemodialysis, making the fistula, maintaining the catheters, maintaining the AV port hub, or detaching and connecting the catheter. So those are the areas where the bundle approach can be used. And the current pandemic of COVID-19, how do we ensure staff safety of personnel involved dialysis procedure in hemodialysis unit? That we already we all know about the and coming to emergency care department. How do we ensure good IPC practices in the emergency care department? I think again this has been dealt. And how does this is very important? How does standardization and optimization helps in adherence to IPC practices in the emergency care departments? And how the workflow is very important to reduce the load and to reduce the infection opportunity between the patient and the doctors. For ambulance services, again, the audit parameters which may be important regarding cleaning, regarding personal standard precaution techniques which the employee should know. So those are important. And radiology, I think Dr. Harsh has already explained about COVID-19. Outpatient department, Dr. Jyotsna has mentioned about that by monitoring healthcare associated infection in OPD services, like whenever any procedure is done, the patient can be explained what can happen later on. So he can be told about the signs and symptoms of the infection or inflammation, and we can also track the adherence of the healthcare infection control practices like hand hygiene, like wearing of a proper mask, wearing of proper PPE in the OPD services area. And third, that what are the key visual alerts in the OPD services? So this may be related to respiratory infections which are communicable in nature. This may be in terms of information to the patients regarding maintaining the social distance. It may be regarding the respiratory etiquettes, or it may be regarding the healthcare personnel, how they can how frequently they have to wash properly, look for their hand hygiene. Endoscope, I think Dr. Harris has already mentioned. So thank you, Dr. Sonal, for and thank you everyone for listening. Thank you, Dr. Sonal.
Thank you so much, sir. That was very informative. And there are a few questions addressed generally to all the panelists. And one of them is that related to decontamination of RT-PCR laboratory, COVID versus non-COVID, what should be the strength of hypo solution? I think that is what they want to ask to Dr. Jyotsna. Is Dr. Jyotsna there?
No, ma'am. No.
She's not. Okay. If anyone else would like to take that question.
Well, it is 1% only.
I think it's the same.
0.5 to 1% only.
Yeah. Initially, it was 5%, and then they dropped to 2%, and then they dropped to 1% being effective. This is how
I think right now it is 1% only, Dr. Raman.
As we gained knowledge, and it came to 1%. The other question has already been answered by Dr. Raman Sardana. It was that do we need Sidex strip testing for orthophthalmiaid, and that has been answered by sir that yes, we can use the same. And the other question is Sidex OPA can be used to disinfect as it uses mycobacteria. OPA is the, I think we are continuing the same discussion, so there are no new questions. Thank you so much.
There was a question to Dr. Gaurav, I suppose. Dr. NP Singh had some question for Dr. Gaurav.
Dr. Gaurav to chale gaye sir?
No, he's there, sir.
So the
Dr. Gaurav aa gaye?
question was about using dedicated machines for hepatitis B, C, and HIV.
Yeah, sir.
So in our hospital also, we have the guideline is to use dedicated machines only for hepatitis B, since the virus is very unstable and the risk of transmission is very high. But unfortunately, there is a stigma attached to HIV, and that is the reason we are forced to segregate these patients in dialysis units. There are so many dialysis units who are not taking patients with HIV also. So at least we don't follow that practice, but as a protocol, just for the sake of other patients and the stigma attached to it, we segregate patients with HIV as well. And there are certain centers who are using dedicated machines for hepatitis C also, but I always feel it's not the machine which is transmitting the virus, it's the human hand which is transmitting the virus, and hand hygiene and those practices are more important rather than dedicated machines.
Perfect.
And I think that is the reason what we have been practicing. See, dialysis and emergency can arise anytime. There are so many breaches which can happen. And for this reason, we have dedicated technicians for hepatitis B on that particular day. So when there are patients with hepatitis B, there are generally 2 or 3 patients who get dialysis in a day with hepatitis B. And for that particular day, we designate technicians that they will be handling those patients only. I don't know how much, what the guideline for this are, but it definitely reduces the risk of transmission. You can imagine a technician sometimes have to change gloves 5 or 6 times during a 4-hour session because of some emergency or because of some blood flows. So it is not practical for them also that they keep on intermingling between positive and negative patients. I think that really helps in reducing the risk of transmission.
Sir, for hepatitis B, I think you are quite right that there are guidelines for dedicated machine and dedicated staff. And for hepatitis C, again in India, though the the guidelines are against hepatitis C and HIV, but again there are designated machines which are kept for hepatitis C and as well as for HIV. So I think with the adherence to the infection control practices over the time, I think this will definitely go.
Yes, I totally agree with you, sir. I totally agree.
Sir, it is more, as Dr. Gaurav has said, it is more for administrative purposes. There is a big ruckus from the dialysis patients and their relatives. Every time they come to know about, just because of the stigma being attached.
And sir, for that matter, it is hepatitis C which is most rampant in dialysis patients. And in our hospital, we are not isolating hepatitis C patients. In any dialysis units, it's hepatitis C which is a nuisance. There would be at least 25 to 40% of patients, especially in the peripheral centers, who would be positive with hepatitis C. And in our unit, we are not isolating these patients.
So we are just banking upon infection control practices to break the chain of transmission. And that has worked so far in past 2 decades or so. So I think that you're saying that infection control practices definitely are the core for prevention of transmission in hepatitis C as such. So actually speaking, there is no need for HIV also, but there's a lot of stigma attached to it. Very difficult to contain patients and for a smooth functioning, mainly for administrative purposes it is. Maybe I think as the time passes, more and more things might be different.
Time is very important for this. So I think these particular sessions were very good, Dr. Raman. and most of the speakers like Dr. Gaurav, like Dr.
Excellent,
Mahajan,
sir.
like Dr. Harris, like Josna, they were all excellent.
Excellent speaker, sir. And they did full justice to their talks. Excellent. Really thankful from HISI side, sir. Very well conducted also, Sonal and Dr. NP Singh.
Sonal is always she is versatile actually. She can handle any situation. Dr. Sonal?
Very knowledgeable, very versatile, sir.
She is a good doctor.
Thank you, sir. Thank you.
Thank you, sir. Thank you, organizers.
Thank you, all of you. Thank you. Thank you so much.
Thank you so much.
Thank you, speakers, for your wonderful slides and presentation, and the panelists for your time and attention, and all delegates. Thank you.
Thank you, Dr. Khan.
You just have
Namaste, sir. I saw Shashank, Dr. Shashank Kale somewhere for a minute and then I think it went off. Oh, he must be watching कि वो आ रहे हैं हम लोग या नहीं अभी. So, Dr. Fatima. Hi, namaste.
Good evening. Good evening.
Good evening. Namaste, namaste, namaste. Dr. Fatima?
Assalamu alaikum, and a very good evening to all the dignitaries, teachers, seniors, and colleagues. A very warm welcome to the inaugural function of the 17th Annual Conference of the Hospital Infection Society, India. Let us start off the function with a recitation from the Holy Quran by Dr. Manazir Athar, Professor from the Department of Anesthesiology.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم اقرأ باسم ربك الذي خلق خلق الإنسان من علق اقرأ وربك الأكرم الذي علم بالقلم علم الإنسان ما لم يعلم صدق الله العظيم. In the name of Allah, the most gracious and the most merciful. These are the verses from chapter number 96, the clot. The Almighty says, proclaim and read in the name of your Lord and cherisher who created man out of mere clot of congealed blood. Proclaim, and thy Lord is the most bountiful. He who taught the use of the pen, taught the man which he knew not. Thank you.
Thank you, sir. The Hospital Infection Society India, Aligarh chapter is proud to organize the HISicon, which has seen an amazing response and is hosting many respected dignitaries from around the country. In particular, I would like to welcome our chief guest, the Vice Chancellor, Aligarh Muslim University, Professor Tariq Mansoor. I would also like to welcome our two orators, Dr. Shashank Kale and Dr. Priya Ibrahim. Also, the President, Hospital Infection Society India, Dr. T.S. Jain, the Secretary, Hospital Infection Society India, Dr. Raman Sardana, Dean, JNMCH, Professor Rakesh Bhargav, Principal and Chief Medical Superintendent, Jain Medical College, Professor Shahid Ali Siddiqui, the Organizing Chairperson, Professor Haris M. Khan, the Co-Organizing Chairperson, Professor Tamkeen Khan, the Convener, Professor Syed Mueed Ahmed, and the Organizing Secretary, Dr. Fatima Khan. I would like to request Professor Haris M. Khan, sir, the Organizing Chairman, to please give the welcome address.
Professor Tariq Mansoor, Honorable Vice Chancellor, Aligarh Muslim University, and the Chief Guest, Dr. T.S. Jain, President, HISI, Dr. Raman Sardana, Secretary, HISI, Professor Rakesh Bhargav, Dean of the Faculty of Medicine, Professor Shahid Siddiqui, Principal and CMS, Jain Medical College, Professor Tamkeen Khan, the Organizing Co-Chairperson, Professor S. Mueed Ahmed, the Convener, Dr. Fatima Khan, the Organizing Secretary, Dr. Shashank S. Kale from AIMS, and Dr. Priya Abraham, the Director of NIV Pune, dignitaries, and participants. Good evening, everyone. At the outset, I would like to welcome all the participants and all the dignitaries to the 17th Annual Conference of Hospital Infection Society of India. We are hosting it in Aligarh. We were looking forward to hosting this particular program as an offline mode. And to achieve this particular aim, we had already initiated measures to hold this conference in the offline mode. But unfortunately, due to some reasons, in which we had no control, we had to go on the online mode. Because of the short term we got and the onset of the unprecedented second wave, the time we got was a bit short, as a result of which there may be some shortcomings for which I would like to apologize at the onset. There may be some organization difficulties, because of which some people may have difficulty in presenting the papers or logging on to the program. This particular hospital infection society has been doing a human service for the control of hospital infections throughout India. And we were looking forward to all the participants and all the dignitaries to participate in this particular program in such a way that all of us, we achieve something and something new from this particular program. Around 1,000 delegates have registered for this particular program, and about 700 participants took part in the workshop, which was held on 27th and 28th. At the end, I would like to welcome you all again to this particular program, and we look forward to a successful program, as a result of which we may take some take-home message from this particular program. Thank you so much.
Thank you, sir. I would like to say a few words about Professor Brahm Prakash. Professor Dr. Brahm Prakash is remembered as a doyen of neurosurgery and amongst the greatest visionaries in healthcare in India. He was the first MCH neurosurgery alumnus of AIIMS in 1968. His earlier career was at AIIMS, where he joined as the first senior resident in 1968 and then lecturer in 1971. He served at AIIMS till 1980. In 1980, he joined GB Pant Hospital as professor and head neurosurgery, and that brought GB Pant Hospital, New Delhi, to the most glorious days and scaling heights after heights in the field of neurosurgery in the country under his dynamic and committed leadership. An extraordinary human being with excellent academic and clinical outputs, with many of his students occupying places of pride in neurosurgery in this part of the world. He was well known to take his rounds early in the morning, visiting every admitted patient, and knew everything from history to latest investigations about every patient. Much of his success story revolved around his meticulous observations, innovative techniques, and astute leadership, culminating into some very effective measures to prevent and control healthcare-associated infections by introducing strict OT discipline, surveillance activities, emphasis on sterilization and disinfection, and its quality monitoring, hand hygiene, and antisepsis. The stalwart was a major motivator in the formation of Hospital Infection Society India and served as its past president from 1996 to 2001. His humane side has been witnessed and revered by his students, colleagues, and patients whose life he never failed to touch. So much was his personal involvement. After a brilliant career, this great Margdarshak and visionary of IPC and neurosurgery in India left for his heavenly abode in 2005. This oration thereafter at every Hisicon has been awarded in his fond memory to esteemed surgeons of any stream, pioneers, and doyens in their field in India, who contribute towards the betterment of humanity and serve their patients with zeal, passion, and complete dedication, and known for the utmost application of practices of infection prevention and control, leading to excellent outcomes. I would like to introduce Dr. Shashank Kale, the professor and HOD, Department of Neurosurgery in AIMS. Sir is a member of various societies, ASSI, NSI, NSSA, DNA, SCSI. Sir is also the past chairman of AO Spine India, and he was the chairman of AO Spine Davos Course 2007. He also has more than 200 publications under his belt. Sir, please would you present the Dr. Brahm Prakash oration?
Thank you very much, everybody. Am I audible to all?
Yes, sir, please.
Yes, yes, you are audible.
Okay. Can you see my screen now?
Oh, yes. Yes, sir.
Okay, it says you cannot start screen share while the other participant is sharing. So somebody will have to stop sharing.
Yes, sir. So please start.
Okay, can you see it now?
Yes, sir.
Okay. Good evening, everybody, ladies and gentlemen. I'm extremely honored to be here as to deliver this oration in the name of great Professor Brahm Prakash. The first time I met Professor Brahm Prakash was in 1987. In those days, the MS surgery postgraduate was of 2 years, and the first year before joining MS had to be spent as a house surgeon or a house physician, depending upon whether you wanted to do MS or MD. And I chose somehow, I don't know how, but I chose to do my house job in neurosurgery. And on the 1st of January 1987, I was presented in front of Professor Brahm Prakash. And what immediately struck me was his fantastic personality. He had this big aura, and he used to be called Chief. And we were really overawed in his presence. And today, I feel really honored that I have been conferred this oration, and I am speaking something in his name, in his Professor Brahm Prakash Memorial Oration. And since that time in 1987, I was not only a student of Professor Brahm Prakash, but I can say I was really in awe of his personality. And as I keep telling you in the rest of the story, which I'm going to tell today, how my life was actually shaped by Professor Brahm Prakash. So this was the beginning in 1987. And I would just like to add these two shlokas here from actually it's Sanskrit poetry, and it's beautiful poetry. It says, Adnyanam timirandhasya jnananjan shalakaya, which means Adnyan is ignorance, timirandhasya is the darkness, timir is andhasya is blindness. So the darkness or the blindness brought about by ignorance is dispelled by somebody who puts that kajal of knowledge in your eyes, and that is your guru. And that's what he did. He just dispelled all the clouds in front of my eyes, that what I have to do in my life in the future. And secondly, this is a very famous part of the same Guru Vandana. Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Param Brahma, Tasmai Shri Guru Vena. Okay. So these are some pictures, and interestingly, this picture is Professor Brahm Prakash with his guru, that is Professor P.N. Tandon. Interestingly, somehow fate so conspired that after becoming a student of Professor Brahm Prakash, I then later had to join AIMS, and I became a student of Professor P.N. Tandon. So which was a great fortune for me. Some more pictures about how this is when he was a chief guest and he was honored in one of the conferences of the Delhi Neurology Association. He's lighting the lamp in one of the conferences and sitting down with the other distinguished members of the Delhi Neurosurgical Association. So what happened was, after doing my house job, I thought that, okay, I have to become a neurosurgeon. I have to follow this great man. And so I filled up this form for a 5-year course in All India Institute of Medical Sciences. And that time your employer had to sign the form. So I went with the form to Professor Brahm Prakash that, sir, please sign this form. I want to apply for this 5-year course in neurosurgery. And he said, no, I'm not going to sign it. And I was taken aback that I just didn't say anything. I couldn't say anything. So he said, no, I want you to do MS surgery first. I want you to do MS surgery. I want you to do operations on the abdomen, on the chest, on the limbs, on the thyroid, everything. And after that, you come and tell me whether you want to do neurosurgery, because neurosurgery is entirely different and you will miss out on all this for the rest of your life. I couldn't understand. Anyhow, once the chief had spoken, that was the last word. That was the end of the story. So I dropped that idea. I filled the form for MS surgery. I did my MS surgery. And the day I finished my MS surgery, I was back in front of him. And I said, sir, I finished my MS. So he just looks me up and down and he says, okay, you want to do neurosurgery? I said, yes, sir. He picks up the phone, talks to the medical superintendent of GV Pant Hospital and tells him, Dr. Kale will come downstairs and he will join as senior resident in neurosurgery. That's it. He puts the phone down. And he tells me, okay, go downstairs and join immediately. That's it. And from the next day on, I was in neurosurgery. And here I am today. Such great fortune that I'm presenting this oration in his name. So one of the sayings of Theodore Roosevelt, the ex-prime minister or the earlier president of the United States, was, do what you can with what you have and where you are. And what happened was, once I joined the neurosurgery department in AIIMS, I finished my MCH and I became a faculty. I was lucky enough to become a faculty here. There were such big surgeons here, Dr. Banerjee, Dr. Bhatia, Dr. Mehta, that I was given the responsibility of operating on something which I'd never seen, or I'd seen only a few cases during my residency. And they said, okay, from tomorrow, you're going to take care of the craniovertebral junction. And for me, it was this managing this craniovertebral junction was as difficult as I could imagine Atlas when he had to bear the whole world on his shoulders. And after that, for 3 days a week, every week for years, I was operating on this area, all kinds of things. And then I remembered this saying by Theodore Roosevelt, you try to do the best of whatever you get. At that time, spine surgery was not so much glamorous. There was less glamour in spine surgery at one time, especially from the neurosurgical angle. And I was entrusted this task of managing craniovertebral junction. So I said, okay, I'm going to try and do my best, try to do everything. And one of the first cases which I encountered was this little boy. He was hardly 7 or 8 or maybe even younger, 4 or 5 years old. And if you see this X-ray over here, there is a big soft tissue shadow right here in his anterior to the spine. And there is atlantoaxial dislocation, which you can make out here in this X-ray. And it turned out to be a tuberculous abscess of the CV junction, the craniovertebral junction. And this boy could not swallow, he could not breathe properly, and something had to be done for him. And later on, after dealing with such cases, he discovered that the surgical problems in CV junction TB are many. It is not just one atlantoaxial dislocation. There could be a secondary basilar impression or an epidural abscess or a granuloma leading to cervicomedullary compression. And then we learned how to manage these cases. Another example, this 23-year-old man, apparently healthy, he underwent a neck massage, had severe excruciating pain, and he came to us. He was holding his head like this in his hands. He just could not move his neck, but he was walking. Neurologically, he was intact. And look at his X-ray. You can see there's some gross and horrible deformity here at the C1 and C2. And we offered him surgery. We said, okay, we are going to take this out and we are going to remove the tuberculous abscess. Then we are going to fix your bones. It's a slightly dangerous and a big operation. And he flatly refused. He said, sorry, I'm not going to let you touch my neck. I don't trust you people. This is a dangerous area and I'm not going to operate. I'm not going to let you operate. I was dumbstruck. We didn't know what to do. I said, okay, we'll try and do something for you. So we fixed his neck in a kind of a contraption, a halo vest. That is, the head is fixed to the chest with the help of these rods, as you can see in this X-ray, and started him on anti-tuberculous treatment. And look what happened. We had serial CT scans, and gradually the abscess subsided, as you can see here, and the C2 started reforming. The odontoid process and the C2 actually started reforming. And in a year's time, that is an anti-tuberculous treatment of a year, or maybe a little more than 1 year, he was fine. And then we took off his halo vest and he happily went home without any surgery. So that was my first encounter of having a patient say no to surgery and still getting better, to shake the foundations of my belief that, okay, this is a surgical problem. And then we had this young teacher from Delhi Public School, 30-year-old lady who said, I can't look up when I have to write on the blackboard. And she had this tubercular abscess again at the C2. But this time I was better prepared. I said, if that 6-year-old can get better, maybe she too will get better. We put her on a collar and anti-tuberculous treatment, and she was absolutely fine. Within months, the image on the right is what her craniovertebral junction became. That led me to actually make a proper study. We studied 71 patients from between January 97 to January 2006. We took a detailed history, did X-ray, CT, MRI. We managed all kinds of patients and had to do all kinds of fixation. If you look at this MRI carefully, another big abscess in the front. And if you see this MRI image, the tuberculous abscess goes all around the spine. It's all around. It's in the front, it's in the back, it's surrounding the craniovertebral junction from all sides. One example of what we did. So we had to fix him from the back. And at that time in year 97 or 98, I think this picture must be, we didn't have these fancy screws and rods and all. We used to take a simple Steinman pin, bend it in the shape of a U, and fix it to the guy's head and neck, or a patient's head and neck, with the help of stainless steel wires. And this was what he did. And we made this flow chart of all the patients we managed. And we thought that this is important information. Some pictures of the operations we had to do. Later on, as implants manufacturers became more efficient, they started manufacturing better implants, and we could stabilize the head and the neck in a more efficient and an effective way, better than the crude method of taking a Steinman pin and bending it in a U and fixing it with stainless steel wire. And then we had all these kinds of implants which we used successively. In the end, this whole thing got published in the Neurosurgery Journal, the Red Journal as it is called, a very prestigious journal in neurosurgery circles, that how to manage craniovertebral junction tuberculosis, a comprehensive therapeutic strategy. And this is quoted many times, many places, especially for TB of the CV junction. That led me to manage, once you start doing, people start referring cases and people start getting cases. So one interesting case which was referred to me was an odontoid fracture. And then we read about it, we saw what is being done in the rest of the world, and we discovered that a simple operation of putting an odontoid screw anteriorly in the neck, starting from here and putting a screw, which you can see over here in this image, this works very well. And with a simple single screw, you can fix this fracture and the patient goes home with all mobility of the neck retained. Otherwise, if you fuse the occiput to the cervical spine, his ability to move his neck side to side and nod forwards and backwards is restricted severely. So this was one method of managing it without any loss of mobility. We did a whole lot of them. We tried to compare anterior fixation with posterior fixation. We saw what the complications were. And to my horror, I discovered that after you analyze so many patients, you discover that you have a significant problem. You have this 6.3% redo surgery. So 6.3% of them need a surgery again. And some of them have different problems, dysphagia, or the wire may break. While you are putting the screw, the wire may break, or the malposition of the screw. The screw may not go into the odontoid. It may go slightly outside, and outside is the cervicomedullary junction. So that's dangerous. And the overall failure rate of 8.1% in our hands at the All India Institute of Medical Sciences. And this whole data was analyzed in every which way. And finally, it was published in Neurology India as a surgical management of odontoid fractures at a level 1 trauma center, a single center series of 142 cases, which probably is one of the largest case series in the country. And that's the time I realized that you have to talk about your complications. You have to look at your complications. You cannot just say that, okay, I have no complications. Because if a surgeon says that he has no complications, there are only two inferences. Either he's not operating or he's lying. There is no other way. Everybody has complications. And you have to look at them, you have to analyze them, and you have to improve yourself based upon your analysis of these complications. The third part of the CV junction problem which I saw was the vessels. There is this vertebral artery which runs into the cervical spine inside the bones. And then it has this funny course between C1 and C2. It makes a loop and it enters the skull. And in these injuries or inflammations or tumors of this area, these vessels somehow get affected. And this led us to a different set of problems in patients. There was a young man who came to us, a 16-year-old person with a stroke, with some part of his cerebellum was infarcted. And we were wondering, why should a young person, 16-year-old, have stroke when all the other risk factors of stroke are missing? So we said, okay, we'll first get an angiogram done. Let us see what is happening. And while the angiogram was being done, we discovered that, well, there is a CV junction problem. This is the C2, this is the C1. There is an atlantoaxial dislocation. And the radiologist was quick enough to pick that up. And he completed the examination while getting the neck stabilized, and he discovered that one of the vertebral arteries is completely blocked off when the patient turns his neck. So that's how the vertebral artery gets affected. It led to thrombosis. It led to an infarct in his cerebellum, which led to a big problem, a stroke in young. So this was a new thing for us. This was a new presentation that a trauma to this area can also present as a stroke. And the way to fix it was by doing a transarticular screw fixation or a modified galley fixation. And it worked very well. He gradually recovered. Cerebellum and some parts of the cerebellum are quite forgiving. And the patient over time learns to overcome his disability. And he was walking quite steady and using both his hands equally well at the end of the treatment. And then we analyzed these patients as well. That has craniovertebral junction anomaly been overlooked as a cause of vertebrobasilar insufficiency? We actually looked at a whole series of patients, and this was published in Spine, which is also a very respected journal in the year 2006. And how we did that was we did a SPECT scan study, perfusion study of CV junction problems. And that led me to, if you saw the first slide where I'd kept the title, it was, it had a wishbone in the title. So what is a wishbone? A wishbone is this bone found in birds, which is actually both the clavicles of the bird are fused together. And it's called a furcula. And this makes the birds fly. So why is it here? Why is it the furcula here in this top? Because you need some luck as well. In surgery or in medicine, when you're treating patients, you need to have some luck. And this bone was called wishbone, so that somebody who had this bone was granted a wish, and his wish came to be fulfilled. And that is by having a wishbone would make a person very lucky. So that is what happens with the wishbone. But how is it important to me? If you turn the wishbone around, it makes a letter Y. It is that perfect letter, the wishbone. It is that fork in the road. Which way to go? Do we go left? Do we go right? Do we stop here? You can take it as an empty wine glass, or you can take it as the question, any question which we ask over and over. And as physicians and surgeons, We have to ask ourselves these questions, tough questions regarding management, regarding the best practices, regarding making patient outcomes better. So this fishbone is very important for us. Another aspect of craniovertebral junction, this young male, neck pain, difficulty in walking, all this clinical examination, and look what happens in his x-ray. When you see this x-ray, you see something horribly wrong over here. You know that there is something wrong here. The alignment of the cervical spine is not correct, something wrong. And then we went on to scan the rest of his body. We saw that he had other lesions in the spine, in the pelvis, everywhere, in the cervical spine. And finally, we did a posterior fixation operation on him, and he did fine, he did well. And while doing this operation, we did a biopsy, and the biopsy turned out to be, I think this was an eosinophilic granuloma. Yes, it was. It's a local disease of the bone, and it affects the skull mostly, but it can affect the spine as well. And this was a new thing for me. And so we tried to look at all the tumors which we could find in the CV junction and how they are managed. Another tumor, C2 body. If you see this C2 body is completely tumorous. The odontoid process, the lateral masses, the posterior elements, every part of the C2 vertebra is involved. And this turned out to be a plasmacytoma. The plasmacytomas are derived from plasma cells. And our plan was to do a transoral decompression of the tumor and a posterior fixation, that is an occipito-cervical fixation. That's what we did. We tried to remove the entire tumor. We removed it, and posteriorly we fixed the occiput to the cervical spine. And this young girl, she was a pretty looking girl. Now she's about 6 or 7 years follow-up we have, and she's doing fine. She's doing all right. The tumor has not recurred, and she's doing all right. Then there were some problems which had bony as well as soft tissue problems, you know, the cervicomedullary junction as well as the bone. So here we have a basilar invagination with a Chiari malformation and a syringomyelia. You can see the cervical and the dorsal part of the cord is full of water. It's syringomyelia. So he has a bony problem and a soft tissue problem. And to our horror, we discovered that there are many such patients. And this was another series which we looked at between 2005 and 10. And we discovered that, well, sometimes you have to do both anterior and posterior surgery in them. Posteriorly, you can see these are the cerebellar tonsils. This is the dura opened at the neck. And you have to resect these cerebellar tonsils and to repair the dura, make space for the CSF, and the syringomyelia would magically disappear after you fix the cervical spine. And the fixation of the cervical spine, earlier we used to do as I described with the Steinman pin and stainless steel, and later on we had some better implants with plates and rods. And the lessons we learned was that these are problems which can have a soft tissue as well as a bony component, and you need to tailor the treatment to the patient. Somebody will need anterior surgery also. That is what we learned from these patients. Here is an example of, this is a pre-op MRI which shows the basilar invagination and the syringomyelia, and the post-op where the basilar invagination is gone and the syringomyelia has almost completely disappeared. So what I learned was that you need a balanced backbone. The backbone needs to be balanced, and basically it's just like, you know, we used to play this game when we were children, putting these 7 stones one on top of the other. That's exactly what the cervical spine is. And the top 2 vertebrae are the most crucial. They bear the weight of the head, which rests on top. So the balance of this cervical spine has to be perfect. You have to get it in balance. And all these operations which I had been doing, or our unit had been doing, was basically to restore the balance of this cervical spine. Here is an example. A young girl, again, CV junction problem. But with that, she also had a deformity of the lower spine as well. A 94-degree curve in the thoracolumbar spine with a CV junction problem. And we had to stage her treatment, did the neck first and then the thorax. And this is what she looked like. We did put a magic rod. This used to be called a growth rod. As the child grows, you expand this rod, you make it longer. This rod gets longer and longer. So a series of operations every year is needed. till the child attains her normal or his normal height. And that's what we did with this growth rod. We kept following her for a few years, and now she's a very pretty young girl. And this was what her post-op ultimately looked like, with a straight back. You see the beautiful smile on this, on her face. This smile struck me, and I kept her picture. Now she's more than 20 years old, and her smile is as beautiful, or probably more beautiful than what it was when she was a young girl. And I remembered this smile, and I will get this smile to in the end of my talk as well. So this was what we did. And then once you do these deformities, the patients start coming one by one. Here is another patient, Marfan syndrome. Now, such a rare problem, but a Marfan syndrome can have all these signs, and all these are clinical signs of Marfan syndrome. But he also had a horrible deformity of his spine. If you see, the upper part of his cervical spine is horribly deformed, and one vertebra is pushing in and pressing on the cord. And this is something which we had never encountered before. And well, we thought of an innovative way. We went from the back first, we put in all the screws, we came in from the front, we did the corpectomy of this vertebra which was buried inside, and then we went back from the back and completed the fusion procedure. And this was what it looked like in the end, and he did quite well. This is the gentleman. Marfan syndrome people are very tall. His height is, I think, 210 centimeters now. And if you look at this picture, this is my resident standing behind him with his hands holding the patient's hands. And he was really tall. And after the surgery, now it's 7 years post-op, and he's done well. He's put on another 10 centimeters of height. And immediately after some time, we had another deformity of the cervical spine, where this time there were 2 vertebrae buried inside. And he also had valvular disease of the heart. So we did the same kind of procedure. You can see these 2 vertebrae are buried inside. The C2 is touching the C5. Horrible deformity. Lot of deficits in this patient. And we did the same surgery, back, front, back. Go from the back, come from the front, do the corpectomy, put in a cage, stabilize with a plate, then go from the back again and complete with this. Complete the procedure with the rods. And he too did well. And finally, I want to present this lady who came to us, I think 3 or 4 years ago. And she said, I just can't look up. Her chin was resting on her chest, and she just could not look up. And she says, my children, they are growing, they do this, they do that, and I'm unable to see anything. I cannot see in front of my eyes. I don't know where I'm walking. So this was a chin on chest deformity. This was all her parameters which we studied. And when we did her x-rays and CT scans, the deformity was such that we could not make out much. It was difficult to imagine exactly which vertebra is where. So we actually made a 3D model, a 3D printing of the model of her cervical spine to understand what her deformity is. Then we thought, how am I going to operate her? We tried to take her to the theater. We did a mock drill. Maybe we can do under image guidance. We put her in the O-arm. But you see, it was impossible to put her in a position where we could operate comfortably. And in the end, the only position we could manage was this. If you see on the image on the right, it was kind of a sitting because she just could not straighten up. This was the position where we could manage. Her chin is touching her chest, and we operated only from the back. This was what we did. Removed a wedge of this cervical vertebra, all these posterior elements and the body, and then it kind of collapses on itself with joints like this, and the neck becomes straight. And that's exactly what we tried to do. Take off all this, the shaded yellow part, curate it out, curate out the body, see all the roots, make sure that all the roots are fine and the patient doesn't have any deficit. And then we just break the cortex of the vertebral body, and the head snaps back immediately. And you can see this picture where one of the residents just put his hand under the chin. They were so thrilled to see that, my God, her head has become straight, and he could put his whole hand under the chin. And there was a lot of commotion in the OT at that time. I remember there were about 60, 70 people come to the theater to watch this surgery. Anyhow, we completed that surgery. We went on to complete the procedure by fixing her head to the thoracic spine. And this is what her ultimately outcome was. If you can see the image here, her chin is kind of touching the chest, and the angle of the neck and the thorax is this. And ultimately it became this. And she started looking up. and she was really happy. And she was happy of the fact that I can just see again. You know, people, we were here trying to get her spine straight, get her balance, this, that. Her main problem was I can't see in front of my eyes, and I'm very happy with this surgical result. I can see in front of my eyes. I can see my family. I can see my children. We told her your surgery is incomplete. I told her I need to do another procedure. Your neck is rotated. I need to correct. She said, I'm not coming back to you. I'm not coming back for any more surgery. I can see my children. I can see in front of my eyes. I'm happy. I'm not coming back. And now it's, I think, 6 years out of the surgery. She's doing fine. And she turned out to have ankylosing spondylitis, and she has problems with other joints, but right now she's walking and she can look in front of her eyes. So what happens is many times we get lost. We get lost in many things. Oh, we become narrow visioned. We look at only patients, or we look at only pathology, or we look at only work, or we look only at the career. But it's not that one of these directions, I mean, life is not like this, which you see here in the picture, that if you take this road, you can't go down this road. It's not like that. It's more or less like this jigsaw puzzle, where you have to balance everything. Just like I learned to balance the spine, I also learned to balance everything. You have to balance the life, you have to balance the family, your career, your work, everything needs to be in balance. And once you have that balance, that will lead to a happy life. And for a balance, the way I do it is I balance the spine. You balance somebody's spine, his balance improves, and his balance improves, your balance improves, and you become happy. And then you slowly climb all this ladder to self-fulfillment needs and self-actualization. So you balance, and the backbone is critically important. With the balanced spine, you can do all these things. So you need that balance. You need that backbone with a balanced spine to actually help you achieve what all you want to achieve in your life. So we talked about the wishbone. We talked about the backbone. Now there's another bone which is called a funny bone. A funny bone is that ulnar nerve which hits at the elbow, makes your arm tingle down the forearm and up to the hand. But the funny bone here I refer to is a humor. You should look upon yourself. You should crack some jokes. You should look at yourself in that humor angle. You should not take everything very seriously. There will be some setbacks. There will be some ups and downs, but you should not forget ever that beautiful smile which you get, whether the patient is a young child or that lady who just wanted to see her children grow up. So that's the funny bone I'm talking about, that sense of humor. You know, this patient was so happy. She was so happy. She had this massive problem, Morquio syndrome. And this lady had ankylosing spondylitis, and all her joints are kind of fusing one by one, but they never lost their sense of humor. And that's why I learned that to thrive in life, I need these three bones: a wishbone to be lucky, a backbone to be balanced in life, and a funny bone to always smile and to see the good part of life. Thank you very much for your attention.
Thank you, sir.
I take a time, just a second from the mistress of ceremony, please, if you allow me.
Yes, sir.
Can we have something like a standing ovation? We can't actually be on the physical platform, but a standing ovation to Dr. Shashank Kale for an excellent delivery.
Thank you very much. Thank you. I'm deeply honored. I'm deeply honored.
I wish you would have added on the family angle also.
Yeah, it is very important. It is very important.
Well, what Dr. Brahmprakash did to you on personal front is tremendous. He did the same certain things for me also, but I think, yeah, very, very personal. What a human being.
Great man. Great man.
Back to you, ma'am.
Yes, sir. Thank you so much, sir. This was indeed a very interesting and educational presentation. Let us move on to the Dr. Ajita Mehta oration. Dr. Ajita Mehta was amongst the founder persons of Hospital Infection Society India and served as its president from 2001 to 2006. She also founded the HISI Mumbai chapter forum in the late 1990s. Known all over the country in the field of infection prevention control and clinical microbiology for her indomitable spirit, dynamism and warmth, compassion and generosity, courage and outspokenness, Dr. Ajita Mehta graduated from Nagpur Medical College in 1966 and completed her DPB in 1973 and MD Pathology and Bacteriology in 1974 from the St. G.S. Medical College in Mumbai. She was an educator par excellence and a well-adored teacher. She established excellent standards for diagnostic microbiology during her illustrious academic tenure from 1969 to 1989. She joined the Hinduja Hospital, Mumbai in 1989, where she served as consultant microbiologist and chairperson of the Infection Control Committee till her retirement in June 2008. While at Hinduja Hospital, she aggressively indulged in activities from surveillance and waste disposal to hand hygiene and needle stick injury prevention with a zeal that was unmatched. Subsequently, she took up the chair of Infection Control 2008-2009 at Nanavati Hospital in Mumbai. She was a visionary microbiologist and infection control professional who understood the importance of daily interactions with the clinicians and bedside microbiology for optimizing the care of patients with infectious diseases. She was one of the first microbiologists in the country who actually took microbiology from the bench to the bedside. Dr. Mehta was a pioneer in anaerobic bacteriology and healthcare infection control in the country. This oration is awarded in her fond memory every Hisicon to a renowned clinical microbiologist who have served the humanity and the nation through pioneering and exemplary work in the application of clinical microbiology in infection prevention and control and antimicrobial stewardship in the community and in healthcare institutions. Please allow me to introduce Professor Priya Abraham. Professor Priya Abraham was the earlier HOD of clinical virology at the Christian Medical College, Vellore. She took over as the director of ICMR, National Institute of Virology, Pune on November 18, 2009. She was invited by WHO to serve as a team member in the formulation of detection and prevention of HBV and HIV infections. She was also part of a WHO external team to Sri Lanka for assessment of the country's national plan in HIV/AIDS in STI in September 2017. She has served as a scientific advisory committee member to the ICMR virus unit at National Institute of Communicable and Enteric Diseases, Kolkata. She was part of a national task force to outline the molecular epidemiology of HPV infections in India. She has more than 164 publications in peer-reviewed journals. She has also been keenly involved in outlining the syllabus and training program for Doctorate of Medicine, which is the MD, in virology, a specialty that is the need of the hour. She has also led the scientific team at ICMR NIV in several facets of COVID-19 work, diagnostics, including assay innovations, kit validation, serological assay, and trials related to an indigenous vaccine also. I would now invite Professor Priya Abraham to please present the Dr. Ajita Mehta oration. Ma'am, please.
Good evening, everybody. And I am indeed very honored to be given the opportunity to deliver an oration in memory of a very, very passionate microbiologist who was a larger-than-life figure, very large-hearted, whose name is synonymous with hospital infection control, also known for her leading contributions to the discipline of anaerobic microbiology. And I remember my first interaction with her as a postgraduate trainee. I had gone to Hinduja Hospital for one of the meetings on hospital infection control. And, she was so full of passion in the way she conducted that meeting. And, I felt like I had met a star because when she actually took notice of me, a lowly postgraduate trainee. And when she came over to Vellore on a meeting when I was just finishing my training in Vellore, and she remembered me, I thought I had hit the jackpot, because she was really one of those leading lights in the discipline of microbiology, where the importance of hospital infection was coming very much into the forefront, and where microbiologists were now beginning to be taken very seriously as far as clinical management was concerned. So having said that, let me just, I think my slides are focusing somewhere else. And let me go to my first slide. And I once again thank the organizers of Hisicon to have given me this extreme honor to deliver this oration in this pioneer's name. So my talk is going to be really my tryst or my journey with a virus known as human papilloma virus. And I still remember in the early 2000s when my mentor, the late Professor Gopalan Sridharan, told me, Priya, would you like to work with HPV? And I kind of knit my eyebrows and wondered, well, isn't that the virus that causes those yucky warts? And I was thinking, why would you want to hand this out to me? I was quite happy in working in my domain. And there began my journey. And I look back and I feel that this journey has taught me many techniques, has given me the opportunity to interact with very renowned clinicians, laboratory specialists, made me travel the world and mingle with other populations, be it South Africa to Canada to Australia, and meet some of the biggest experts in the world that have really taught me what being an open-minded scientist should be. So having said that, I will go on to give you the outline of what I'm going to talk about. I'm going to be talking a little about the classification of HPV. I know we are switching track from this wonderful, enthralling lecture where Professor Khaled gave us his account of his life of life-transforming surgery. And I love the way he ended with the right attitude to life in general. So I will start with how I journeyed through this particular area of HPV virology, talking about the classification of the virus, a little about its biology, the molecular epidemiology of this virus in Indian women with cervical neoplasia. What were the prognostic markers I picked up on the way? Did HPV do worse in those who were immunosuppressed, particularly HIV infected? Its role in malignancies or tumors in non-cervical sites. I forayed also into trying to develop cost-effective and patient-friendly methods of screening. And finally, I will sum up. So just for those who are probably starting off like how I started almost 20 years ago, this is a virus that is well known to most of you to cause a variety of warts, plantar warts, palmar warts, other skin flattened warts, the common wart, but it also causes lesions in the genital mucosa because of certain types of HPV that could be resident there and establish persistent or transient infection. So when it sets up persistent infection, particularly with certain high risk or oncogenic types, such as HPV 16, 18, 31, 33, 34 that you see there, it could lead to a high grade cervical intraepithelial neoplasia. It could even be low grade depending on when you have managed to screen this lady. It is also incriminated, apart from cervical cancer, in anal, penile, vaginal, vulval, and oropharyngeal cancers. There are some HPVs that are typically described as low risk, and these are the types that cause either low-grade squamous intraepithelial lesions, or they cause the typical genital warts, which are very disfiguring for the individual. And it is type 6 and 11 that is incriminated in over 90% of them. And it is these very same low-risk HPVs that cause the recurrent, benign recurrent respiratory papillomatosis in the newborn. So there's another way to classify these HPVs depending on their ability to cause cancer, their oncogenic risk. And I have classified them for you into high risk and highlighted 16 and 18, which are by far the biggest villains, followed by those that have probable high risk and the low risk that cause mainly genital warts, of which the best known are 6 and 11. Now, HPVs, you would be surprised, are more than 100. Actually, if you count even the non-human HPVs, we would probably be bordering on 200 different types of HPV. But the genus of HPV that we would be concerned with is what belongs to this genus called alpha papillomaviruses. Some also belong to the beta, but all these are really not too much of our concern. Now, a little about the genome to get familiar with it, because this is the very backbone of diagnosis for looking for this virus. This virus does not grow easily in cell cultures. So it is not easy to detect the virus unless you take a molecular approach to detecting this virus. It quietly, stealthily does what it does, which could lead to cancer, especially in women, causing cervical cancer. But the best way to screen it is to look for the viral DNA. So this virus really has genes known as early genes and late genes. The late genes are known as L1 and L2, but these genes basically code for the capsid protein, the outer protein of the virus. And the early genes have different functions. E1 has a role in replication, E2 in replication and transcription, E4 with the virus release from the infected mucosa, E5 has some role in evading the immune response, and E6 and E7 are otherwise known as oncogenes. They are known to actually bind with tumor suppressor proteins such as P53 and the PRB tumor suppressor proteins. And these are one of the mechanisms that permit progression to cancer. So if I were to pictorially show you here, how does this virus actually get to infect a woman? So the virus actually gets in where there is a breach in the mucosa. It tracks its way right to the basal layer of the cervical epithelium, particularly at the squamocolumnar junction. And once it gets into the basal epithelial cell, it develops a productive infection wherein the virus is mostly episomal in nature outside the nucleus of the host cell, but making more of its own. And as these cells undergo differentiation and reach the top of layer of the epithelium, these viruses are extruded, waiting to infect another host. As you know, HPV is the most common sexually transmitted agent today. So in somebody who is indulging in sexual activity with a partner, yes, these extruded viruses could actually infect the individual's sexual partner. Now, occasionally, these viruses, instead of working towards the top and producing the late proteins, the L1 and L2 proteins, and getting extruded from the surface, they develop an overexpression of the oncogenes, namely E6 and E7, and the virus slowly gets integrated into the individual host cells within the epithelium. And you can see here the grade of cervical intraepithelial neoplasia goes slowly from SIN1, SIN2 into SIN3, which is like a point of no return, where the individual without clinical intervention can actually proceed to invasive cancer, where the virus breaches the basement membrane of the epithelial layer and can spread and cause metastases. The same concept described for you here is the natural infection, showing you how when a person gets infected for the first time, the first lesion takes about a few weeks to months to develop. The person then becomes DNA positive. If the immune response is good, actually 80 to 90% clear the infection if it's a low-risk HPV within as early as 4 to 9 months. If it's a higher risk HPV, possibly in 1 to 1.5 years, but a smaller proportion of individuals under other cofactors like immunosuppression or heavy use of oral contraceptives, other STIs, sexually transmitted infections, even a genetic predisposition, would then actually progress to persistence of the virus in the epithelium, proceeding from SIN1 to 2, 3, and then possibly invasive cervical carcinoma. So how would you screen for this virus? It's there in the basement membrane. Well, this is done by actually swabbing a woman's, following a pelvic examination, which is the traditional way a woman would be screened. You swab the woman's, the surface of the cervix with usually, today what is preferred is a Kolpan swab or a Christmas tree brush. And once you swab the surface of the cervix, you can actually perform two types of assays. One is known as a signal amplification assay, where you use a method by which the DNA in the clinical material is artificially amplified by amplifying the signal from the specimen, or the target DNA is actually amplified using PCR technology. One of the best known methods is the hybrid capture method, the first of the FDA approved assays, which is has been used widely over almost the last 2 decades. And among the target amplification or PCR based methods, one could go on to genotype to actually identify whether you have the high risk HPV in the specimen, which would determine the further plan of action from the gynecologist's end of things. There are a whole slew of assays here that can be used to detect not only HPV, but the specific genotype. And some of the assays not just pick up HPV DNA, but the last assays here mentioned, shown in yellow tinge, are those that can detect HPV mRNA or HPV transcripts, which suggest that the virus is actively replicating in the cervical tissue, which would have a higher specificity and indicate that this could progress to more advanced lesions. So I showed you some of the assays that are possible. And over the next segment, I'm just going to tell you some of the assays we worked on. This was the hybrid capture, where basically the DNA is denatured in the clinical specimen, allowed to hybridize with high-risk genotype-specific RNA probes. This hybrid of DNA and RNA is captured on a microtiter plate, and then RNA-DNA hybrids are detected by another set of antibodies. Then a second set of antibodies with alkaline phosphatase is added. And then when you add a substrate which is capable of giving a chemiluminescent signal, when you add substrate, this enzyme acts on substrate to give this chemiluminescent signal, which is captured in a machine known as a luminometer. Most of the PCR-based assays target actually the L1 region or the E6, E7 region. The E6, E7 is this region and the L1 region. And there are several primer sets which amplify different lengths of genome, as you can see here for the L1 region. Now, one of our very early assays that we did, and this is, I'm going back to maybe 2003, was today what one might call a very, archaic assay, was to actually do a PCR RFLP assay, wherein the PCR was, sample was amplified, was extracted from the clinical specimen, and then the amplified PCR product is digested with a set of restriction endonuclease enzymes, which cleave the amplified product at distinct regions depending on the genotype, because each genotype has a slightly different genetic sequence. So the area where these restriction endonuclease enzymes would cleave the amplified product would vary with the genotype. And then it's run in a gel, as you can see here, this cartoon here. And this is a gel picture of actually HPV-16, perhaps the most oncogenic HPV known today. And here actually the PCR product was treated with 8 different restriction endonuclease enzymes, and you can see the characteristic pattern that is unique to HPV-16. We also went on to do a fairly cost-effective assay, but cumbersome. It's called a direct hybridization or dot hybridization assay, where the extracted DNA was amplified, blotted onto a nitrocellulose paper, washed, and then you add specific genotype probes that are biotinylated, washed, and then you add a substrate which gives a chemiluminescent signal. The strength of the signal and the position of these signals, which are as per a grid, helps you to identify one by position which genotype it is, as you can see here, and the strength of that signal, as you can see, this gives an intensity of 4, whereas this is read by 2 different people independently, and one has given a score of 2 and 1. So you have a semi-quantitative idea of the strength of signal and also which genotype we are dealing with. Another assay, which is the format for many commercial assays, is the opposite of the direct hybridization or dot hybridization. It's called the reverse hybridization assay, wherein the DNA is amplified using a biotin labeling as well. We also amplify a housekeeping gene. Remember, whenever we work with DNA, to know whether there's enough DNA in the clinical specimen, 2, whether the PCR was actually run under optimum conditions, we always have a housekeeping gene. So here the housekeeping gene is beta globin. Even in the previous assay, we had beta globin as the housekeeping gene. In this assay, beta globin is also co-amplified. And to cut the story short, after amplification and denaturation, the amplified denatured products are added to a nitrocellulose strip that has a number of different genotype oligonucleotides put onto this. It is actually blotted as strips like this. It's probably not visible here. And then using enzyme conjugate and substrate chemistry, at the end of it, you see, depending on what genotype is there, you would see the specific genotype lighting up. And this is how this particular assay, known as the linear array, would look. These are individual strips of a patient. These are the housekeeping genes. And you can read off what genotype the individual has by looking at this grid. You can see this patient has got HPV-16. This patient number 12 has got HPV-18 by reading off here. And some individuals may have multiple HPV types, as the case may be. And you know, today, most of our molecular assays have reached the stage where we work with real-time PCR, which allows us to not only quantify, but or even semi-quantify, and also detect genotypes in addition. So those were the slew of assays that I standardized along with my colleagues, my students, particularly, who have been a huge help to me, and along with collaborators who held our hands while we developed these assays right from scratch. We then went on to look at, is HPV a big deal in cervical carcinoma? And one of our early studies, which was in 2000, published in 2006, we looked at around 130 odd women with cervical cancer, 11 of whom had stage 3 cervical intraepithelial neoplasia. And we found that, yes, among these women, the HPV-16 was the #1 culprit among women with cervical cancer. 60% of the women had HPV-16, followed by 18, and then other smaller representations of HPV-31, 35, 45, 52, 58, 56, all of which are oncogenic types. Some of these were also non-oncogenic types as we examined these women. This was a wonderful multicentric study where, in addition to Vellore, where I worked, we collaborated with labs from Delhi, Bengaluru, Mumbai, Kolkata, and Trivandrum. I have made some of the best friends in my journey with colleagues from these centers. And our findings were that, irrespective of which center it was, at least almost 80% of infections were caused by either 16 or 18. And the remaining, out of the 90+ percentage of HPV positivity in women with squamous cell carcinoma, belong to the other genotypes, namely 31, 33, 35, 45, 51, 52, 56, 58, 68, and so on. And some women, of course, also had multiple infection. I also went on to look at possible prognostic indicators of whether a particular HPV type had markers that would suggest faster progression. And we did actually sequence the HPV-16 from patients with cervical neoplasia. And we found that there was a mutation at the 350 nucleotide position from thymine to guanine, which is associated with a higher risk of progression of cervical neoplasia. And we also looked at the phylogenetic lineage of this HPV-16. And instead of being an American lineage or an African lineage, most of our strains seem to belong to the European lineage. We also undertook a multicentric study, again with the same colleagues, and we did find that, yes, it was the European lineage that was common throughout the country, because amongst us, we represented all the geographical regions, major geographical regions of the country. In addition, we found that in the L1, the gene that coded for the structural protein of the virus, there were a number of variations that could potentially impact not only on the diagnostics, particularly serology and molecular techniques, vaccine initiatives towards vaccine, and future therapeutics. This was a very important finding, and not surprisingly, this got published in the International Journal of Cancer. We also looked at the E2 gene. You remember the E2 gene I had mentioned as one of the early genes that was associated with replication and transcription. It was earlier thought that this E2 gene had a negative feedback on the expression of E6, E7, almost an inhibitory effect. But we found that contrary to this assumption, irrespective of disruption of the E2 gene, there was increased E6, E7 oncogene expression. But we did find that certain mutations in the E2 gene also could impact on the biological function of the protein in terms of replication and transcription. We also had a very unique finding to find that HPV could be detectable in the plasma of patients with cervical intraepithelial neoplasia in patients with cervical carcinoma. Now, normally we all know that cancer cervix starts in a very, anatomically restricted area. And then, of course, if it becomes advanced cervical cancer, it can spread to the lymph nodes and then have distant metastases. So we actually found that in advanced stages of cervical cancer, there was HPV DNA that had got into the bloodstream and could be detected, and it showed 100% sequence homology with the strain that we got from the primary site at the cervix, showing that this probably was part of the, the break off of tumor from the metastatic sites or from the primary area. And this could be used as a prognostic indicator. And this was seen mainly with HPV-16. This is what we published in 2004. But in 2010, we were able to find out that, yes, this phenomenon is true. It's also seen to some extent with HPV-18. We were able to quantify the DNA and, sorry, I think I skipped a slide. We were able to quantify the HPV-16 and 18 from the plasma of individuals who had circulating DNA in advanced cervical cancer. And we found that in as many as 54% of people who had HPV-16 and surprisingly 20% of those who had HPV-18, they had circulating virus in especially advanced forms of this malignancy. We also found that amongst, if we were to measure or quantify HPV DNA and also quantify HPV RNA, in fact, was a better prognostic indicator of advancing stages of cervical cancer. Particularly, we found that correlation with HPV-18, and that quantification of DNA really had no role. In contrast, quantification of mRNA or HPV transcripts did have a role. I was very honored to be asked by one of the dons of cervical cancer screening, Dr. Partha Basu, who today is the head of the screening group in the International Agency for Research on Cancer in Lyon, France. He's a wonderful clinician, very passionate and committed man. He wanted to evaluate the role of a mRNA detection assay, which had just come into the market. And he was sitting there in Lyon and he said, Priya, can you evaluate? We've looked at some women with this, using this assay. Can you validate it against the DNA detection assays you have? Is it better or worse? We would like to know how it performs. And yes, we did find that it had a very good concordance with DNA detection assays. And where there was a discordance, we use an arbiter assay in the form of the linear array, which is the reverse hybridization assay to detect genotypes. Another important area we went into was to detect HPV in HIV-infected individuals. We found that in HIV-infected individuals, they had those who were HIV positive not only had single but multiple types, more than 3 HPV types, and most of them had high-grade lesions, and also many of them had high-risk HPV. Those who had high-risk HPV and were HIV positive typically had multiple infections, and women who had an early sexual debut, less than 18 years, also had many high-risk HPV infection. You can see the spectrum of HPV in HIV-infected women versus non-HIV infected women, which I showed earlier. The spectrum of HPV types are very different. We also looked at HPV and HIV-infected men who have sex with men. These were 300 men examined from Mumbai and Tamil Nadu. And we found that the HPV types they had were very, very different from what we saw among women. In fact, HPV-35 was the big player there. We also examined penile and scrotal infections in the same men, and 54% were positive, for penile or scrotal infection. Anal infection was the tune of 95%. And importantly, this group of men who had sex with men, 51% were bisexual, which means they would be a vehicle or a bridge population who could give infection to women. So this was a very important finding. We also found that oral infection they had to the tune of 23.7%. We looked at HPV non-cervical sites. We found that there are a very low percentage of HPV in penile carcinoma. And in our study, we found when we looked at 140 patients, fresh frozen paraffin-embedded specimens of penile cancer, HPV had a very low role. Likewise, we found that even with oral cancers in India, our findings are very different from Western countries. HPV has a low role. A smaller study done in Vellore, again, HPV had a very low role. In laryngeal cancers, we found that there was about 7.5% positivity for HPV, of which about 1 definitely was an HPV 16. The study sample was very small, as you can see, and therefore this needs further studies in the future. We also went on to look at the feasibility of self-collected vaginal swabs rather than a physician-collected cervical swab. And we found that self-collected samples gave very good correlation with the physician-collected sample and had great acceptance with women. And this today has become the manner of testing world over. This is something perhaps you need to know. We've also looked at the feasibility of examining self-collected samples and urine. Self-collected samples had a better correlation with physician-collected samples. Urine had less association, but of course, urine was very easy to collect and women liked giving that sample. But self-collected is still better than more acceptable for the woman as compared to physician-collected. We did some